Good morning and welcome to Factory Automation Virtual Tour. Thank you for joining us this morning. My name is Natalia Donkov. I will be your hostess for today's event. And here with me is Bernd Reichel. Bernd is a director of product management here at Factory Automation here in the United States, and he is here to welcome you to the event.
Thank you, Natalia. Welcome to everyone out there watching to us, listening to us today. Thanks to everyone from the US and also from Canada and all around the world, really to join us today for our virtual event for factory automation. We are here in Georgia, in Atlanta, sending from our studio. Outside, it's supposed to have more than 90 degrees Fahrenheit, 34 degrees Celsius today. So I really thank everyone to join. I'm not quite sure if it's that hot everywhere else where you're joining from. So I really appreciate, even for it's getting warmer and warmer, that you join us for our event. We got a lot of exciting topics coming up for you today. We will talk about modernization. We will hear from Jake Hall, a keynote, to talk about how to attract the next generation workforce and how to get them excited about automation and going into manufacturing. We will hear about the efficiencies in Tier Portal, how to use Tier Portal, and we will also hear then about Industrial Edge, how to leverage digitalization for motion control, how important security is nowadays due to the fact that more and more devices are connected with each other. And last but not least, we will hear about how Siemens cooperates with education, how we collaborate with universities and colleges throughout the US, really to get today's students ready to enter the workforce into manufacturing, into automation, and be a part of it. After every session, we will have a on-stage Q&A. So post your questions. And in case you miss something, our product managers are around at the booths, so you can also ask questions afterwards.
That's right. And any event is always better when it's a dialogue. So to make this an active dialogue, we really love to hear from you and also encourage you to participate in polls that will pop up throughout the day as you attend live Q&As. And to entice and reward you for your active participation, we actually prepared a couple of prize packages. You see them right now on your screen. And if you attend over 90 minutes of any of our sessions, talk to our experts live on chat, or attend 3 of our live Q&As, you get a chance to win 250 points, which you can convert in basically any gift you want. Do the same, but only one live Q&A. You can win up to 100 points. And if you just attend a session and hang out for about 90 minutes or so, you can get 50 points. So those are the prize packages. We'll remind you about them throughout the day. But the main message is make yourself at home and actively participate. And speaking of making yourself at home, because we're live on the virtual platform, we thought we'd give you a little tour so you knew what was included and how it's structured. So let's take a look at the screen.
All right, let's take a quick look around of our virtual tour platform. Once you click on your confirmation email, it takes you straight here to our homepage. From here, you can navigate to Lobby, which has a rotating carousel of our virtual booth, or you can click on the Exhibitors tab and explore all of our virtual booth by scrolling. You can also narrow it down by selecting a hall, a SAP category, and clicking Submit. Let's take a look at how one of the virtual booths would look like. On the digital rendering of the booth, you see pulsating dots. They represent information, links you can follow, videos you can watch, or downloads available for you. Click on any of it, it'll take you to it. If you click Heart on any of the assets, it gets added to your digital bag, which you can find under My Favorites. On the Agenda tab of our platform, you can find our program for the day by the minute. If you click Heart on any of these agenda items, they get Heart added to your favorites as well, so you can get a reminder that it's time to watch your session. This is where you find the live stream as well. I would like to note that if you watch the live stream in full mode, you will not be able to see polls as they appear. If you keep your screen as it is, as you see it right now, you'll be able to see polls as they happen. Lastly, we have an on-demand video tab where you can check out a couple of videos at any given time. We hope you enjoy.
All right, now let's start and talk about the future of automation. How we as Siemens see the future of automation and what is how we think we can tackle the challenges for the future. Um, First of all, and we saw it throughout the last 2 years and even before, things are changing, customer demands are changing. And we really saw that also throughout the last 2 years. Suddenly, certain products weren't needed anymore. Other products were in high demand. Factories had to change their production, had to adapt, suddenly produce masks, ventilators, and other products that were suddenly in demand and weren't in demand before. And a lot of companies realized how difficult it is to change a production. It's not so easy to change from one product to another product, even though one might think it's kind of similar. So there are a lot of challenges out there, like efficiency, profitability, quality, and we all see that new challenges are coming, new demands are coming, like flexibility was there to a certain degree, and also personalized products. And also sustainability is getting more and more important. In the past or today, companies sometimes build one factory producing one product for everywhere around the globe, delivering the products everywhere from one factory, might be located in Europe or US or in Asia, to everywhere. So now we realize due to trade boundaries and trade restrictions, or also because we have a sustainability pledge, we made a sustainability pledge, that this is not the best approach anymore. We don't need a factory, one factory that produces one product for all the world. We need multiple factories that can produce every product. They can switch from one product to another, basically without any interruption in between, and they can adapt much more flexible to the needs that are out there and to the changing demands. So, how do we want to address as Siemens these challenges? And we see as a as a key part really the combination of a digital world together with a virtual world, with a real world. So we have a digital representation of a product, and we have a real product. We have a digital representation of a machine or of a production, and we have a real product. And the important part is here that first we have a digital representation of a product or of a machine. And when we design the product or we design the machine in a digital world, we can simulate it up front. We can make sure we can adapt to all the different things up front before we actually build a product or before we build a production and a machine. And for that, we have digital twins for a product, for a production, that help us to really build these representations and then really be much faster in implementing new machines. And we had a lot of good examples also during COVID, where companies used this digital twin approach to reduce the number of people they need for commissioning of new factories, to reduce the time they need to for for implementing new factories and to bring new products to market. So we saw now in the last 2 years also there's a huge benefit in it. To a certain degree, it was needed because not so many people could go into a production. At the same time, everyone realized there's a huge benefit and a huge time saving and cost saving using this approach. And by doing so, companies gain much more flexibility, they are much faster, and they are also way more efficient than before. So let's have a look at one example for a digital twin of a product. And this is a really interesting example. It's about a burner nozzle. And again, this product is designed in a virtual environment. And the challenge here is really you have an airflow coming in and the gas coming out of a nozzle, out of a burner nozzle. And in the past, you needed multiple engineers from different disciplines sitting together for weeks and months and really trying to design this nozzle and finding out what's the best way when the air is coming in, that you have as little pressure drop as possible, and that for the overall surface inside, there are no specific hotspots, but everything is kind of under the same temperature constraints and so on. So instead of having multiple people sitting together and trying to figure out a good solution, here in this approach, a computer is running a simulation with all kinds of different designs and is testing every design he's coming up with in a virtual environment. And if it's a good approach when he's going to continue down that path. If it's not a good approach, he is going to reject it and is going to try something else. And by doing so, we can design a product in a virtual world, and we come up with solutions that nobody would think about, and designs nobody would think about if we do the same thing with people trying, basically with humans trying to figure it out on their own. And the same thing is true for production machines. When we look at this example, we have a production machine running. This production machine is already connected to a PLC, to a soft PLC, a PLC simulation, and it's the exact same code that will run later on in our 1500 hardware PLC. So there are no changes anymore. And this simulation allows us to test the different components, to test that the product itself is working, and also see how can we optimize the machine, how can we make the machine more efficient, how can we make the machine faster. And 20 years ago, I would have loved to have this kind of tools at hand, because usually when I was programming machines and doing commissioning, first the machine was looking different to what I had on the drawings before, so I had to adapt all my IOs and everything else, and sometimes also the logic. And of course, it took longer to build the machine than actually anticipated, but the deadline for the customer for the go live of the machine was still the same. So had to hurry up, a lot of long nights to figure everything out and get everything working. And this is a great approach where you really can test the machine up front, and even can test, for example, functions like safety doors to see what happens if they open, and you can also test errors up front and make sure you are ready, and by that you can reduce the time you need for commission. So in this example, we have one PLC controlling one machine. In the next example, we have a whole warehouse and a simulation of a warehouse where we have 15 virtual PLCs running in parallel in the background. So we cannot only simulate one machine, we can also simulate an entire plant or a warehouse, a part of a plant with multiple PLCs like here, where we really have 15 PLCs in the background controlling everything and making sure that the whole warehouse is running. And again, we can take the exact same code as we have here and put this code into the hardware PLCs and the real PLCs, and there are no changes needed anymore for that. Also, when we do the commissioning for this warehouse or for a machine, we can take later on the code again, put it back in our simulation, and by that, step by step, improve the overall operations and can improve the machines further later on also in a virtual world. So digital twins are not only good for planning of a machine, for creating a machine, for designing and for programming a machine. Here's an example where a customer is using a digital twin also afterwards to have it on its fair. To have a digital model of a machine on a fair and show, instead of bringing the whole machine, the customer showed a digital representation to their customers and was able to explain the functionality, and customers could also test the machine. So there was a real panel in front of the display where customers could, and operators basically could test the functionality of a machine without crashing the machine. And it was also very easy for this machine builder to adapt to customer requirements. Customer came up and said, hey, but I want to have a slightly different product running through your machine. Can you do that? And overnight, was possible to change the digital twin of this machine and show the next day to the customer that it's actually possible to build a machine that fulfills the requirements. And so it's also a sales tool and a training tool. It's not just for creating machines and designing machines. It can be used also afterwards for training and validation and to have quick adaptations of these machines. So now we did the simulation, we did the design of a machine. Now our machine is running. And of course, we want to improve our machines and our operations further. And this is where IT and OT and where all industrial IoT connectivity comes in. Collecting a lot of data from our machines, from a shop floor, from a sensors, sending this data to edge, to cloud, And using this data first to optimize our production and also optimize our digital representation of our machines and plants even further, so that we can really close the whole cycle and make sure that we have a continuous optimization of our plant and of our machines. In addition, with industrial edge, we can also take the digital twins that we use for simulation of a machine and run these digital twins or part of these digital twins on an industrial edge device. So we can have a real-time simulation of a machine, of a certain process, and by doing so, we can validate that the actual machine performs like we predicted in our model. If we see some discrepancies, we can adapt to it. Maybe something is going wrong, component is going to fail. So we have an indication that component has to be changed. And we can also use with digital twins, with executable digital twins, to have virtual sensors to get additional information, additional insights, and do real-time optimization of our machines and of our processes. So industrial edge itself is much more than just collecting data. It's also having processing and computation power at the edge, close to the machine, and having the possibility to implement complete new concepts, new processes, besides having the standard control of a machine. So, and where are our PLCs and our hardware coming in? So with TIA today, we are providing the basis for all of the future concepts, for all that you see. We have already a PLC sim running, virtual commissioning is running, simulations, digital twin, everything exists today, and everything is tied back to our automation hardware, to our automation platform as a core of all of it. So we have our 1500 PLCs, we have our 1200 PLCs, we have our unified panels, we have our IOs. All of that is a basis, and all of that can also be simulated in a virtual world. And by that, really combining the virtual world and the real world and being more efficient in the engineering processes and during commissioning. So what's already there? What are the latest features we released? We have OPC UA on our controllers. Every controller has OPC UA. We have an encrypted communication for every controller. Every controller can have its individual certificate. And that's something that's unique in the industry right now, because up to now, controllers usually had like one certificate for every family. Now it's possible to have, with our controllers, to have individual certificates for every controller. We do have openness. We have a lot of interfaces. We have test suites, for example, where you can also test certain function blocks automatically. For example, when you create a function block to read in data from a scanner, you don't need a digital twin for it, but maybe it might be good to simulate a scanner so that you don't have to connect it. And you can have test automation. You can do regression testing. If somebody is changing one function block, there can be automated tests to validate that this new function block is really talking in the right way with the device it's connected to or with the rest of the system. We have a thematic robot library. Robots are getting more and more important in a flexible environment, really to connect all the different elements in a factory with each other. And we have a scalable HMI now within the Unify, where you can run HMI screens on a panel. We can run them on a PC as a SCADA system, and we can also run them in an edge device and basically also in the cloud. And we have the same screens, parts of these screens also available for our PLCs. We can reuse all of the screens, all of the projects, and many different applications. This also saves time and increases efficiency. At the same time, we are connecting the real and the digital world. We have our thematic target Simulink library. We have a Team Center gateway. We have PLC Sim, really to connect the simulations with our PLC programs and make it more efficient. And of course, we are also investing a lot in innovation. So we have Thematic Edge, have been released. Thematic Edge offers a possibility for predictive maintenance, prescriptive maintenance, doing anomaly detection, running live simulation in parallel to your actual machine. And there's more to come. So Thematic Edge is really a big lever to bring in new concepts bring in new programming languages, and really opening up automation for complete new concepts and ideas, how we can increase the efficiency, reliability, the uptime of a machine, and make them also more flexible at the same time without touching the controllers every time. So in the future, we will continue to build on our core portfolio, on Tier Portal, on our PLCs. There are innovations coming. The 1500H system is coming with R1 redundancy. Many more functionalities are coming for our core portfolio, and we will continue to invest in it. Because also we have a huge installed base out there for this portfolio. Electrical engineers know about it, and then this is really the core of our operation today. In addition, we see that new technologies are coming out with industrial edge, with artificial intelligence, cloud connectivity, software controller, new technologies are coming out, and we also want to make sure that we can leverage these technologies also in automation. So that's why we have an additional portfolio, software-defined automation, really to leverage these new technologies, and we tie both of them together with industrial computing, with DIA in the cloud, with WinCC Unify. And for this in industrial software-defined automation, we already have the first product for it. We have for 20 years, we have our software controller running on PCs. We have PLCs with 1500 MFP PLC who can execute C code. We have our 1500 Open Controller running on a ET200 platform, where you have Linux in addition to it, where you can run Linux programs. There will be shortly a 1500 Open Controller coming, where Industrial Edge is running in parallel. So we really combine the worlds, 1500, the PLC functionality, and we also bring in the new functionality with Industrial Edge, with all of the flexibility and all of the possibilities to create new applications and improve the machines and the flexibility of production overall even further. So for today, we talk about modernization, because there's a huge installed base out there, and it's important to make this installed base ready for the future. So we will hear about how can we make this installed base ready, what strategies do we have, what's possible. A lot of people are going to retire, so it's vital that we attract new people coming into the workforce and are also interested in automation. And we hear about ways to do that from Jake. We see how can we really attract new people starting with manufacturing? How do we get them excited about it? We learn about Tier Portal, existing efficiencies you can already leverage today in engineering, in commissioning, and also for diagnostics afterwards. How is Tier Portal going to help you? And we take a next step. So how can Industrial Edge help you in addition? How can we implement new concepts with Industrial Edge in addition to our controllers and PLCs? How is digitalization going to help in motion control? And because we have so many devices now connected, so many edge devices, IoT devices, security is getting more and more important. And we will learn about aspects and approaches. How can you make sure that your factory is secure? How can you make sure that your machine is secure? How can we really make sure that we have all the benefits of these new technologies, new concepts, new architectures, without opening up any holes and any threat and creating any potential risks? Today, Siemens here in the US, we cooperate with more than 600 universities and colleges. And this is vital, this collaboration, to make sure that students get excited about automation and also want to join the workforce for and go into the field of automation. So we work with a lot of universities, and we will talk about how we help professors really to teach these automation classes. What examples do we have, or what highlights, and how we approach it. And a big part of it, of these 600 universities and colleges, is also two-year colleges, really not just to have the next generation of high-end guys looking at new technologies and then trying to improve the concepts even further. with two-year colleges, it's really also about the automation engineers, and it's also about upskilling of the existing workforce to make sure that also today's workforce, people who are interested in automation today, can join and also participate and help in manufacturing, to bring manufacturing ahead. With that, I'd like to close. The next session coming up is modernization. I'd really like to thank everyone. Hope you stay on, and I hope to talk with all of you in the chat, or also see your posts in the live Q&A later on. Thank you.
Hello, and welcome again to the Factory Automation Virtual Tour 2022. And thanks for joining our presentation called Modernize and Integrate Your Automation and Drives. My name is Jim Wilmot. I work at Siemens Industry in Alpharetta, Georgia, and I manage a team that handles all of the marketing and promotions for our Somatic PLC, I/O, and software. And I'm going to give you a very brief presentation on how simple it is to integrate our automation into your existing systems, whether you want to modernize or add on to your plant. And together here today with me is Jackie Stokes from the MC Group. She's going to give you a similar presentation on the drives. Jackie?
Thanks, Jim, and thanks everyone for joining us. I'm Jackie Stokes, and I work for Siemens Motion Control. Today, I'll be talking about how to connect Synamics drives on networks like Ethernet IP with a Logix controller, as well as how to connect to older networks such as Remote I/O and DeviceNet with older PLCs.
Okay, so let's jump into the presentation and talk about some modernization scenarios and a solutions overview of what we're going to show you. So there's three major reasons why you might be interested in this presentation. First of all, if you need to modernize an existing plant. This means you're having current life cycle issues, or maybe you need higher performance in your plant. I've actually seen applications that produce a lot faster once you upgrade a plant due to maybe backplane speeds or networking speeds. Maybe you need some innovations like security or safety innovations that are required for your industry, and you can't get that out of your current product because it's too old. Number two, maybe you're doing an addition to an existing plant. This means you're going to keep your existing controls, but maybe you want to integrate something new. There's a new machine function, or there's a new plant addition, or maybe you just bought some kind of machine from out of the country and it happens to have Siemens on board. How do you integrate that? The third scenario would be maybe you just need flexibility with your network and hardware in general. An example of this would be if maybe you're a machine builder and you have some customers that would like to use for example, a Rockwell PLC. Another customer might prefer a Siemens PLC, but maybe they're open to the different I/O scenarios. So you want to standardize on your I/O or your HMI or maybe your drives, and you want that flexibility to use different networks. So that's kind of the type things we're going to talk about today. If you're in one of those scenarios, this is a presentation for you. One thing I want to say before I start, we do talk a lot about networking to Ethernet IP and a few other networks. We're not going to cover all of the networks that Siemens can actually interface with. So as you can see on this particular slide, we have lots of options with CAN and CAN Open, IO Link, BACnet, KNX. We do lots of different interfaces. That's not really the focus of this particular presentation. We're trying to focus on the masses and what might help you in your plant. So let me show you what we're going to focus on here. Obviously, in the United States, Rockwell has a pretty good market share. So there's a lot of Ethernet IP, so we kind of wanted to focus our efforts on Ethernet IP in this presentation. So as you can see, we have a lot of networking capabilities with Ethernet IP, with our remote I/O, with our PLC, with our HMI, with our drives. There's other components as well, but these are the ones we want to cover today. And I'm going to cover the automation part, and I'm going to start off with the remote I/O on top. So specifically, I'm going to talk about some of our IP20 I/O, which is I/O that actually is mounted in a cabinet like standard PLC and I/O. I also want to talk about our IP65-67 offering, which is a machine mountable type I/O. We have solutions in both these areas to connect to different networks that I think you'd be very interested in. So first of all, I want to talk about the ET200 MFB, which is the multi-field bus, is what that means. This is a fairly new product, so I'm pretty excited about this, and I'm going to focus on this for the majority of my presentation. Now what this is, these are different head modules. that do actually 3 types of protocols. They will work with Profinet, Ethernet IP, and Modbus TCP. So the same hardware works with any of those 3 networks. And as you can see, there's 2 different form factors. There's an ET200 SP form factor, and then there's the ET200 EcoPN form factor. Now, both of these support all these 3 protocols, and both of these support these all at the same time on the same actual cable, which is a pretty cool thing. We also, on the bottom right, you can see a PNMF coupler. So this is what it is. It's actually a coupler that does the same thing. It does Profinet to one of these other 2 networks, if you'd like to go that route. So why would you want to use one of these? Well, let me give you an example. If you're a machine builder and you've got customers who prefer, some of them prefer a Rockwell PLC, some of them prefer maybe a Schneider PLC, some of them prefer a Siemens PLC. They're very heart set on what PLC they want, but they're a little bit open to the I/O they might want to use. So in those cases, if you're a machine builder, you might want to use all the same I/O. It makes it very easy. It's a standard design. You could use the Siemens I/O and use it with whatever controller you like. So that means you'd have no change of the cabinet design, you'd have no change of wiring and test methods, one documentation, spare parts, you have lots of the same spare parts, you have simple service, and a simplified function extension. So this is a pretty big advantage to actually sticking with one I/O platform. So that's one of the reasons you might actually want to use one of these modules if you're actually a machine builder. One thing I want to point out that's reasonably new, these MFB modules, we've been releasing these for about a year now. The basic release came out a year ago and then little pieces of it afterwards. And to make a long story short, it's all released right now. And one of the major functions we released not too long ago was something called shared device. So you can see it on the right side of the screen. And what shared device is, that actually means that we can use all these 3 interfaces on the same cable at the same time. When we first launched this, we were limited to using one of the 3 interfaces. Now we can do all 3. And one of the big use cases for that, I'm showing on the screen here on the right. So we don't do SIP safety, for example, through Ethernet IP. We can't do a safety through a different interface. We have to use Profinet for that. If you wanted to use safety, it would be very easy to add this on. As you can see in the screen, since we can mix our standard and safety I/O in the same rack, you could use your Ethernet IP for all of your I/O, but then you want actually to add safety, you could actually connect up a Siemens PLC with Profinet and do your safety I/O there as well, achieving a SIL3 rating. Now I'm showing a 1500 PLC. Obviously that could be an S7 1200 safety controller. That could be a soft controller. It doesn't have to be a 1500. Any Siemens PLC will work there that performs safety. Okay, and if you don't want to actually use a Siemens PLC, you don't want to use that whatsoever in your plant, you have options for that as well. So on the right side of the screen again, you see using the Siemens PLC for safety. Like I said, using the shared I/O, that's pretty cool, the shared device. On the left-hand side, you can see you can also achieve a SIL2 safety level if you want to use a local safety relay. You could do that as well if you have only a few functions for safety. So you do have a few functions for safety if you want to go that route using one of these modules. So using these MFB modules, how do you configure those? Well, we have a separate tool called the Multi-Field Bus Configuration Tool, the MFCT. This is a separate tool outside the TIA portal. And as you can see on the screen, it actually gives you a topology view of all the devices. It's very easy to configure in just 4 steps. It's integrated project management. Everything is right there, it has diagnostics. It's a really good tool. And we did a lot of pilot testing, and we have a lot of customers using this who give great feedback that this is good to work with. So this is how you actually configure it. It's very simple to work with. But you might say, if I go to modernize my plant, why would I choose Siemens? I mean, obviously other vendors have I/O platforms that have multi-field bus heads as well. Why would I choose Siemens? Well, I want to focus this section a little bit on why you might do that actually. And I'm going to start with the ET200 SP. This is actually a very compact I/O system. It's very easy to work with. It has really nice push-in terminals, tool-free connections, and we have a huge portfolio of devices that go with this. Pretty much anything you could ask for as far as an I/O device. But there's some specialty applications too that might apply to you, where you might want to add this to your line, even if you have an existing line and you need to add some functionality. We have some weighing cards called Swarex. So this is weighing technology used for filling and bagging scales. rotary packers, batch applications. You can see this is really big throughout the industry. It's the bottom of the screen. Pharma, food and beverage, chemicals, steel. This is a really cool card. And note that, again, this is a little tiny ET200 SP card. So it can go in a remote rack or next to the PLC. It's maybe this big in size. It's really small. So this is a tiny little ET200 SP form factor device. And by the way, the slides I'm showing, I always put a QR code in the corner of the screen. If you want more information, feel free to click on that and it'll bring you right to more information. And when you get the slide set later, there's also a link there as well you can just click on. So another couple of specialty cards we have these energy meters. So we have them in a CT and an RC version. Okay, this is pretty cool too. So if you want to measure your energy in your facility, the ET200 SP again is a very small form factor, a really neat addition, something you might use if you want to modernize your plant or add something on. This is something fairly new as well within the last year or so. These are the somatic micro drives. And again, take a look at the form factor. This is ET200 SP, tiny stuff. These are for step drives and for servo drives. There's two different versions here. And they are for speed and positioning of EC motors up to 280 watts and stepper motors up to 10 amp peak. So we really see this used heavily in the AGV area, storage and conveying, industrial applications, just various semiconductor, which should be booming in the States moving forward, medical applications, lab automation, any kind of tiny device, little movement type device you need. This is a perfect application. And again, this is really tiny stuff. This is very compact. It doesn't take up a lot of real estate. More information again at the QR code in the corner of the screen on those if you want to add those on. We also, of course, have an IO-Link master in the ET200 SP form factor. So if you are a customer that uses IO-Link or likes that, it's very easy to incorporate that into an ET200 SP system as well. And that's used in various industries as well, lots of different industries. Another thing about ET200 SP, if you have an application that works in a very harsh environment, say an extended temperature range, maybe down -40 to +70 C, that's extremely cold to extremely hot. That's in ice actually, and that's really hot, 70 C. We can actually do that application. If you have something that's a high altitude, or you have special requirements for the railway industry, anything like that, condensation, high humidity, you have to be able to deal with that. We have something called C+ Extreme. We can actually make any of those cards into a more ruggedized product and we can sell it that way. So if you have an application like that as well, maybe that's the reason you'd want to add Siemens to your plant. We have those offerings in a huge portfolio like I mentioned. So I talked about the ET200 EcoPN also. This is an MFB as well. Now, when I talked about the ET200 SP, this is one particular part number, one head module that did the multi-field bus. With the ET200 EcoPN, this is block I/O. So all of this I/O actually incorporates this functionality. So this is pretty cool that this is actually a firmware update. If you have fairly recent product, this ET200 EcoPN, you can actually download this updated firmware and use this new functionality. And this is really cool. The thing about this I/O, if you've ever held it in your hand, it's very heavy, it's potted. This is to be mounted on the machine, as you can see in the picture I'm showing here. This does not have to be in a cabinet. It's fully waterproof. It's IP65-67, so you can mount it right there. Very small footprint, very easy to mount on your plant. So this is a really cool option again with the MFB as well. So it does all these three interfaces that I mentioned before, and all of them at the same time if you like. So I also showed a picture of the ET200 Pro. Now this is another version of our IP65-67 I/O that's very popular. I can tell you in the auto industry, this is really, really popular. And this is a really cool product line that's also IP65-67. Like I said, machine mountable, just like the ET200 Pro Eco. It's just a different form factor. We also have controllers in this form factor you can buy as well. This is not a multi-field bus. It doesn't do all three interfaces. This actually, we have a head module that does Profinet, and we have a head module that does Ethernet IP. So it's not the same as the others, I just want to point that out, but it does work with Ethernet IP, and it's really a highly used product that we sell for mounting on the machine. This is a really cool thing, so take a look at this. So I also wanted to say a few words about a somatic PLC integration. Because I know from past experience working with automation, Some of the hardest tasks are actually the integration itself and doing this networking and the communications. The actual control project is sometimes much easier than doing the code for the networking, right? So what happens if you want to integrate a PLC into your existing system? If you have a plant full of maybe Rockwell controllers with Ethernet IP and you want to integrate this PLC that's Siemens, maybe you bought it, I don't know for what reason, maybe it was shipped from a machine builder with Siemens, you didn't realize Siemens was on there, or you chose Siemens for some reason. It is very easy to integrate into your existing plant. And let me show you how that works. So in the past, if I wanted to integrate a Siemens PLC together on a different network, it's always possible to do that. You can engineer a solution, you can make that work. Everyone can make that work. And most of us are engineers, we can figure that out somehow. But the point I want to make today is you don't have to try to figure that out anymore. We actually have a new library of controller communication functions. This is a complete library that's already done the work for you. So if you're trying to use your SIMATIC controller as an Ethernet IP scanner, an Ethernet IP adapter, a SIP client, a SIP server, we have a solution for that already can. So it's very easy for you to go in and plug in that work and actually make that communication work. So you're looking at my screen and you see these crazy blue boxes I chose. Why did I come up with these crazy drawings? I actually just cut and paste that off of the Siemens Industry Online Support. This is the actual support site that has these different applications. You can see I kind of cut and paste a screenshot of all 4 of these. When you go to this site, if you look at the QR code here and click on it, when you go to this site, you'll actually get all this information. And this is actually for each one of these 4, you'll get actual documentation how to use it. You'll get a complete library. You'll get even a little project you can start off with. So it makes it very simple to start off and work with. So if you have to integrate a Siemens controller for some reason together on an Ethernet IP network, it's very easy to do using these new functions. So take a look at that if you need that. And also, I don't know if it even needs to be said, obviously our SIMATIC HMIs integrate as well. That is something that is not new by any chance, but I just want to point that out. Our HMI, we do have actual drivers that will obviously work with different networks. So if you're talking about Ethernet IP, Modbus TCP, lots of other Ethernet drivers as well are available. Since I'm focusing on Ethernet IP, I'll just talk about that for a minute. But as you can see, our comfort panels and our new unified panels as well, we have actually the ability to do that and integrate those with Ethernet IP very easily. Up in the upper right, again, you see a QR code. This is actually a tag converter. So you can actually run your L5K files right through this tag converter, and it converts it into something for the TI portal that you can use. It's very simple to work with, so there's no need to worry about, hey, it's not a Siemens controller. Is this going to integrate? Is it going to work? It's very easy to work with third-party networks and controllers with our HMI systems. And just one more slide to show you at the bottom. Again, it is for our new unified panels as well. And on the bottom left, you can see we've got Modicon, we've got Allen Bradley, Omron, SLMP, Mitsubishi. There's lots of different interfaces here. It's not just Ethernet IP. Again, to reiterate that for all the products I mentioned, we have other interfaces as well, but I just tried to focus a little bit on the Ethernet IP for this particular presentation. With that being said, I'm going to turn it over to Jackie to talk to you about Synamics Drives integration.
Thanks, Jim. So now we'll talk about integration of Synamics drives on different networks with different controllers. Synamics drives can easily connect on an Ethernet IP network, similar to the other devices that Jim was mentioning. Today I'll talk about standard performance drives as well as high performance drives, and they're part of the Siemens low voltage drive portfolio, also known as Synamics. Before we get into how exactly we'll connect on these networks, I'm going to talk to you a little bit about the portfolio itself. So we'll start out with the standard performance drives. These are also known as general purpose drives. So we have the Synamics V20. This is just a basic drive, actually no networking capability. But as we move through this portfolio, any text highlighted in green is actually able to connect on both Ethernet IP as well as Profinet. So in the standard performance category, we have the Synamics G120, which is our flagship drive in this category. It's a modular drive, so the power module as well as the control module can separate from each other. And then we also have the G120C, which is a slight variation, but is a compact drive. It is not modular. The next category of drives that we have are distributed drives. These are meant for on-machine applications, mostly conveying applications, but any application where you might need a drive on a machine. We also have industry-specific drives, so this would include the G120X. This is a pump fan compressor drive built for the HVAC and water wastewater markets. It also comes in an enclosed version, and we have an 18 pulse drive for the water and wastewater industries. We also have a variety of servo drives, so a micro drive, which is made for smaller applications, so mobile applications like AGVs. It has a very low power. We have the Synamics S210, which is a simple servo package, and then we have our flagship drive in this category, which is the Synamics S120, and it's also part of our high performance category. So the S120 is most similar to a PowerFlex 755 or maybe a Kinetics 5700. It can be single axis or modular, comes in a cabinet as well if you need it in a cabinet. And then we also have a variety of DC drives. So that just gives you a quick overview of the Synamics low voltage drive portfolio. Some really great things about the drive portfolio is that our parameters are consistent across all drives. They include some innovative features like SD cards and modularity, and some of them can even be programmed and accessed through a web app. So next we're going to talk about solutions for connecting our drives on Ethernet IP with Logix controllers. So this is an example of what you might see in a facility. We have a Logix PLC with Studio 5000 software talking to a panel view HMI and connected over Ethernet IP. So what we can do here is add a Synamics G120 drive, could be any Synamics G drive or Synamics S drive, to this and have it communicate on Logix or on Ethernet IP to a Logix controller. Our drives allow you to connect on Ethernet IP with just one simple parameter change. So one parameter change can move from Profinet to Ethernet IP. So there's no additional hardware that you need to be able to connect and communicate on either network. So we have electronic data sheets, which I'll explain in the next slide, how the drive is seen in the Logix 5000 software. We also have add-on instructions, so those allow you to program the drive within the Studio 5000 environment. And then we also have faceplates, which allow you to control the drive on the panel view HMI. So let's talk about the electronic data sheets for Studio 5000 integration. They're basically simple text files used by network configuration tools that identify products on the network. And what it does is it loads Synamics drives into the Studio 5000 product library for easy selection and integration. It pre-configures the communication between the PLC and the drive. And when we wrote our EDS files and when we created them, we removed the need for drive hardware and firmware management. And so you might have had the experience with a PowerFlex drive where when you set it up in the Logix environment in Studio 5000, you have to select what the major and minor revisions of the drive firmware is. Now, this isn't a big deal necessarily when you set it up, but later, if you ever have to go in and replace that drive, you would have to know the firmware of the drive that you're replacing in order to flash the new drive's firmware to get it to match. Otherwise, it won't work. With our drives, you can simply drop in a new Synamics drive, and you don't have to worry about managing the firmware revision of that drive. The next tool that we have are add-on instructions. So these are basically just blocks of code that allow you to quickly and easily program our drive. They reduce engineering time and they allow our drives to have descriptive tag names so that when you're programming the drive, you'll see common phrases like stop, start, and jog. And the AOIs connect to the faceplates, which I will talk to you about in the next slide. So the faceplates are available for the panel view HMI. They're pre-built. They talk directly to the AOI. They give the user an easy view into the Synamics drive parameters. So you can control the drive, but it also reads information from the drive and displays that information on the screen. So just want to show you some of the benefits or recap the benefits. When adding a Synamics drive to an Ethernet IP network and talking to a Logix controller, we've eliminated the need for drive firmware management. So the EDS files do not have this requirement. They do not ask the PLC to check for this in the drive. We've reduced the PLC programming with our AOIs, and then we've also helped out with the HMI development using the faceplates that connect directly to the AOI. We have several different resources available for you to leverage on SIOS, which is Siemens Industry Online Support. So that would be application manuals, AOIs, the EDS files, faceplates. We also have labs for PLC and HMI. So if there's ever any question in your mind, you want to see how this works, reach out to your account manager and we can set up a demonstration for you. You can get hands-on with the hardware and you can try out some of these tools that we have. We have resources for Synamics G drives as well as our S drives. So that covers it for Ethernet IP. We also appreciate that some of our customers have old PLCs. So then we have a question of, well, what do you do if you have old PLCs? If maybe you have a PLC 5 on remote I/O, or maybe you have a SLC 500 processor still in your facility, and you might have drives attached to these. So you can connect to PLC 5 and SLC 500 without touching the PLC code. And what we've done is develop different tools, different hardware devices that allow you to connect. So first I'll talk about solutions for AB remote I/O. So this is what you might encounter in your facility. So you have an AB PLC 5, it's on AB remote I/O, also known as RIO, also known as Blue Hose. The PLC itself is circa 1985. The drive, in this case, 1336, might be about the same vintage, might be a little newer, but still not supported by Rockwell. And so what you might want to do is consider protecting your most valuable assets in your plant, what the drive controls, and replace that drive either if it fails or hopefully proactively before you have such an incident. So what you'd want to do is remove the drive. You would add a new Synamics drive. So in this case, we have the Synamics G120. It's connected on Ethernet IP, and it's also connected to this remote I/O gateway device. And you just download a configuration file, and there's no need to go into the PLC. There's no need to change anything in the PLC code. So this is very powerful because, as you know, or may know, the PLC 5 software is programmed with RS Logix 5 software, requires special cables, requires a special, I don't know what version of Windows it runs on, or even if it is Windows, but a lot of different problems with potentially connecting to that PLC and making any modifications in that code. So let's examine, just in a little bit more detail, again, what you would need to do to make that connection. You first connect the hardware, so you connect the old remote I/O adapter and Ethernet cable from the Synamics drive to the soft PLC gateway. You would configure that gateway via a web server. So I'll go into this in a little bit more detail in the next slide. You commission the Synamics drive, similar to how you commission any drive, and then you configure the Synamics drive using the configuration file, also known as a CLI file. So this is what the custom developed gateway for remote I/O looks like. So Siemens has partnered with Soft PLC to custom develop and pre-program this gateway device. So it's not just any gateway. A lot of research and development went into this, and it specifically works with Synamics drives, remote I/O, and older PLCs, and replacing AB drives. So this configuration is very simple. It's on a web page. You do not need to download any software to be able to configure this device. It asks just a simple questions, like your AB drive model, the rack size, some of the remote I/O words, and then we have this available to purchase on our website. The command line interface that we mentioned earlier, which allows you to just quickly download parameters to the drive and get you up and running in this case, we've already written the code for you. So there is a standard for how you would write this code and then how you would change that text file. So you write it in a text file and you just save it as a .cli extension. But basically, it's just an easy modifiable file that contains parameter settings for the Synamics drive. So all you would need to do is take our CLI file, add it to the operator interface, put the operator interface on the drive, download it to the drive, and you're up and running. If for some reason you wanted to change any of those drive parameters ahead of time, you could go into the CLI file, you could go into that operator interface and make those changes, and you would be up and running. We have remote I/O resources. So we have user manuals for Synamics AC drives. So that would be the G family of drives, G120, G130, G150, etc., as well as Synamics DC drives. And it's replacing AB drives, the common ones like 1305, 1336, DC drives, as well as PowerFlex 70, as well as 700. So that covers it for remote I/O. We also have solutions for DeviceNet. So this is a diagram of, an old AB SLC 500 processor, could also be a PLC5 processor, talking to an unsupported Allen Bradley drive, in this case 1336, and it is on DeviceNet. So similar process as for remote I/O, but we'll go into this in more detail. So you would remove the device, add a new Synamics drive, and connect it to a DeviceNet gateway. Download a configuration file, and again, you do not need to touch the PLC code. So again, you can connect to PLC5 or SLC 500 on DeviceNet without touching the PLC code. This is what the unboxing looks like of this device. It is a gateway by Hilscher, but similar to the soft PLC device, a lot of development and research has gone into this by Siemens and Hilscher. So it's pre-programmed to work with our drives. The IP mapping is done in the CLI file along with other parameters. It has a very small footprint, so this plus a Synamics drive takes about the same size as a PowerFlex 40, and it has a Siemens part number, and it's available on our website. There's a 5-step process for replacing drives on DeviceNet. So first you commission the drive, which is same as you commission any drive that's new on a network connected to PLC. You would download the CLI file, get connected to the drive and DeviceNet network, and then set the node address. You would disable keying on RS networks and then configure the Hilscher device. So what you don't need to do, and I'm not going to go through this whole list, but you do not need to reconfigure the RS networks for DeviceNet software, and you don't have to reconfigure the PLC program. So this, saves you a lot of time, reduces risks, and makes the whole process a lot easier. We have several DeviceNet resources. So we have a user manual for Synamics G120, and it's really for replacing AB drives 1305, 160, 440, 70, and 700. So just want to recap our solutions for drive migrations. So no change to the PLC code. This is huge. Not having to go into PLC 5, not having to go into a SLC controller, find the correct cables, get the right, get the right VMware image that has the correct software. That saves a lot of time and will reduce your risk. The gateways that we have aren't just any gateways. They are custom developed and specifically designed to work with these old obsolete AB drives, old PLCs, and our drives. So this really simplifies the connection. And then we have pre-developed configuration files which simplify the configuration. So in summary, our drives can connect on Ethernet IP with a Logix controller, one parameter change, and you can talk on Ethernet IP or Profinet. You can also connect to PLC5 on Remote I/O as well as DeviceNet. And we have all of the tools ready for you to use and available online. So thank you very much for joining us today. We talked a lot about how to connect to different third-party devices, how to modernize and connect, how to modernize and integrate on automation platforms. And now we would like to open it up for questions.
Welcome back. Here we are at the studio, and Jim and Jackie is with me on stage. I'm standing here with my trusty iPad where I see your questions as they come in live. So please feel free, submit a question, and we're going to try to answer it right here and right now. We had a few of them come in while Jackie's session was finishing up. So let me get started with that. And the first question came from John. And John is asking, do you have an ET200AL-IM with multi-field bus capability? Would that be for Jim?
That would be for me, I guess. That's a good question. Actually, we do not have an MFB module for the ET200AL, but we actually do have a card that goes into the ET200SP that will let you move out to ET200AL as well, connect to that, and connect up to, I think, 16 modules. So you actually can use AL, but not with the head module for AL. And for those of you in the audience who don't know what AL is, that's a block I/O from Siemens. It's kind of similar to the Eco that I showed earlier in that form factor. It is a very low profile type I/O. It's IP65, 67. It mounts on a machine. It's for assembly lines. So if you don't know what that is, that's what it is. And we basically can use it with Ethernet IP, but it's not a head module. It connects through ET200SP.
All right. Thanks, Jim. We have a couple of more. Next question is from Jennifer. Let me scroll back because people are asking, and I have to scroll back up to go in order. Jennifer is asking, are safety I/O supported by EIP or Modbus configuration?
Another one from me. Perfect.
You can get us started.
I know. No, actually, safety is not supported with Ethernet IP or Modbus TCP through this module. You would have to use a Profinet configuration for that. But like I said in the presentation, you could do that. You could actually put your standard I/O and your safety I/O in the same rack. And so if you had, for example, most of your I/O is with Ethernet IP, you could control the standard with Ethernet IP, and you could add a safety controller with Profinet onto the same cable and actually use that for your safety devices. And keep in mind, that would not have to be a large S7-1500 PLC. It could be something like an S7-1200 or a soft controller, anything you want with Profinet and safety. So all the safety actually has to be through Profinet.
Okay, thanks for that, Jim. Actually, Jennifer had one more question.
Okay.
So we're gonna take care of those right away. And do you have a solution for migrating drives on Data Highway Plus?
So that would be for me.
One
Yes.
for each.
Yes. So we do not. We have solutions for migrating drives on Remote I/O, DeviceNet, and then of course we can connect on Ethernet IP as well.
All right, thank you. Thank you, Jackie. We have a question from Kim. Kim Miller is asking, is there an easy way to control an AB PowerFlex VFD using a Siemens processor? An easy way.
Sorry, can you repeat?
Yes, of course. Kim is asking, is there an easy way to control an AB PowerFlex VFD using a Siemens processor?
Yes. So again, it would depend on what network you're talking about, but if it's Ethernet IP, we have those add-on instructions that you can use in the Studio 5000 software language so that you can easily connect, add that drive to the project, and then control the drive. If you're talking about legacy networks like DeviceNet and Remote I/O, we have solutions for those as well.
All right, very good. You guys are on a roll.
All right.
And guess what? So is our audience, but we have more questions.
Okay.
All right. One more question here, and that is the following. Do the MFP modules support asynchronous mode for the EIP or Modbus configurations? I think that would be you.
I think there's a lot of questions in that question. The first one is, how do you pronounce isochronous?
Sorry.
Is it isochronous or isochronous?
That's a good one.
That
I'll
question-
take all the blame.
That question I can't really answer for you, but if you know what that is, it's kind of a time-based I/O. Basically, it allows you to synchronize in a constant time interval your inputs, your outputs, and your PLC scan. So it gives you a very constant response time. And isochronous mode actually is not supported through Ethernet IP or the Modbus TCP. And actually, even with the Profinet, that particular head module that does all three of these does not do the time-based I/O. You would have to use a high-feature head module to do that, different head module.
Okay.
Yeah.
And any judgment on which way we're going to pronounce it? How do you say it?
I like isochronous. I'm going to go with that.
All right,
Yeah.
isochronous.
Okay.
Thanks for that question, John. Next question is, what kind of safety functions do Siemens drives have? I think that's a good one.
Yes. So I should know the answer to this question, but
Yes, indeed.
full disclosure, I am fairly new to Siemens. I come from Rockwell Automation, and so
Don't say this thing.
I know. So I will have to get back to this individual on what exact drive they're talking about and what safety features they're interested in, if it's over Ethernet IP or Profinet. But we do have safety built into our drives. I think the person in the audience might be asking about possibly over a network. So I need a little bit more information. We can follow up. Yeah.
Okay. And we do have another question that just came in from Jared. And Jared is asking, does Siemens offer AIO profiles for using AB products with a Siemens controller?
I'm not sure of anything specific for that. I don't know. I might have to look at that one and get back to that question. I'm not sure on that one.
All right.
Yep.
Okay. And
I was talking mainly today about the CAN solutions that we have. And in the past, like for example, the communications that we can connect up our PLC to other PLCs on an Ethernet IP network. I mean, that's a great thing. We've been doing that for years and years. Make no mistake, that's not something new. But what's new is the fact that we have these CAN solutions that we can actually do that with. So somebody can go in there, go to the Siemens Industry Online Support, and they can actually grab that block and use it right immediately. And they
is it
have
a
nice
plug
notes.
and play?
Basically, yeah. I mean, you have notes there. You have even a project, a seed project. You have everything you need to get started and make that work. So that's the big difference that I was trying to point out in the presentation today. So lots of different ways to connect with Ethernet IP.
And so if it's the first person if it's the first time that person is going to Siemens support to plug and play, what kind of instructions or support can they rely on?
Should be very straightforward. This is something right on the online Siemens Industry Online Support.
Okay.
So in the presentation, I actually put a QR code and a link. So if you want to click on that, it brings you right to all those solutions. You can go directly there. And I should say, too, those are free libraries. You don't have to buy those. You download those for free. You don't need anything else. Download those for free and take a look. All the instructions are there. Should be very simple to use. All canned.
All canned.
Yep.
All right, like a can of soup. We have two more questions, and I think we have enough time to address both of them before we have to bring in our keynote speaker to you today. And speaking of migration, can you migrate an ABDC drives on remote I/O?
Yes, so we have solutions for migrating AC drives as well as DC drives on remote I/O. So that would be a 1395 or a 1397 drive. We can migrate that on remote I/O to a new Synamics drive.
Thank you for that, Jackie. And so the previous question that we asked that came from Jarrett, we think we know what he asked and answered it to the best of our ability, but he's basically clarifying if he got us correctly, if he understood correctly. So it's similar to the I/O offered for the Allen Bradley PLC to use Siemens drive. Does Siemens offer something vice versa? Did he get it straight?
Yeah, I think so.
This is how
right.
he.
Yeah. Okay. Yeah. The same.
Jared,
yeah.
I see you typing. If I'm misrepresenting what you're saying, please clarify. At this point, I'm going to give this moment for. Oh, wait, hold on. One more question. We have a second to address it, and then I'm going to take it to our keynote. So One last question. I heard Siemens PLCs can talk Ethernet IP. What PLCs support this and how?
The PLCs that support that are the 1500s and the S7300s. That's what those blocks are for. So all of our mainline PLCs.
Okay. All right. Well, thank you so much, guys. At this point, we are actually coming down on our live Q&A with Jim and Jackie, because here on the other side of me on the screen, and you'll see that in a second, I already have our keynote speaker. Jim, Jackie, thank you so much for being here on stage with me today, and it will be my pleasure to take it next to our next session, because the next step is our keynote. Hello, Jake. Can you hear me all right?
I can hear you just fine. How are you?
Good. Good to see you. It is such a pleasure to welcome you here at our Factory Automation Virtual Tour. Thank you for joining.
It is such a pleasure to be here.
Yes. So for all of you guys listening online, it is my absolute honor to introduce you to Jake Hall. Jake Hall is a business development manager for Avaya and Zelstra, but for many of you, he is better known as the manufacturing millennial. He's a tireless advocate for automation, for digital transformation, for manufacturing and skilled trades. And he really changes that conversation and perception of both people and companies of all these topics on social media. He's got a combined audience of over 40,000 followers, and his posts have seen a combined views of over 25 million times. Yes, it sounds really impressive. We're so excited you're here. We hope all those 25 million people tune in. And with that, I hope that the way you ignite the conversation on social media about the latest in manufacturing, about the current and future of work, you can bring it to our stage. So Jake, I give it up to you.
Awesome. Thank you so much. And it's really exciting to be here today. I'm just really thrilled to have a conversation coming from a millennial and a younger generation on what we're seeing as the future of manufacturing. But not just for me, what are the future millennials and Gen Zs looking forward to seeing in the industry, and how do we attract them with new technology, but also the way we're perceiving our culture and the way we're perceiving manufacturing is today. So we're going to kick things off. We're going to talk about the future of manufacturing, technology, and workforce attraction. And for today's conversation, for the 30 minutes I have with you today, my goal is to talk about what is the state of manufacturing? What are we seeing in the industry? And how does that perceive to a future workforce? We're going to talk about some of the problems that we're facing, and then also share some really cool technology that I see that I like to talk about with my audience. So a little about me. I've been in the industry for about 10 years now. My degree is in manufacturing engineering, and I became an industry influencer about 2 years ago when the pandemic hit. And I said, there's going to be a lot of people now online and on social media looking for new technology and new solutions. So over the short 2 years, I've grown over 40,000 followers on LinkedIn. I'm averaged last about 12 months, 15 million views on content. I've been honored to be viewed as a top 100 industry influencer for Industry 4.0. I have also founded the Manufacturing Millennial and the Manufacturing Champions to work with better advocating the manufacturing industry. And as it was said earlier, I'm a huge advocate for workforce development, for skilled trades, and new technology in the industry. Some fun content. I always love to share what we're seeing in the industry. So if you like automation and just having conversations about it, we're going to love the next 30 minutes. So what is the state of manufacturing right now? Well, we're all looking at it. We're having a hard time finding and keeping workers in the industry, especially a younger generation. In fact, when you look at first-time millennials entering the manufacturing industry, over 70% of them don't make it past 90 days in the industry. And what we're going to be facing going into 2028 to 2030 is a massive labor shortage gap. In fact, when we see 2.6 million jobs retiring from the silver tsunami, and we're going to see another almost 2 million jobs being created as our industry grows, we're going to have a massive gap. And with the upcoming and changing force, we're going to be able to fill some of those jobs, but we're still going to see 2 million jobs unfulfilled in our industry. So workforce is a major issue. In fact, one other issue that we're talking about in the industry right now is redefining the supply chain. If I were to break out 4 categories of what is the state of manufacturing in 2022, one would be workforce attraction and development. The next is redefining the supply chain. In fact, a survey recently done, 41% of executives were going to be adding diversify their existing supply chain in 2022. 53% are going to be planning to enhance their integration of supply and demand with visibility and planning. That means they're going to be working with their suppliers to get better access onto what their production looks like. And 24% of manufacturing executives surveyed will be moving operations closer to their end customers. So we're going to be seeing a lot of domestic manufacturing coming back. The other thing that we're seeing is acceleration of digital adoption technology. And this just isn't happening in brownfield or green facilities. It's happening in both. And in fact, driving the smart factory is going to be one of the biggest competitive advantages that a lot of companies are seeing. 45% of manufacturing executives are planning a substantial investment with IIoT and connecting machines in the next 2 to 3 years. And on top of that, one of the other really cool technologies that we're going to be seeing is the adoption of 5G. When we're looking at how do we connect these machines in our industry, 5G is going to be a big solution, especially with a lot of systems being mobile. We're seeing the largest implementation of AMRs and AGVs in the warehouse and distribution field in the last 3 years as a result of the pandemic. In fact, we're going to see by 2028, there will be more mobile robots than industrial robots in manufacturing and in the warehouse industry. And then we're also going to see a lot with the connected worker. But as we're connecting new technology and new devices, there's a risk, and that is cybersecurity, when preparing for when it's going to happen. In fact, when we look at the manufacturing industry, 92% of manufacturers have had some sort of ransomware or phishing incident in the past 12 months. So as we're adding new technologies, cybersecurity is going to be on the forefront of a lot of companies to better protect their OT and their IT and external networks. But when we look at those 4 systems, what is the biggest thing that I see happening in the industry that's really going to be either setting back a lot of manufacturers or moving them forward? And I think a lot of that has to be with what is the future worker look like? What does your future employee look like in our industry? Well, there's a few things that I look at. When you're looking at manufacturing a lot of times isn't just making one product over and over again. It's a lot of flexibility within your manufacturing system. I think that's the first thing. When we're looking at new employees, are they going to have the ability to be cross-trained? And the reason why I'm bringing this up right now is, are manufacturers and end users putting in the proper systems to cross-train people? As employees are moving around from station to station and station, how are you implementing a system that's flexible and dynamic enough that's going to allow them to be able to be very efficient and not have to put in a bunch of hours to bring efficiency on that machine up? What is their interest and aptitude for technology? If we're seeing this massive retirement of what I view as the silver tsunami with people being in the industry for 20 or 30 years, what is this next generation going to be able to do with them being very familiar with their phones and devices and being able to make decisions through technology? Are they going to be able to leverage that skill on the factory floor? And on top of that, strong communication skills. And it's always good. I think, there's always that perception that millennials and Gen Zs are shy. But are they going to have communication in a way that they're familiar with in terms of texting and chats, and be able to communicate in a way where maybe it's not always happening on a 45-minute Teams conversation? Are you going to be able to communicate in a way, or communicate to those machines in a way that they're comfortable with? The last one is the attention to detail. And I think it's one of those things where, are we going to be able to leverage this younger generation in a way that we're having a hard time attraction, and be able to address the problems and errors and downtime and risk when manufacturing comes up, when manufacturing issues come up? But one of the biggest things I think is, as we look at for the employee of the future, are we going to be able to attract the employee of the future. And I think this slide here says a lot. I always love to share this picture right here of what the older generation's perception on millennials and Gen Zs are. When we're so used to looking at a picture, and if we want to look at the next one, we swipe. And I think there's some humor to that. But where there's not the humor is when you look at, this is a list of where Gen Zs plan on going after they retire from high school. So on that top is that 36.6%. We see more Gen Zs, which are aged from 40 to 22, going into a field that's not manufacturing. In fact, we have to go all the way down the list past education and training, government, information technology, hospitality, and tourism until we get to manufacturing, where only 3.5% of our future generation says they want to do manufacturing. How do we address that issue? So who are these millennials and Gen Zs? Well, I think there's a lot of perceptions about them. You know, they like their avocado toast. They like their coffee. They feel that everything is about them. They all want a participation trophy. And listen, there are those people out there. But I think what we need to look at and focus on is who are these millennials and Gen Zs, and what do they have in common that we can relate and drive them into our manufacturing field. And I think the first thing is they need to find meaning in their work. In my opinion, gone are the days where people just show up to work an 8-to-5 job and they don't care about that time, and they only care about the paycheck, and after that they go home. I think what we're seeing with a lot of generations now, as they're becoming more connected, as they're becoming more glued to society through social media and through the influence that they're seeing, they need to find work in what they're doing. If that's either through a purpose that they're creating an impact through their job, if it's learning on how their company is impacting sustainability, or how what they're doing is something greater than just a manual operation that they're a part of. They don't view the concept of work as the previous generation, kind of as what we talked about. They want to be able to go to work, but they also want to be able to have a life outside of work where they're not going to work and they're just exhausted to the point where then they can't do anything when they get home or do anything on the weekends because work is just taking up so much of their energy. So how do we enable a worker to be able to be efficient with what their job is, but also allow them to have a life outside of it? And we look at what manufacturing, some of the highest labor or highest turnover jobs where we see the most, lack of retention is high labor, high thinking task jobs where people don't want to do a same repetitive task over and over again. And a lot of times we can't always automate those processes because either there's a high flexibility, there's not a justification for ROI for a fully automated system. So what are some solutions that we can look at that are going to enable a worker? And I got some videos to show you in just a few minutes talking about that. But the other thing as well, I think we need to realize, and going down this list, is the bottom one. They are highly educated. When we're looking at millennials and Gen Zs, when we're seeing the most kids graduating from high school and college, they are highly educated. And I think the one thing is they feel the perception is they feel entitled, but I would argue that they feel empowered. They feel empowered to make change. And if you want to see change in manufacturing, how do you enable the empowerment and the motivation that they have to benefit your company? The way they perceive change as well and the way they address issues is different. In fact, I always love this as an example. When my father first taught me to fix my car when I was 15 years old, we bought a truck, a Ford F-250. And that was my first car. And he taught me how to replace the alternator on it, how to replace the belt, the calipers, the rotor. We went to AutoZone and we picked up this Hayes manual repair book. That's how we learned how to address the issues and how to do that. But over that time, in that 15 years since I got my first car, we've changed on how we look for solutions and how we look for addressing the problems in the industry. In fact, now what I do is if I want to replace a part on my car, I go on YouTube. I look for digital content to help drive solving the problem and help addressing the problem. The same thing goes with manufacturing now. If a operator faces a problem or there's a downtime or there's something that we want to change in a job or a job changeover, Are you still using the Haynes catalog from 1995? Or are you leveraging technology in a way which this younger generation is familiar with to work and be more beneficial in your manufacturing process? So how do we attract this future workforce? Well, we talked about it. We communicate purpose. We show them that what we're doing in the manufacturing industry is beyond just making parts. It's beyond just this dark, dirty, dangerous, dull environment. And in fact, what we're seeing in the industry is more innovation, more technology is coming to our industry than ever before. In fact, in a lot of areas, it's actually leading the industry. Adapt to their way of life. How are we leveraging technology to allow them to communicate, allow them to learn, and allow them to solve problems? And how are we investing in their future? When I look at investing in the future, what are you doing to give them more skills, to allow them to grow in our industry? In fact, that's why I personally love manufacturing. Everything from skilled trades to engineers and everything in between. What's important and what's amazing about our industry is people can grow in it. Probably people in this audience right now, you probably didn't start in the position you are currently in. You might have started as a maintenance technician or a plant floor operator. And over that time, you grew in that 5, 10, 15, 20 years to be in a manager or director position. And what's incredible is that manufacturing industry allows us to empower our future workforce by investing in their future. So if we can do a better job at looking at how do we retain a future workforce, we invest in that future workforce so they stay with us. And by investments, I also look at how are we investing in adapting new technology. And new technology, I think one of the things that we always hear about is this idea of Industry 4.0. Industry 4.0, in my opinion, isn't a technology. It's not a solution. It's a culture change. How are we adapting new technologies such as autonomous robots, systems integration, IT and OT development, cybersecurity, cloud computing, additive manufacturing, augmented reality, robots and humans working alongside one each other? How are we leveraging this technology to make a worker's life easier? What we're going to be seeing in these next few videos is not fully automated systems and cells. We've all seen those before where it's a turnkey system, raw parts go in, and out comes a completed component. What we look at is those systems that we can't fully automate, but an operator still needs to be involved. How do we enable an operator to be more beneficial for us? How do we take the future of manufacturing and leverage the technology to attract and retain a future workforce? Well, this is the first video, and I'm going to go ahead and just go right to the screen itself. This is the first video I always love to share. It's this idea of an operator working alongside a manual component with projected augmented reality. And what we're seeing here is light being projected down onto a work surface that's guiding the operator through an assembly check to look for the components, to check for Class A surfaces, to verify that parts are in place. In fact, if you're working in the automotive industry, a lot of times Class A surfaces are very hard to inspect through either a vision system or through an automation component. We still need the operator there. But how do we guide that operator who might have been there the first day for the first time and has not learned all the proper locations to check? Well, we can leverage augmented reality, in this case, projected AR, to guide an operator through that task to check everything. The next solution here I always like to highlight is exoskeletons or device wearables. In an area where you're going to have more than likely a young worker coming out of college, coming out of high school, who needs to work on an assembly line, who's doing this very heavy, rigorous task of lifting their arms above their heads to assemble components or to move parts around. How do you assist them to make their life easier? In fact, we talked about it earlier, when millennials and Gen Zs look at manufacturing, they want to have a life outside of their job. And if you're able to make it so there's less physical strain on their body by adapting a technology or solution that's going to make their work more enjoyable, you're going to keep that employee around for longer. Because a lot of these tasks are still systems that can't be automated. Here's another solution. I was like, this is another device wearable. So this is a barcode reader that allows the operator to wear it, where they don't have to walk around with a handheld and pick it up and set it down and pick it up, set it down. It's attached right to them. And, you know, we always joke about, oh man, these younger generations, they always have their phones, you know, on their hip. They're always in their hand. Well, how do we leverage the technology to be in their hand? In this case, we have a biometric device that an operator is wearing a glove. And if an operator is picking up heavy parts and components all day, what if they wore a glove that assisted them so they didn't have as much strain on their hand and arm and fingers? So here's an app that the operator can use to adjust for strength. And then when the operator goes down and tries to pick up a part, it assists them, giving them extra grip strength. Here's another one, another device wearable where we're leveraging technology to work alongside an operator. So here's an area where a operator is wearing a glove and they're guiding the operator through a manual task to ensure that the correct components were picked, the correct location was placed, and it was assembly in the right process. This next one is a really exciting one for me, and that's just because when we're looking at the industry and the welding industry in particular, there's currently 550,000 welders in the United States. Well, the average age of those welders in the U.S. is 55 to 56 years old. It's an aging workforce. In fact, they're expecting in the next 10 years to see over half the welding workforce retire. So how do we leverage technology in a way that's going to allow us to still weld components, especially components that I would view as a low quantity, high variability, high SKU count? We can weld a lot of components. We see that in the automotive industry all the time. But what if we just had to weld 50 components or 100 components? How do we leverage technology to do that? Well, in this case, what we're seeing here is we're seeing a collaborative robot being guided by an operator. So they go in and they set multiple points to say, hey, I want you to start here. I want you to end here. I want you to start here. I want you to end here. And the robot and the system itself will then determine where do I place my bead? How fast do I go? What material am I using? And you're enabling a person who might not be a degreed welder or be a skilled trades welder, but you're allowing technology to create and fill that gap of what a skilled welder is going to be. So this is an awesome example of how we're seeing robotics, or specifically collaborative robots, leveraging and working alongside those skilled trades. Especially if you're in a situation where you might not have a controls engineer who is extremely familiar with robotic and welding programming, you might just have a typical operator. But if you have an operator who can go out and look at a part and follow some instructions, say, this is where I stop, this is where I start again. This is where I stop now, and then this is where I start again, and this is where I stop. That's a way to enable technology to complete a manufacturing task. Here's another great example of how robotics and automation is working alongside a future workforce. This is a distribution facility at a FedEx down in Memphis, Tennessee. And what we were wondering at is we're looking at these packages and components. And these components are allowing, or what this product is, it's a polymer bag or a small packaging bag where FedEx sees anywhere between 2 to 3 million of them a day coming through this facility. Well, what the issue is an operator has to, at one point in time, manually separate each bag so then a barcode scanner could read where the package is going and then know where to ship it on their assembly line. Well, the problem is they were finding out that even though that they were paying workers $24, $25 an hour down in Memphis, no one wanted to show up at work at 2 a.m. to do this job. So they had to turn to automation to be able to fill this labor shortage that we're facing. In fact, when you're looking at this video, you can see how there's operators working alongside that. In fact, this solution views that there is a crew chief that works alongside these operators. So when a robot doesn't know what part to pick or what package to pick, it will send a notification or a text message or an alert to an operator's cell phone or to a computer, and it will say, hey, there's 4 packages here. Which one do I pick first to make sure I'm not grabbing an overlapping part? So they're leveraging the skills of a worker to still work alongside robots in a flexible way. This is another fun, exciting one as well. This is a device called Mimic. And what we're seeing here is how operators can program robots in a non-traditional way. I think a lot of times, especially for small to medium-sized businesses that are first-time users of automation, they're always intimidated. I might not have a controls engineer who knows how to program a robot, or I might not have a controls engineer who can always be here. So when we do a new job or a part changeover or try and do something different, he's available to program it. So this is a solution where an operator actually holds a teach pendant, and that teach pendant tells the robot to follow their exact movements. So if they're painting or if they're sanding or they're doing some sort of finishing surface or some assembly, you can see the robot following that operator's exact movements, which, and a lot of times, if you're to look at a solution like that and want to program something like that manually, that would be a very difficult task to do, especially if you're familiar with the painting of the robots and the painting industry. It's a task to be able to get the right coverage, to not get a bunch of drip, to make sure that you're getting the right fill. If you could have an operator do that task and a robot mimic those exact movements, we're leveraging technology in a new way that doesn't require the programming and the controls and the robotic skill set that right now is in a massive demand in the industry. We can leverage a typical worker and follow their motion to allow us to be able to produce and finish parts. So where are we at with that? What we're looking at is how do we take these new technologies and how do we enable them in a way where they become that science, technology, engineering, and math field? Well, what we're doing is just that. We're taking this idea that manufacturing is just this dark, dirty, dangerous, dull environment. And what we need to do is we need to leverage these technologies where manufacturing is that STEM field. It's that field with artificial intelligence, with robotics, with automation, with new technology, where as we're bringing more connected devices to our industry, we need people in cybersecurity and development for code and full stack programmers. We're going to need those future designers and developers in our manufacturing field. So how do we address the issue? We make manufacturing a STEM field with new technology. And I think that's what we're seeing, and that's what's going to be exciting to a lot of people and a lot of our future generations forward. Well, that wraps it up for me. I think I have a little time for Q&A. I can't remember. But what I would encourage you to do is go ahead and click on that Let's Connect sign. Go take out your phone. I'm going to enable to use some technology today. Scan that barcode, and we can work together to make that happen. Thanks so much for your time.
Hello, Jake. Thank you. Thank you for talking about it. Thank you for sharing the videos. Our audience sure appreciate it. You also ignited quite a conversation on our chat regarding baseball alliances, but I'll keep that private.
Oh man, well I can't see the chat. Well, I'm gonna be at a Wrigley game this afternoon, so I'm excited about that.
All right. I would like to thank you for this wonderful session. Everybody who is listening live online, which we have hundreds of people who are actually tuned in, the QR code that Jake has shared, and he can pull that up one more time. He is available to connect. He is the LinkedIn guy, so certainly link him up, and let's keep the conversation going. In the meantime, it is my pleasure to announce our next session, because next up will be our panel discussion for TA Portal. Jake, thank you so much. It was great having you here.
Thanks so much. Have a great day.
Welcome, and thank you for joining this session of our Factory Automation virtual tour for a panel discussion on TA Portal. where we will take a closer look at the Totally Integrated Automation, or TIA, engineering framework and highlight how the TIA ensures increased productivity and efficiency while controlling time and costs. Allow me to introduce today's moderators. Today's panel will be led by John Detellum, TIA Portal Engineering Software Product Manager, and Luis Narvaez, Product Marketing Manager for Systematic Industrial Security. Joining John and Luis will be our two panelists. Our panelists today come from Prism Systems Incorporated. Prism Systems is headquartered in Mobile, Alabama, and has branch offices in California, Florida, and Beijing. Prism has been in business since 1989 and has been a Siemens Certified Solution Partner since 2001. Staff members hold Siemens certifications in PCS7, TIA Portal, switching and routing, and wireless networking. Prism has a wide customer base in industries such as amusement, entertainment, specialty chemical, automotive, and food and beverage. And on the panel today from Prism, we have Ron Knight, their engineering manager. Ron has over 30 years of controls experience and holds a bachelor degree in computer engineering from Mississippi State University. Ron has been with Prism Systems for 28 years, and he holds a Siemens certification in PCS7, TIA Portal, and switching and routing. Joining him is Chuck Serpa. Chuck has almost 30 years of controls experience and holds a bachelor degree in electrical engineering from the New York State University. Chuck has been employed with Prism System for 9 years as a senior systems engineer. And with that introduction, I'm happy to turn it over to our moderators. John and Luis, take it away.
Thanks, Natalia. That was a great introduction. And I just wanted to highlight again, when we make the comment or use the term TIA, it represents our totally integrated automation portfolio, which is the hardware product portfolio, automation products, PLCs, controllers, HMIs, I/O networking, as you see in the setup behind Ron. And of course, the TIA portal is the engineering automation framework. And what our goal today was kind of get first impressions and some of the value propositions that you guys recognize from a perspective of a startup, system engineering and design, and long-term maintenance of implementing these totally integrated automation products together into the spectrum of applications that you guys represent from the perspective of both the system integrator, the OEM, and the end user. And so I'm just going to turn it over to you, Ron and Chuck, to kind of kick off your perspectives and the value propositions, and we'll take in some of the questions as we go along and interrupt and direct wherever we want to go from there. Thanks.
Sure, great. Thanks, John. So my experience with Siemens started way back, I would say in 93, 94, where I was on site at a textile facility and they had a baler that had a step 5 processor in it. And we were doing all Allen Bradley at the time. And I was asked to help troubleshoot this baler. Well, the step 5 software, getting online, looking at the logic, all of that was so different than what I was used to on the Allen Bradley and the Rockwell side that I sort of decided, Siemens is a little more complicated. I'm not going to do it. And so I skipped the whole step 7 days, and then I didn't pick it back up again until TIA Portal. And, John, as you know, we sort of put together it's like a 2-day workshop. If you do it like this in Rockwell, then this is the way you're going to do it in TIA Portal. Yeah. And we've sort of trimmed that down into a 1-day virtual workshop as well. But that was really my first experience with Siemens is TIA Portal. I'm a Rockwell user. How easy is it for me to pick up Portal?
Yeah.
And
so the other thing, Ron, the one thing, Ron, is even the S5 had function block programming and function call and OBs. So I just want to make one comment that one thing that really stands out is the fact that the evolution of S5 to S7 300s to TI Portal carried that technology forward because it's such an integral part of reusable blocks. So go ahead.
Yeah, that's great because what I have found now that I've had occasion to step back into Step 7 Classic. Yeah, all those same things are there, the function blocks and the instance data blocks and the functions. So I had skipped that whole phase, and I guess I really didn't need to, but Portal made it so much easier for me to learn it. And so now that I know those terms, it's a lot easier to step back and go into that as well. And so I get asked a lot, particularly in those 2-day workshops, okay, if you had to name one thing why you want to use Portal over another vendor, what would it be? And the two things that come to mind for me immediately is, first of all, the operator interface and the PLC being in one software package. I don't know about the audience, but I find HMI development tedious, and anything that sort of reduces the amount of time that takes is great for me. So the fact that I can drag and drop things from the PLC right into the HMI, and it automatically creates things like analog displays and creates the HMI connections and all those things, that is a huge time saver. So that would be number one. The second thing I always say is those built-in system diagnostics. If something fails in the control system, how does it let somebody know that it's failed? If you lose communications to a VFD or an IO rack, how does it let you know that there is a problem? And more importantly, for a systems integrator, how much time is it going to take me to implement that? For us, and I know it's cliche, but time is money for us as an engineering services group. And so anything that reduces that time is big for us.
Yeah. And I think another point to that is when you're standing at the machine or dealing with the machine, you're generally thinking about the automation as a system-centric thing anyway.
Sorry.
Well, it's clear that we're alive. The ability to open up the ability to open up the project and truly see my automation architecture without struggling to go find out where's my HMI project, where's my HMI number 2 project, where's my PLC for the subassembly project. To me, that's another big benefit. When I got started in it the first time, I was like, wow, here's the system that I'm actually dealing with, and that might have more than one PLC, more than one HMI, and it's all in one project file. And that's another thing. Again, it goes back to classic Step 7. It was part of the 300 in the WinCC. All we did was carry it forward more powerful with what we have with what I call 3rd generation TI Portal.
Yep. And so Chuck is actually on site right now. As you can see, he's in a control room doing some TI Portal commissioning. And Chuck was kind of thrown into this, due to some scheduling issues and COVID problems. Chuck ended up having to go on site and commission a project in Portal. And he is not a Siemens Portal programmer. He had to sort of learn it on the fly. So Chuck, what were your first impressions when you got on site and started doing this?
I just came for IO checkout, right, Ron?
That's right. It starts that way.
4 months later. To add what you just said, the simulation feature is the best. That has helped me so much, because the built-in simulation you can take back to your hotel after, archive the program. You don't have to be here, and you can run something through to check it for the next day and stuff like that. That by far is the biggest thing in Portal I like.
And what's great about that too is PLC Sim is built in. I mean, it comes with Portal.
Yep. The diagnostics is another one. I agree with that 100%. You can see it right in front of you. It flashes red. I just switched 2 points this morning. That's one of the things that, I forgot to spare the other points. I switched from the RTDs. It told me right away. But it tells you specifically what the fault is. Now, unlike some other platforms, they don't tell you. They'll give you a 16-pound, and then you go look it up. Portal tells you have a broken wire, no power supply, etc.
Yeah, I want to add something to this to this question. And I know, being in Siemens, right, it's a little bit biased here for me, and everybody's like, we don't want to hear from you, Louis. You're a Siemens employee. But not many people know this. I actually, when I started out in controls or automation, I was in school. I had an internship, and I was there for quite a while. I actually didn't learn Siemens at all. And so my first time seeing TIA Portal and working with TIA Portal was when I joined Siemens. And the whole time I, fresh out of college, kind of learning different concepts, the thing that kind of like helped me learn Portal so quickly was, it sounds so simple, but just like the addressing scheme, just understanding how tags are addressed, just understanding how that looks into a computer, just like computer language, and how processors actually access information and stuff. It made sense to me versus what I was used to before. That was more like rack-based addressing and location-based addressing, which is okay for certain projects, but for larger scale systems, it's very hard to track those things, right? Versus something that's more register-based or specific address points worked out for me. The other thing I will say that Chuck brought up was the simulation capabilities made it so easy to pick up and test out different scenarios, which, you know, in the previous platforms that I had learned before didn't necessarily have that much robustness in the simulation. So where I was working before, we didn't even use it because it was just kind of buggy. It didn't really work out. And so I don't know, those two things I think stood out to me the most. It sounds very minute, you know, the addressing thing, but I don't know, for me it just clicked. It made sense. And just understanding, you know, fresh out of college and electrical engineering school, and the school I went to is focused more on the electronic side and understanding how computers process things. And I don't know, it just made sense a little bit more to me. So
yeah, for me as well, you know, as a computer engineer, you know what, we took so many high level programming languages, and that whole idea of object oriented programming, you know, that I know that's sort of a buzzword. That's an old buzzword. But that ability to build object oriented code and reuse it over and over again, it applies certainly in higher level languages, but even at the PLC level, you know, you build your valve object, you build your drive object and your motor object and reuse it over and over again. To me, inside of TI Portal, that was built in from the beginning, right? That ability to create those objects, it was all sort of designed in right from the beginning. And I think even back to Step 7 Classic, it was that way. Whereas I've worked with other manufacturers where that add-on capability, that that object-oriented capability, sort of evolved over time as versions were released. And once you bolt something on like that, it becomes a little harder to use. And the ability to change an object without stopping the processor is huge. You know, most of my customers are 24/7, and to be able to change those function blocks, add some functionality without stopping the plant is crucial.
Yep.
Chuck, you also mentioned commissioning some loops, and
Yeah, I have a bunch of PID loops here. Actually, I'm doing one this morning. I just did one. Portal's good with that too. It's very simple to tune these things. The internet helps a lot. They have really, really good videos out there. They pull up from Germany, show you how to do the tuning. But compared to some other platforms, the auto tuning is great.
yeah. What they did is it used to be we manipulated data blocks in whatever vendor to set up the PID to run based on the instruction. Remember the N registers, N7 registers, or whatever. Same with the classic world. Well, what they did in TI Portal was created some technology objects or faceplates that provide you a nice graphical representation of things like PID and motion, so that the user has a more intuitive view of what they're setting up to a technology that we're doing. Or it might be a PID, motion, RFID, or even a communication setup. So there's some significant things there. And I'll get to a couple of other questions, but I'm going to continue to let Ron and Chuck kind of banter back some of the other key benefits inside the TI Portal there. And then go on with other things that you kind of experienced as a firsthand.
Sure. So you sort of talked about the technology object. Natalia, if you'll show my screen, the one I have shared. Okay, so you know, I'm online with the 1500 here behind me, and this morning I just created a quick technology object for a PID loop, put in some simulation logic behind there so that I could actually do some auto tuning. And bring this up just a little bit here. So this is the auto tuning window, and to me it's intuitive how easy it is to do an auto tune. And I'm not going to click the start button just because it takes it a couple of minutes to actually run the auto tune. I will go ahead and turn the graph on here. And so I tuned it this morning with again just some very simple simulation logic behind here. So I'm going to go online with the PLC and my PID loop, and I'm just going to change the set point real quick so that we can actually see it move. You know what? I'm actually running this in this is the operator interface simulation. So I've got my HMI simulation actually talking to my live 1500, and I'm just going to put the loop in auto here. And now we can go back and watch this thing run. So inside the tuning window, now again, I'm not auto tuning here. I'm just sort of watching how the process variable reacts with the control variable versus set point. And so you can see where my set point there in, or my control variable there in red ramped up very, very quickly to 100%, trying to bring that process variable up to the set point. So even if you were going to not auto tune it, but just manually tune it, maybe you're a great loop tuner and want to do it that way, you can use this built-in window here to watch your tuning parameters. And then the technology object itself, you can see there are functional views here where it's very easy to set up exactly what your PID loop is doing. And then you can even swap over to, instead of a functional view, just go to the straight parameter view and actually manipulate the parameters directly, the sort of the expert mode. So no matter if you're just brand new to PID loops and Portal and you want a very easy wizard view to tune the loop, you can do that. Or if you're a process guy and you do a ton of loops and you want to skip the wizard and go right to directly enter in parameters, you've got that view as well.
I think the one thing the focus was on this TI Portal framework was usability, so that the user didn't have to open the manual to figure out how to do something. So the objective was to create these landing pages that you kind of could tell right away what to do and click. Like if you open up the force table, and you can do that a little bit later, but there's just one entry field where you type the signal and then you hit start and you start, or not the force table, the trace, to capture the trace signal. You just open the trace signal, you type in your signals, and you hit start, and it's ready to go. You don't have to do the traditional German thing of setting up all the parameters and setting up all the cycles that you want to do it. I just want to capture it as fast as I can and see what's going on there. So those are a lot of the things that I felt like we focused on in the usability in headquarters in the development of it 10 years ago, to make it so that it's easy to pick up for somebody without having to read the manual.
The great thing about the trace tool too, as well, is that it's happening in the PLC. So if you want to grab a sample every IO scan, you can do that. You can really see some cause and effect type stuff. And you brought up watch and force tables, Chuck. I think you had to sort of learn about the watch and force tables on the fly with that IO checkout.
Yeah, the force table worked out for me because the way, well, it was a little different to begin with because Siemens does the addressing different. So it's not by rack, slot, and then the way everything's addressed out. So I had an issue when one of the points was wired wrong on one of my cards. But you can go into the watch table or force table and put all the points on the card, flip the point in the field, you can see which one was lighting up, even though it was a spare. So that was very helpful. Another thing with the whole tuning, I like it, but the only thing I really don't care about it is maybe some of the set point and the PV that we talked about before have to be so close. That sort of makes it a little difficult. But other than that, the force table is just like pretty much most of the other platforms, except you can list them all out. You can list them out and skip lines and do it by rack too if you need to.
Hey, one thing I wanted to ask is, Ron, you mentioned earlier that one of the things that you really like about Portal, you know, obviously being in the service industry, time is money, right? So if you can do a task that saves you time, therefore saving you money and saving your customers costs as well, is what is it about like the technology objects that helps you do that faster? Is it like, does the wizard actually help in that space, or?
Well, certainly if you are new to, and it's sort of like what John said too, you know, not having to open up the manual, you know, knowing the existence of the technology object. And I was sort of first introduced to them, you know, via just controlling a VFD, via you know, a motion control via technology object. But while I was doing that, I saw, oh, there's a PID technology object too. So at that point, I thought, okay, well, let me explore that. And so they've got the PID compact, and it creates all of that, all the necessary tuning parameters and auto and manual, and you can tie analog inputs directly to the block, or you don't have to. And the technology object, it spells that out for you. So, you know, to me, not knowing how to set up a PID loop inside of Portal, inside of a 1500 or a 1200, the technology object really jumpstarts you with that process. To go and do it again, you know, I would probably, would I? I would still go through the functional view and set everything up initially because it's just such a time saver. But then once I start tuning and that kind of thing, I'd really probably prefer the parameter view so I can see everything that's going on.
Yep.
I thought you were going to head down the diagnostics trail there as well.
That was going to be my follow-up. So I guess, yeah, so on that note, also, we mentioned diagnostics being another big feature that you really liked about TIA Portal, in general, the Siemens platform in general. So how's that? I mean, you mentioned being able to troubleshoot quicker, but from the engineering perspective, how is that able, what is it about the diagnostics that's able to save you guys some time?
So I have developed very large systems. So I had another manufacturer. I think I had maybe around 10 remote IO chassis, and each of those were like 17 slot chassis full of IO. And if we wanted to go through and pull back diagnostics and an alarm on the operator interface, so if a card has failed, if you've got a loss of 24-volt power on the analog input card, something like that, if I wanted to get down to those specifics, I would have to program some logic in the PLC to interrogate the IO module, pull back the fault code. And Chuck, you and I were talking about this before. It's just going to give you a hexadecimal number, you know, 000 through FFFF. And from there,
go look it up.
You'd have to go look it up in the help file. If you want to display that on the operator interface, well, that is a ton of work. Okay, well, if it's error code FF, then that means, you know, loss of 24-volt power. If it is, you know, FE, then it's this, then it's that. So typically, and what I did for this particular customer was I just said, okay, if it's non-zero, set an alarm on the operator interface, let the operator know that there is a problem, and then they would call somebody, you know, the engineer or the tech to say, look, we've got a problem in a rack. I don't know what the problem is. Can you get online with it and tell me what's going on? And quickly, because I don't know if I need to shut down or not. With the built-in diagnostics inside of Portal, it gives you all that information automatically. So Natalia, can you show my screen one more time? I'll
You're on.
Okay. So this is the built-in diagnostic control inside, and this is just a WinCC comfort panel. So if I go, and I'm going to go ahead and drill down just so we can see this, my ET200 SP, which is remote IO. So here are all the different modules inside the ET200 SP rack. And I'm going to just reach back here and pull out the digital output module. And so, very quickly, it's letting me know that I've got a problem. And I don't have this one set up, but there's also a built-in diagnostic pop-up that'll, so that you don't have to be on this particular screen to actually see this. It'll pop up, let you know there's a problem, and you can navigate right to it. But what's great about this is it's letting me know this digital output module has failed. Zoom in here. I can drill down and scroll down just a little bit. Not only does it let me know it's failed, hopefully everybody can see my screen okay there, but it also says hardware component removed or missing, and it gives me some possible resolution there. Connect or plug in the hardware component, check the power supply, check the presence of an interfering I/O controller or supervisor. All that's built in, and it's for every I/O module in every rack. It's any VFDs that you may have hanging off of Profinet, and zero work here. So obviously it's important for me as a systems integrator to minimize how much work I got to do to get this information. But then for the customer, they can very quickly troubleshoot. Now the operator can say, I've got an error. It's saying that digital output module in a particular rack and a particular slot has been removed. Can you go check it out? And so now he knows exactly where to go, which cabinet to go open up. And on my side, it was no work.
It's also good for IO checkout too, because as soon as you see that coming in for an IO checkout, you see it tells you what point it is, and that'll tell you a broken wire. So if you have an analog coming in or something, right where to go. Yeah,
Chuck, and what you mentioned. So this is on the operator interface, but it shows this also at the bottom of TIA portal in the inspector window, and it's the exact same information, the exact same view.
So there's two views. There's always the alarm that shows up on our alarm view, and there's always the graphical too. And that's what I like, is the fact that I'm looking at the hardware page, I'm online, and I see something that's not green, and I'm like thinking, hey, there's a orange or a red error on an I/O module, and it doesn't have to be a Siemens I/O module. If it's on Profinet or Profibus, it's part of the standard of reporting those errors. And to me, the fact that there's two different means of recognizing a consistent error, and it doesn't matter if the machine was done by Prism or another vendor, if it's built with these components, it's going to report the same consistent, reliable diagnostics. And then the other thing is the diagnostics you're seeing animated on the hardware page are also animated on the hardware. So when you walk in out and open up the cabinet and you look at that AT200SP behind you where you pulled that out, its flashing lights match exactly what's in the software. So you become very familiar with, I got a flashing light on the PLC. And
it also shows it to you on the front of the 1500 on the LCD display. The exact same information.
And on the web server, if you happen to have a HMI. I mean, to me, this is one of the most significant things if you look at the TIA solution is when you put all these automation components together, the PLC becomes a true alarm server, a report system error in generation 2 of the Somatic S7300. So they just evolved it into here. And you can bring that into the blocks, the function block with process diagnostics. You can set an input as an interlock against another input, such as a release, and it automatically is going to generate an alarm onto those same means. It's so simple and easy, and it becomes consistently reliable diagnostics. Because I think that in the past,
one thing I'd like to recommend as well is when you're specifying I/O modules, typically, or in some cases, Siemens has 3 different level of I/O modules. You've got the BA, which sort of has, basic diagnostics. You've got the ST, which has standard diagnostics, just a little bit more than the basic. But then you have HF, which are high feature I/O modules that give you the most diagnostics. It's by channel, and you get things like wire break and short circuit and loss of 24-volt power. And for me, that is, if I'm specifying I/O, I always go with the HF modules. The diagnostics really pay for themselves. A great example, if you'll give me just a second here, I was doing a project where we had these silos that were 120 foot tall, and we had an I/O rack on the top there. And so we were commissioning, and there were some solenoids up there, and we needed to of course, check each solenoid by stroking it from the control room, which was at the bottom of the silo. Well, whoever installed the solenoids didn't seal them properly, And so anytime it rained, they would fill up and with water. And as soon as you stroked it, it would blow the fuse in the IO panel. Because I had gone with HF, high feature IO modules, I could immediately tell the electricians up top, hey, fuse so-and-so just blew because that solenoid is full of water, because it told me exactly the rack, the slot, the channel, and that it had lost 24-volt DC power, which immediately told me that the fuse had blown. So I can very quickly, based on the drawings, tell the electricians up top, go replace this fuse, you just blew it, and by the way, get the water out of the solenoid and seal them properly.
Hey, Ron, another good item to maybe bring up here that I saw was maybe show them how to change an IO point, because that was really nice. Quick, easy, because it's all not based on slot.
The rewire, yeah. The cool thing is that they really do think about all scenarios, and there's the case of what do you call it? Just renaming the tag or the symbol in the classic. But the other concept is, hey, I want to move the input to a different point, and it's called rewire because you've rewired it, and you're just basically changing the address, and it's simple and easy, and the tag name stays the same, and it's applied everywhere that it was in the logic before.
And that's sort of the trade-off too of, some manufacturers tie that IO point, its location, to the tag name. So it's by its rack number and its slot number and its point number. And Siemens doesn't do that. And I get the question a lot, well, why not? It would be so much easier. Well, one of the cool things that you can do with a Siemens IO rack is, let's say you've got 3 digital input modules lined up in a row, and then you start your digital output modules. And then years down the road, you filled up, even though you factored in 20% spare, as customers will do, it filled up, and now you need to add another digital input module. Well, if you're like me, I don't want to just tack it on to the end of the rack after the analog output module. I'd really rather put it in between at the end of my last digital input module and just shift everything down. Well, if you do that in some manufacturers, that changes all the IO tag names. But with Siemens, it doesn't do that, because that IO tag name has nothing to do with its location. So I can put that digital input module in, shift everything down, and it doesn't affect any of the other tags.
Hey guys, hey Ron, John, we've got a few questions in the chat. I want to just take a moment to ask those questions. And just as a reminder to the audience, to you guys tuning in, if you do have any questions, feel free to submit them in the questions box down below on your screen. If you don't get a chance to submit them live, you can always submit them afterwards. But and unfortunately, we don't get to see who asked these questions. We only see kind of some initials. So I'm just going to go ahead and ask the question that comes up. One of them that came in was, any plans to have multiple TIA for multiple engineers work on the same time? Have multi-user interface. Okay, so I guess to kind of rephrase that question, how do we do multi-user engineering? So Ron, you guys obviously being in a system integrator role, I'm sure there's plenty of projects where you got multiple engineers on site trying to collaborate with one another. Can you explain how that process looks like with the TIA environment, and what are some of the advantages you see of that with TIA portal?
So not even online, but let's say you're just developing in the office as well. If you use multi-user engineering, and I believe that is licensed separately. John, you can probably, as a systems integrator, we sort of get our package every year, and I don't really know exactly how it's licensed, but
each user needs a license, yeah.
Okay. So what multi-user engineering allows you to do is you've got a sort of a central repository server where you put the project up there, and then each person inside the facility there can have access to that, and they check pieces in and check things out as they modify them. And what's also great about that is I can be in my TIA portal and I can see, someone is working on this particular function block. I don't need to open it right now because somebody else is working in it. So by the function block, by the data block, by the function, that is so much easier to collaborate than having to have bunch of people working on separate projects, and then you have somebody that tries to merge all of that back in manually. It is so much better just being a check in and check out, and you can tell who's got something checked in, and it'll keep up with those changes as well, so you know what change they made and who made it and why they made it if they put that information in there.
Yeah, so the feature is part of the installation. So the TI Portal framework starts with Project Server, and basically you as a first-time user with your own project, you can check it into a server and put it up there and do that exclusive engineering one-to-one without any licensing. And then as soon as I start working with Chuck or Ron collaboratively, I just turn it into a multi-user, and each one of us just need a license multi-user. It's a couple $100. The other ways are libraries. Sometimes people just pop it, the HMI or the drive that they configured for the project into the library. It's a standard object. What's cool about that is if it's still referencing PLC_1 or PLC mixed tank as PLC number 1, it'll synchronize the tags up there. And another thing that some people use is there's a thing called a device proxy. So once I set up my PLC, I can actually create a fake proxy for it that I export out of TI Portal and import into an HMI project. Some people did that with the classic S7 300 connected to the newer HMI. You just make a little container that says the IP address of the PLC is this, the propane name is this, and here's the tags that are available from that TI Portal device. So there's a variety of different ways that people can work together. Reference project is another really cool tool to use. Is I just open a viewer to the reference project, I get a read only, and I can drag your PID out of your project into my project.
And you can also you can have multiple people online with the PLC at the same time as well. And even through multi-user engineering, you can do online commissioning in a collaborative fashion as well. So to sort of follow up on that last question.
All right, we just got one in too that I think is pretty good. So someone asked, or maybe more like a comment, but I think we have a good discussion for this. I think TIA Portal is lacking on bulk engineering tools. I'd like to see some development into a nice interface to generate or instantiate code quickly, i.e. add 200 valves, 100 motors, 400 analogs, etc., into a project via some sort of import utility. So updated imported codes afterwards would also be a plus. So to me, when I read this question, the one thing that I think of, John, just this is maybe more for John or Ron if you've used this, is the openness, TIA openness capabilities, the ability to automate the project generation. I don't know, Ron, if you have any experience with TI openness, or John, if any of you want to add any comments to the use cases of TI openness, maybe some instances where you have used it and it's benefited you and saved you some time.
So yeah, I'll start that. Yeah, we have some experience with openness. That idea of bulk engineering obviously is important for systems integration.
Ron, are you okay?
No worries.
Take a moment to help out Ron here. There is an openness tool that is built into TI Portal. Is it included with the install? And the whole purpose of it is to basically provide a very proper way to auto-generate or instantiate logic and duplicate these things over and over again. And what's nice about it is you can do a multifaceted thing with the openness to generate the PLC section of the blocks, and then use CVR, Siemens Visualization Architect, and that's another tool that you can build into the library objects for the HMI, and it automatically generates the HMI solution for the HMI part. And we have actually done some real good customer demos when they want to get into this step of testing that out in real world applications.
Hey, I completely forgot about CVAR. The other thing that I wanted that I think about when I think about the instantiation is, and I guess I kind of left out in my original question, or in that question, was the instantiation of devices on your HMI, right? So if you've got X amount of motors, how do you quickly add a faceplate for that many motors without having to build that out for every single instance, right? If you've got a plant with 100 motors and things like that. So CVARC, I think, is another tool that I didn't even think about that helps out with that situation, along with the use of like faceplates for the HMIs and things like that, or even global libraries or local libraries.
Sorry about
welcome
that.
back, Ron.
Sorry.
No worries.
So Ron, I don't know if you need me to repeat the question. We were talking about the use of openness to kind of quickly instantiate things like motors, valves, whatever the case is, without having to manually like drag and drop those things into your program. How have you done that in the past? Have you used something TI openness, and has it
We
helped
have.
you in those cases?
We have. We've developed things in Visual Studio with openness, and for that exact reason. As an engineering company, you really want to be able to. All right, I've developed this great valve function block. Now I've got 100 valves out there, and I want to automatically instantiate it, tie the I/O to it, and not have to do that just exhaustively. So yes, we have developed those tools to do exactly that. Now, you do have to have some Visual Studio programming skills to do that, but we certainly have that in house where we can do that, and we have that. That's the way we do it.
All right, so DB, if you're listening still, I hope that helps answer your question or helps guide you for your next TIA project. I don't know.
The other key to that, Lewis, is the fact that the libraries. So GA4oo framework provides inclusive for the entire automation solution is project libraries that objects are part of the project when they roll out, and the global library where we can work together and reuse valves or scaling function blocks and other things. And the benefit of these, and it can be hardware devices or PLC blocks or HMI screens or faceplates, but that's what the openness and the CDR build off of, is to generate those general repopulation of objects out of the library. So the libraries are a huge part of that kind of creating a standard and evolving a standard, and then evolving how to do mass generations of deployment of these solutions for the future.
All right, so the next one I see here is, I think we touched on this already, but I'll ask it just to repeat for those maybe who joined a little bit later. The HMI has full Profinet diagnostics. Can we get this info back to the PLC? If I'm not mistaken, we already kind of answered that, and Ron demonstrated a little bit too as well with the PLC and TI portal, but I don't know if you guys want to expand a little bit more on that.
Yeah, I think the specific question there is, all right, so let's say we've lost this digital output module. The HMI knows about it, but what if I want to take some action in the PLC because I've lost that? And so there's an instruction set inside a TIA portal. It's under the diagnostics heading where you can actually pull back that fault code information from the module and then take some action based on that. You've also got the diagnostic organization blocks, or OBs, that you can automatically do something as well if you've lost a rack or anything like that. So yeah, you can go specific down to the IO module, or you can sort of do a broad based where if you've had any kind of failure, you can safely bring the plant down.
Yeah, like event based, right? You mean? Perfect. All right. John, I don't know if you had a comment.
Yeah, I think Natalia wants us to kind of get ready to wrap up so that we close this off in an hour. But it's a lot of topics, and like Natalia mentioned in the beginning, is can you pull up my screen, Natalia? In the beginning, we hope that we might do some more of these discussions around topics. We could get deeper into something like openness and CDR. But we do have a suite of tutorial videos on our resources.dc, siemens.com, TIA, and I think TIA is going to send that out, where we can get in. You can get into a deeper dive, and then we also have videos that come from our partners or people that are doing this stuff. So if there's anybody that is participating in these webinars and they have a unique application where they've implemented something with TIA or TIA portal into a unique situation or solution, or taking care of a really interesting application, we're always open to taking your feedback. Just respond back to Natalia and tee it up that you're interested in participating in these partner pages and providing some interesting videos. We've had people provide license manager in the Amazon cloud, done podcasts on different technologies. We've even done test suite, and style guide proof of concepts, and version control interface for using a Git repository. So there's a variety of different things that are available to talk about what you can do inside the TIA and the TIA portal and work together. And then in the download, we put in a nice link to other customer references that talk about this. I want to really thank Ron and Chuck for taking the time today to kind of touch on some of these key topics, and hopefully looking forward to a chance to do this again, potentially with other applications or other ideas that come up related to talking about what the future holds in the automation as we look into the next 30 years.
Indeed, what a great discussion. Thank you, gentlemen. Let's continue taking more questions and talking about TIA in the Q&A session.
And we're back. Thank
Hello.
you for sticking with us. Ron is here with us as well. Ron, it is great to see you. How's the cat? You okay?
Cat is fine. I've got
All right. Well, we are all about animal rights here as well. So great to have you. Thank you for joining. Here on stage with me is John Detel and Louis Narvaez, and Ron Knight from Prism is joining us live remotely as well. And what we're going to do next is we're going to take questions from the audience as they come in. As I previously said, I'm here with my trusty iPad, and as you type in questions, they appear, and I'll be able to scroll and ask them. But before we get into questions, I had one important announcement is that throughout the Q&A sessions today, we do have polls that we're running. And those polls are an opportunity for you to voice your opinion on different automation and industry issues. They are multiple choice, so whatever you think is the right answer, you pick. I wanted to know that if you are watching us in a full screen mode, you don't see the polls appear. But if you minimize it, the polls will appear on the right-hand side of your screen. So please participate in the polls as they happen. We're going to run some during this Q&A as well. But with that, let's get back to it.
Sure.
And my iPad timed out. Here I am. Okay. So we actually had a few questions that came in, and the first one I think it's a really good starter question to open with, and it came from Stefan, and he's asking how to get started on TA Portal.
Okay. First option is to download the software. So the installation of TI Portal trial download is available on our Siemens Industry online support site. It's a free download. You just have to register and get yourself established with a valid login with this industry support site. And you can download the software, load it, and it fundamentally has a 21-day trial. Any other comments, Louis?
Yeah, I think, I mean, there's lots of ways to get started. I mean, I think most people tend to like Google things or YouTube. One of the things I would suggest Googling, Siemens, we have some free online instructor-led type mentoring courses that you can take. Just Google TIA University. That's, you know, a good place to start. We also have, like what John showed earlier during the panel discussion, Siemens Knowledge Hub, TIA guided tour. There's tons of on-demand content that people can watch and learn how to do different things. Or reach out to your local distributor or system integrator like Ron A lot of them also offer on-site mentoring or training services as well. Sometimes they're at no cost. Sometimes, depending on what your needs are, they could be for a small price or whatever. But in the end, there's lots of options, right? Both free on demand, free live, paid live, paid on site, whatever the case is. So
yeah, that's what I was going to say. The local channel is the best resource to get in person support with your solution, and then also they have a suite of custom packages of workshops that can be simple top end TI portal overview, or go into the basics of safety, motion control, HMI, and other topics. Thanks.
Yeah.
All right. Thanks, gentlemen. We actually going to go back for a second. We had a question previously that was asked in our previous session. Somebody had asked about conversion, and one of our live attendees here is commenting, Kim is commenting, that we just converted a comfort panel to an old multi-panel. And other than the screen size difference, it was a drag and drop. Any comments on that, gentlemen?
Ron, you want to start?
I hate to jump subjects, but one of the things that was talking about when we were on the Q&A panel was the idea of bulk engineering. That was right before the cat interrupted. But I stumbled across, since that Q&A, I stumbled across on the Siemens website, there's something called TI Portal Excel Code Generator. And so you can actually, in Excel, create like valve objects and motor objects and all of that, and auto instantiate them in Excel, and then have it automatically come into TI Portal. So that is a free tool. The bulk engineering, that whole idea is you don't have to have Visual Studio experience. You don't have to be a programmer, all inside of Excel.
Yeah. And then I want to add to that based on that question, in my past experience, the 15 years I've been here with Siemens, is we had a customer in the old Pro Tool, which was previous to WinCC Flexible. And they had HMI panels running on the machine. They needed to update a cracked unit. And they went with the new MP TP panels that existed in that time frame that was based on WinCC Flex. And we helped migrate. It just opened the project from Pro Tool into WinCC Flexible, and then into the next generation, which was WinCC Comfort Advanced. So there's always been a real good focus on Siemens to support what was the legacy devices and bringing those into what we're doing now. And there still is a focus on that in the future, especially if you look at the PLC, which is the most critical. If you look at the S5 with function block programming, input and output addressing, that migrated into the S7-300 Semantic Manager. And we still carry that forward with so many of the concepts that was part of that generation, so that our users can migrate into what is this generation, the TI Portal with the S7-1200 and the 1500.
Yeah, I think one thing that to point out in that kind of stood out to me is the concept of just standardization. So you brought up like migrating PLCs, for example, and I think what helps with that is kind of adhering to a standard, right? And so things like IEC standards, IEC 61131, definitely like, kind of staying as close as possible to those types of things definitely help with that migration effort. Even if like you're converting, for example, from like a third-party system, it definitely helps when you're migrating into a Siemens or into, to have that consistency across that's aligned with those international standards. So just my comment
Good point.
on that.
Yeah, absolutely.
That's
Standardization and being able to apply what we did last time is key to our success as we go forward, right, Ron?
I agree.
Sure. And
Yeah,
as I
and
scroll
I mentioned that in that last the Q&A we had before. Now that I know TIA Portal and all those terms, it's much easier for me to go back into Step 7 Classic, and heck, I might even be able to tackle a Step S5. I don't know.
Yep.
I'm not sure I'm going to do that.
Yep.
All right. Thank you so much, and apologize for cutting in there. Also, I appreciate all of you guys commenting live. If you're having trouble hearing or anything, that allows us to know how it's coming through. So if we need to up the volume, we'll definitely do that. Another interesting thing is fun scrolling through the questions and realize that your audience is there to get your back, because some questions that were asked got answered by other people online. Yes, they do. However, I'm still going to go and vocalize it because not everybody's participating in the chat. Not everybody's following it. And I think it will be useful for others who are listening in live. And we do have a couple of hundred of you at this very second. So I want to make sure everybody's on the same page. So one of the question was, is the TA portal available in subscription or and cloud solutions?
Yes, it is. So in addition to the existing or what people are used to, the perpetual license that lasts forever and is upgradable, we recently introduced the concept of an annual subscription as an additional seat. So if I have an install base of 6 or 7 licenses and I want to add 2 new ones, I can roll those 2 new ones in as a subscription and start on that process of running my department based on annual subscriptions, where every year it's renewed and I get an updated license. It's fundamentally the same process in the download of the software and the download of a license into our license manager, except for the license has a 365-day set point on it that gets updated next year. And updates that come out like this November when we release the next release of the software, they'll get the update and the license will run on there. And then we're starting to introduce the concept of TI portal in the cloud, where you have access from your computer without any installation to be able to access the engineering software TI portal in a cloud environment and do some preliminary stuff. Right now, for the USA, United States of America, it's strictly a 21-day trial. So you again have to have a login to that industry support site and go select the premium services, find that cloud, and you can play around in it and do a trial for 21 days. That's another good way to get started with TI portal. And eventually, we're hoping to add that or augment the existing licenses. So we have a variety of different things, and one is not going to go away to replace the other.
Yeah.
Keep that scalability.
Yeah, flexibility too.
Yeah.
Keep the flexibility and scalability coming. Speaking of, there is a question about that, a little bit of a slightly different topic, and that is, John here is asking, system diagnostics are great, except for when we don't have Siemens components within solution? Question mark. Ron,
the last end of that cut off.
Yeah,
if we don't have
repeat that. System diagnostics are great, except for when we don't have Siemens components within solution? Question mark.
I'll start with that, Ron. What I see the customer asking is, we don't always have in the Siemens or in the TI portal system-centric approach where we lay out the architecture. The PLC is the alarm server collecting all the diagnostics from the entire network for everything that's on there, even legacy stuff, Profibus and the old I/O. It also collects standard diagnostics from the device because it's following the standard, the Profibus, Profinet standard. So any component that's put onto that network, regardless if it's Siemens or third party, is actually being tracked by the PLC as an alarm server for that system-centric approach of the system diagnostics, and it's being collected. So it's going to come up and say something to the effect of not reachable, or there's a fault. That system diagnostics approach that we apply with the PLC, it is complete. Every device that you configure for that PLC, regardless if it's a Siemens component or a third party, is still going to be reported by the PLC and enunciated in the LEDs on the front of that PLC. You see there with Ron, he's got solid green lights. There'll be a light indicating that, hey, I'm not able to reach that brand XYZ device, and it'll come up there and give the text and the graphical in the TI portal on the display, on the HMI, and on the display. So it's complete and it's consistent regardless of the programmer or the OEM. Some of the other guys implement system diagnostics only on the newer hardware and only on the newer controllers. And that kind of limits the benefit of that functionality if it's not complete and capable of doing everything on the system. Because that's what the maintenance people
and the
depend
level
on.
of diagnostics, I would assume, would be part of the GSD file that particular manufacturer creates. So it's really on that third party to include those diagnostics and diagnostic messages as part of the GSD file that you bring into TI portal.
Right. Yep. Yeah. I'll add to that too. Is I think like John mentioned and like Ron actually mentioned during the presentation and showed something cases of when you get modules that have that increased diagnostic feature, like getting down to the specific channel and being able to determine that, a wire is broken or a fuse is blown or, things like that. I think, that's part of the story where, sometimes it depends on the device manufacturer and the features of that specific device. But to your point about like that being integrated in the Profinet standard too, is that all that stuff happens on the back end. So there's no programming needed. There's no configuration needed of that kind of stuff. It's all built into basically the firmware of the controller, and it's displayed anywhere you need it to. The PLC, the HMI, if you want to display it on the HMI, you can access it from GA4oo Portal. You can access it from other diagnostic or maintenance tools like Somatic Automation Tool or such. And the other thing too that I think is beneficial is that to prove that it's kind of built into the firmware, oftentimes we usually like put the PLC in stop mode and generate some sort of fault, and then fix the fault and see that the alarm diagnostic message goes away immediately while the PLC's in stop. So there's no code running, right? The controller's in stop, and so it's able to get those diagnostics, and it's easy to troubleshoot. That's the key. Clear text, simple text.
Yeah.
Wire break on channel this, station this, and if you put other information like the location in the plant, then it's even better and reduces that downtime and spent troubleshooting faults.
And coming back to what you had said, John, one of our attendees here is just wanting to clarify when you were talking about the light, were you referring to SF or the BF light?
Both. I was mixing it. Yeah. So that is an interesting comment because yesterday we were talking to someone and asked them, what's the first thing that you see when you look at the Siemens PLC? We were hoping that they would recognize the display, the integrated display that provides all of the information that's inside the controller as far as system. But honestly, the first thing she said is that flashing red light. And and what's interesting about that is, that's where I grew up in a plant was, you want and you have an expectation that the lights are green. And solid. But when you did find that flashing red light, what's great about the Siemens world is it's a legitimate diagnostic. It's very powerful in self-diagnosing the fact that, hey, it recognizes something is not necessarily configured properly or something in the peripheral device. So it's legitimately a diagnostic that is helping you. And the PLC is still in run mode. Even if there's a system flashing light or a bus fault, the PLC is still in run mode. It's just giving you more diagnostics. And part of that is the LEDs on the PLC and the I/O, so that the maintenance guy inside the panel can see something to worry about. And then the second part is the fact that it's in the software on the HMI consistently the same way.
It's great that Jared asked for that clarification because we actually have more questions about lights. So
it's not Christmas time yet.
Right? Exactly. So let me go to this one. Is when it comes to the Siemens PLCs, there does seem to be a fault light on them more than the other devices. Can you relate that fault light indication to what you call in the Siemens diagnostics?
Yep, same question. Yeah.
So it's the same question. So we hope that John had answered it.
Yeah.
Very timely. Okay. One more question. This one came from Jennifer, and that is, when it comes to implementation of a standard over a long haul time, can you talk about some of the benefits of using Siemens?
All right, so I'll take that initially.
Standard over the long haul over time.
Yeah. So to me, as a systems integrator, we have a lot of different customers, and they typically have their own standards. And what TI Portal has is the global library, and that global library, we will have a global library for each of our customers because they have different standards. And that global library is going to reside up in some network folder or share where all the developers can get to it. And then the ability to, when new versions of an object, a function block or a function are released, everybody, all the developers can then go and open up that global library and push those new versions down into their controllers and do it all at once. You don't have to go one by one and do a bunch of drag and drops. You update instances in your project, you download them, and you're now up to the standard. And so the long haul is you're not having to use external tools. It's all stuff built into Portal.
Yep, agreed. Yeah, what's significant is I grew up in the automotive in Detroit, and South Carolina and other places. And we implemented a standard from one project or one build of a vehicle to the next standard of the vehicle. And the big frustration for me in the 90s was starting over again and basically copying code. And the risk of copying code and getting or expecting everybody to implement it is that it gets changed or modified or not properly applied. But as soon as you can encapsulate something in a function block and put it into a library, we also support the ability to give it a version or a type and manage it as a type library. And then we also support, once it gets deployed on the machine, the concept of team engineering, where we check those things into a server and have some traceability. So there's a lot of power in the TI portal framework to support the concepts of standardization. And what we're looking out to the future is the concept of more continuous integration with other tool sets that users are familiar with in that programming world or that team engineering framework with version control interface. I think one of the topics that I saw in the chat earlier was version control interface, version control. And we're really deploying that functionality inside TI portal more and more with the concept of repositories and the ability to manage the code in the PLC to that concept and other concepts coming in the future. And the concept of unit testing with Test Suite so that you have the ability to validate your valve control, your motor control, your drive control in a unit testing functionality with the Test Suite concept. So there's a lot of things that have evolved in the concepts of Somatic and Siemens that really support a user as they go from one project to another project and implement standards instead of deploying it from a copy of a project file.
That's right. Thanks for that, John and Ron. I'm going to have one more question at you, and then I'll take one because that's regarding the links and downloads and all of that. So I'll take that one. So here is a question that came. It says, what options do you guys recommend that should start with? What options do you guys recommend that we should start with when it comes to debugging and validation of my solution without the hardware? And what hardware is possible?
Do that simulation. Want to take that, Louis?
Yeah, I mean, I think right now, I mean, one of my favorite things to talk about with TI Portal, with our controllers, is the ability to simulate and how it's been that way for a long time. I think a lot of people don't realize the benefits of, we hear a lot of talk and like about these buzzwords of like virtual commissioning and software in the loop and digital twin and stuff like that. And
we
it's
talk
not
about that today.
yeah, yeah, exactly. And it's not a new concept in theory, but it's been something that we have been building on for years, for decades, really. And it's not something new to us to be able to simulate your PLC to test your code. And it's not just like used to like test your code to validate your code. It can be used for testing like diagnostics as well. So in the case of like the question asking like best practices to validate, debug, and also validate diagnostics, with PLC Sim built into TI Portal, it's not even like a charged software. It's built into to the engineering. It's included as part of the engineering tool. You can simulate your PLCs, both standard, safety. You can simulate your logic, simulate diagnostic events, motion as well. So it's a pretty powerful tool. And then when you go into like the PLC Sim Advanced tool, which allows you to tie in other co-simulation tools, like when you have your 3D model of your machine and you want to tie that to your PLC code and see, the PLC controlling some actuators and moving things on belts and producing a product or something and debug that way, you're essentially doing acceptance tests like you would do on the factory floor. Then that preparedness going into the on-site commissioning or on-site acceptance test, you're completely prepared. You've done all your debugging ahead of time. You've done all your diagnostic checks, and you're in and out in a day pretty much. So,
Ron, another product. I was going to add. Simit is another Siemens simulation solution. We use it quite a bit, both with PCS7, which of course is the DCS side of things, but it also works with TI Portal and PLC Sim Advanced. And with Simit, you can create libraries even in Simit for your simulation logic. So that idea of pushing standards even further down the road, you can be sitting in front of your station doing all the programming, have a standard simulation library, have your standard code library, have all that working together. You're right, Lewis. It saves a ton of time when you actually go on site.
Yeah. And I want to add to that too. Like Lewis said, Semantic Manager in the 2000s, 1990 had PLC Sim, and it allowed you to simulate the 300, and it had sim tables so that you could check on the boxes. You didn't have to write code in the PLC like you do with some of the other emulators that might exist out there. You got to write some logic to toggle the outputs true based on when you want the or the inputs true based on when you see the outputs. So you got to write some logic in there. In the Siemens world, you take the exact same project that you loaded in the PLC and you load it into our simulator in the PLC Sim. And like Lewis mentioned, the first step is to simulate the inputs and outputs, and there's tables in there to do that.
Sequences, everything.
Yeah, and sequences. You can browse the watch table. So that tool's evolved so that you could really get started without any hardware and learn the fundamentals. And it's supported for even the S7-1200.
Yep.
And the ET200S. Yeah, so it scales down to that basic control of the S7-1200. You don't have to worry about getting started with hardware. And then we also have hardware tools that allow you to simulate the I/O, other Simit components that allow you to do even further simulations. So it's a full suite that, like Lewis mentioned, has evolved. It's not something new that we invented over the last few years. It's something we've had for at least 20 years, and it's pretty significant and powerful.
In fact, we celebrated the 25-year anniversary for TA Portal just this year, so it's been a great milestone for us. And I know I said I was going to take the next question. However, we had a new question come in from Darren, and it really ties in well into what you guys were talking about in terms of simulation. So I'm going to go into that next. And Darren would like to know how easy it is to simulate a non-PLC device, for example, a drive.
There's so we do have, like in TIA Portal, for example, when you configure like a drive or motion object, there's a simple checkbox, right? You can have as like a simulated axis. There's also like within like Simit, like what Ron mentioned, we have modules or profiles that you can basically add on. I think our drives colleagues just released a package called Drive Sim. So that's a tool that we can use to simulate the reaction or the response and the behavior of our Synamics drives family, for example. If it's third party, I mean, I guess you'd have to go to those vendors and find out what simulation packages they have. But that's also the benefit of using something like PLC Sim Advanced with that co-simulation or simulation with PLC simulation with other co-simulation tools, is you can also tie in third-party simulation tools along with the PLC running your code. So even if you're not using the Siemens Simit package and you have some other simulation package that you use for other components or whatever, you can tie that in with the API or some of the standard interfaces with PLC Sim Advanced. I did want to add one thing. Sorry, it's still on kind of that topic of simulation that I thought about when you were just talking, John, was the other aspect that people don't think about, the benefit or the use case of simulating or testing your logic also, is not just from the debugging perspective or from the diagnostics perspective, but also adhering to standards, right?
That's right.
So
Very
being able
important.
to do checks on, like, sometimes customers want tag nomenclatures to be certain formats or want comments to be, certain ways or certain rungs. We have that ability within our software to also test against a specification. So, if you're an owner operator, a factory or plant, and you're working with, say, Ron Knight from Prism System, and you give him a certain specification document and say, I want my tag names to be this name, I want, certain, basically any particular rules on the program itself, so that way my maintenance people are used to diagnosing and reading this logic. There's tools built in to test against that too. So we have the testing of the logic to be able to validate sequences. We have the testing of our diagnostics to be able to validate that our troubleshooting is as well. And then we also have the ability to test against functional specifications or any kind of specifications for the program itself. So I don't know, Ron, if you had a comment on that or on the previous question regarding like simulating drives, if you had any experience with that or
our use cases.
Yeah, particularly that ability to go and analyze how you've written the code, that you have followed the naming conventions, because we do have some customers that are very strict with that, and being able to at once, check your entire project to make sure you haven't named something incorrectly. Hey, we don't want underscores, we want everything to be camel case. It'll detect that and say, hey, look, you've got these tags, you didn't name them properly. Input parameters to a function block, output parameters, we want all of them to start with in and all the outputs to start with out. It'll check that to make sure you follow those standards.
And the other thing I want to point out is once you figure out or establish a process to do this stuff, it's not a one-off. Once you establish the process, then it becomes something that you can continue to do over the whole life cycle of your success. So if you're an OEM or an end user or a system integrator, and you figure out how to do this in the simulation world, how to validate these things for your testing, it becomes something that you use as part of your next project and your next project and your next project. And the benefit with Siemens
also
is,
helps when you onboard new engineers too.
Yeah,
Very important.
Absolutely.
Good stuff.
Good stuff. Thank you so much, guys. And I'm going to take one last question that is a little bit less portal centric, but it is as well, because as the session was going on, a lot of people were really interested in some of the links and some of the knowledge hubs that you were demonstrating, and they were saying, can we get those links? How do we get to it? And as well as some other people saying, hey, that keynote was so great. Can we get more information? So with that, I just want to mention that even though we are a one-day event, once the event concludes, we will keep the recordings, we will keep the platform open. So come back, watch it again, take a look at every QR code that maybe you missed because you were really trying to listen to the presentation, and check it out. Perhaps you had a colleague who had a conflict today, couldn't attend, but you feel like, wow, that was really beneficial for what they do. Invite them to come back, because the platform will remain open and you'll be able to access all of that information.
How long is that open?
We're going to keep that open till June 30th, so almost.
So we'll be here on stage till June 30th.
I'll just change into Flash and we'll be good. All right. With that,
thanks, Ron.
I would like to thank you guys for this Q&A. Remember, polls are popping up if you're not in a full screen mode. And at this point, we're going to take a little break. Everybody can go get some lunch and come back and join us for our next session, followed by our next live Q&A. We will be back at 1 p.m. Eastern. And remember, your active participation is rewarded through our prize packages. There are 3. The first prize package is when you participate 90 minutes, you chat with our experts that are sitting in the next room over from the studio and ready to answer any questions you may have. And if you also listen to 3 live Q&As, you get up to 250 points that you can convert in basically any prize you want. Do the same, but only 1 live Q&A session, you can get up to 100 points. And if you just listen to any of our sessions for over 90 minutes, you can get 50 points. So thank you so much for joining us for the first part of the day. We go on break and we come back live here at 1 p.m. Eastern. Meet us on stage.
Perfect. Thank you all.
Thank you.
This very minute, we're standing at the precipice of possibility. Once again, industrial innovation is transforming our lives. Cities stretched towards the sky. Electricity ushered us out of darkness. Computers enabled automation. Science reshaped our universe. Supercomputers got super small. Then connectivity leveled the playing field, creating new competition and accelerating demand for innovation. Now, digitalization has opened the floodgates, blurring the boundaries between the physical and digital. The opportunity is unprecedented. It means turning complexity into competitive advantage. The race is on, and the rules have changed. Products, processes, and people are united across digital threads, enabling hyper-connected systems to predict future outcomes. Engineers from all over the world collaborate, using a digital twin to design, optimize, and validate a product in real time. Data is fed to manufacturing, where adaptable production lines in every sector are digitally simulated before being built. The virtual and real join as parts are printed and tested on the spot, and variants are manufactured by the millions down to a lot size of one. The merging of hardware and software, design and automation, insight and optimization forms a continuous feedback loop to improve every part of the process and deliver value in unexpected ways. Siemens is enabling digitalization, harnessing the power of possibility to create at the speed of innovation, where today meets tomorrow.
Individualized mass production requires a high level of flexibility in machines and plants. This calls for new concepts for machines and plants, which in turn imposes new demands on machine building and plant engineering. In order to meet these market requirements, it is necessary to think digitally. That means integrating and digitalizing the entire value-added chain, and generating a powerful digital twin that includes the product, or in other words, the machine, its production, performance of the actual production of the machine, and the actual machine in operation. The digital twin makes it possible to merge the real world with the virtual world. The product digital twin, in this case the virtual machine, enables machine builders to handle the design, the simulation, and the validation of the machines without generating physical prototypes. This concludes the specification of the virtual machine. All this data is then used to create the digital twin of production, or, in other words, the virtual production. From the co-simulation of mechatronics and automation, machine builders can create an overall simulation model that serves as the basis for virtual commissioning of individual machines and simulation of entire production lines. Now we move from the virtual world into the real world. The PLC code is transferred to the real machine. Totally integrated automation enables an efficient, reliable implementation of the machine. This makes it possible to analyze and evaluate the performance of the real machine in actual operation. The insights gained from this are used to improve the digital twins for the product and production on an ongoing basis. This in turn leads to continuous improvements in production and in the machine in the real world.
This very minute, we're standing at the precipice of possibility. Once again, industrial innovation is transforming our lives. Cities stretched towards the sky. Electricity ushered us out of darkness. Computers enabled automation. Science reshaped our universe. Supercomputers got super small. Then connectivity leveled the playing field, creating new competition and accelerating demand for innovation. Now, digitalization has opened the floodgates, blurring the boundaries between the physical and digital. The opportunity is unprecedented. It means turning complexity into competitive advantage. The race is on, and the rules have changed. Products, processes, and people are united across digital threads, enabling hyper-connected systems to predict future outcomes. Engineers from all over the world collaborate, using a digital twin to design, optimize, and validate a product in real time. Data is fed to manufacturing, where adaptable production lines in every sector are digitally simulated before being built. The virtual and real join as parts are printed and tested on the spot, and variants are manufactured by the millions down to a lot size of one. The merging of hardware and software, design and automation, insight and optimization forms a continuous feedback loop to improve every part of the process and deliver value in unexpected ways. Siemens is enabling digitalization, harnessing the power of possibility to create at the speed of innovation, where today meets tomorrow.
Individualized mass production requires a high level of flexibility in machines and plants. This calls for new concepts for machines and plants, which in turn imposes new demands on machine building and plant engineering. In order to meet these market requirements, it is necessary to think digitally. That means integrating and digitalizing the entire value-added chain and generating a powerful digital twin that includes the product, or in other words, the machine, its production, performance of the actual production of the machine, and the actual machine in operation. The digital twin makes it possible to merge the real world with the virtual world. The product digital twin, in this case the virtual machine, enables machine builders to handle the design, the simulation, and the validation of the machines without generating physical prototypes. This concludes the specification of the virtual machine. All this data is then used to create the digital twin of production, or, in other words, the virtual production. From the co-simulation of mechatronics and automation, machine builders can create an overall simulation model that serves as the basis for virtual commissioning of individual machines and simulation of entire production lines. Now we move from the virtual world into the real world. The PLC code is transferred to the real machine. Totally integrated automation enables an efficient, reliable implementation of the machine. This makes it possible to analyze and evaluate the performance of the real machine in actual operation. The insights gained from this are used to improve the digital twins for the product and production on an ongoing basis. This in turn leads to continuous improvements in production and in the machine in the real world.
This very minute, we're standing at the precipice of possibility. Once again, industrial innovation is transforming our lives. Cities stretched towards the sky. Electricity ushered us out of darkness. Computers enabled automation. Science reshaped our universe. Supercomputers got super small. Then connectivity leveled the playing field, creating new competition and accelerating demand for innovation. Now, digitalization has opened the floodgates, blurring the boundaries between the physical and digital. The opportunity is unprecedented. It means turning complexity into competitive advantage. The race is on, and the rules have changed. Products, processes, and people are united across digital threads, enabling hyper-connected systems to predict future outcomes. Engineers from all over the world collaborate, using a digital twin to design, optimize, and validate a product in real time. Data is fed to manufacturing, where adaptable production lines in every sector are digitally simulated before being built. The virtual and real join as parts are printed and tested on the spot, and variants are manufactured by the millions down to a lot size of one. The merging of hardware and software, design and automation, insight and optimization forms a continuous feedback loop to improve every part of the process and deliver value in unexpected ways. Siemens is enabling digitalization, harnessing the power of possibility to create at the speed of innovation, where today meets tomorrow.
Individualized mass production requires a high level of flexibility in machines and plants. This calls for new concepts for machines and plants, which in turn imposes new demands on machine building and plant engineering. In order to meet these market requirements, it is necessary to think digitally. That means integrating and digitalizing the entire value-added chain and generating a powerful digital twin that includes the product, or in other words, the machine, its production, performance of the actual production of the machine, and the actual machine in operation. The digital twin makes it possible to merge the real world with the virtual world. The product digital twin, in this case the virtual machine, enables machine builders to handle the design, the simulation, and the validation of the machines without generating physical prototypes. This concludes the specification of the virtual machine. All this data is then used to create the digital twin of production, or, in other words, the virtual production. From the co-simulation of mechatronics and automation, machine builders can create an overall simulation model that serves as the basis for virtual commissioning of individual machines and simulation of entire production lines. Now we move from the virtual world into the real world. The PLC code is transferred to the real machine. Totally integrated automation enables an efficient, reliable implementation of the machine. This makes it possible to analyze and evaluate the performance of the real machine in actual operation. The insights gained from this are used to improve the digital twins for the product and production on an ongoing basis. This in turn leads to continuous improvements in production and in the machine in the real world.
This very minute, we're standing at the precipice of possibility. Once again, industrial innovation is transforming our lives. Cities stretch towards the sky. Electricity ushered us out of darkness. Computers enabled automation. Science reshaped our universe. Supercomputers got super small. Then connectivity leveled the playing field, creating new competition and accelerating demand for innovation. Now, digitalization has opened the floodgates, blurring the boundaries between the physical and digital. The opportunity is unprecedented. It means turning complexity into competitive advantage. The race is on, and the rules have changed. Products, processes, and people are united across digital threads, enabling hyper-connected systems to predict future outcomes. Engineers from all over the world collaborate, using a digital twin to design, optimize, and validate a product in real time. Data is fed to manufacturing, where adaptable production lines in every sector are digitally simulated before being built. The virtual and real join as parts are printed and tested on the spot, and variants are manufactured by the millions down to a lot size of one. The merging of hardware and software, design and automation, insight and optimization forms a continuous feedback loop to improve every part of the process and deliver value in unexpected ways. Siemens is enabling digitalization, harnessing the power of possibility to create at the speed of innovation, where today meets tomorrow.
Individualized mass production requires a high level of flexibility in machines and plants. This calls for new concepts for machines and plants, which in turn imposes new demands on machine building and plant engineering. In order to meet these market requirements, it is necessary to think digitally. That means integrating and digitalizing the entire value-added chain and generating a powerful digital twin that includes the product, or in other words, the machine, its production, performance of the actual production of the machine, and the actual machine in operation. The digital twin makes it possible to merge the real world with the virtual world. The product digital twin, in this case the virtual machine, enables machine builders to handle the design, the simulation, and the validation of the machines without generating physical prototypes. This concludes the specification of the virtual machine. All this data is then used to create the digital twin of production, or, in other words, the virtual production. From the co-simulation of mechatronics and automation, machine builders can create an overall simulation model that serves as the basis for virtual commissioning of individual machines and simulation of entire production lines. Now we move from the virtual world into the real world. The PLC code is transferred to the real machine. Totally integrated automation enables an efficient, reliable implementation of the machine. This makes it possible to analyze and evaluate the performance of the real machine in actual operation. The insights gained from this are used to improve the digital twins for the product and production on an ongoing basis. This in turn leads to continuous improvements in production and in the machine in the real world.
This very minute, we're standing at the precipice of possibility. Once again, industrial innovation is transforming our lives. Cities stretched towards the sky. Electricity ushered us out of darkness. computers enabled automation. Science reshaped our universe. Supercomputers got super small. Then connectivity leveled the playing field, creating new competition and accelerating demand for innovation. Now, digitalization has opened the floodgates, blurring the boundaries between the physical and digital. The opportunity is unprecedented. It means turning complexity into competitive advantage. The race is on, and the rules have changed. Products, processes, and people are united across digital threads, enabling hyper-connected systems to predict future outcomes. Engineers from all over the world collaborate, using a digital twin to design, optimize, and validate a product in real time. Data is fed to manufacturing, where adaptable production lines in every sector are digitally simulated before being built. The virtual and real join as parts are printed and tested on the spot, and variants are manufactured by the millions down to a lot size of one. The merging of hardware and software, design and automation, insight and optimization forms a continuous feedback loop to improve every part of the process and deliver value in unexpected ways. Siemens is enabling digitalization, harnessing the power of possibility to create at the speed of innovation, where today meets tomorrow.
Individualized mass production requires a high level of flexibility in machines and plants. This calls for new concepts for machines and plants, which in turn imposes new demands on machine building and plant engineering. In order to meet these market requirements, it is necessary to think digitally. That means integrating and digitalizing the entire value-added chain and generating a powerful digital twin that includes the product, or in other words, the machine, its production, performance of the actual production of the machine, and the actual machine in operation. The digital twin makes it possible to merge the real world with the virtual world. The product digital twin, in this case the virtual machine, enables machine builders to handle the design, the simulation, and the validation of the machines without generating physical prototypes. This concludes the specification of the virtual machine. All this data is then used to create the digital twin of production, or, in other words, the virtual production. From the co-simulation of mechatronics and automation, machine builders can create an overall simulation model that serves as the basis for virtual commissioning of individual machines and simulation of entire production lines. Now we move from the virtual world into the real world. The PLC code is transferred to the real machine. Totally integrated automation enables an efficient, reliable implementation of the machine. This makes it possible to analyze and evaluate the performance of the real machine in actual operation. The insights gained from this are used to improve the digital twins for the product and production on an ongoing basis. This in turn leads to continuous improvements in production and in the machine in the real world.
This very minute, we're standing at the precipice of possibility. Once again, industrial innovation is transforming our lives. Cities stretched towards the sky. Electricity ushered us out of darkness. Computers enabled automation. Science reshaped our universe. Supercomputers got super small. Then connectivity leveled the playing field, creating new competition and accelerating demand for innovation. Now, digitalization has opened the floodgates, blurring the boundaries between the physical and digital. The opportunity is unprecedented. It means turning complexity into competitive advantage. The race is on, and the rules have changed. Products, processes, and people are united across digital threads, enabling hyper-connected systems to predict future outcomes. Engineers from all over the world collaborate, using a digital twin to design, optimize, and validate a product in real time. Data is fed to manufacturing, where adaptable production lines in every sector are digitally simulated before being built. The virtual and real join as parts are printed and tested on the spot, and variants are manufactured by the millions down to a lot size of one. The merging of hardware and software, design and automation, insight and optimization forms a continuous feedback loop to improve every part of the process and deliver value in unexpected ways. Siemens is enabling digitalization, harnessing the power of possibility to create at the speed of innovation, where today meets tomorrow.
Individualized mass production requires a high level of flexibility in machines and plants. This calls for new concepts for machines and plants, which in turn imposes new demands on machine building and plant engineering. In order to meet these market requirements, it is necessary to think digitally. That means integrating and digitalizing the entire value-added chain and generating a powerful digital twin that includes the product, or in other words, the machine, its production, performance of the actual production of the machine, and the actual machine in operation. The digital twin makes it possible to merge the real world with the virtual world. The product digital twin, in this case the virtual machine, enables machine builders to handle the design, the simulation, and the validation of the machines without generating physical prototypes. This concludes the specification of the virtual machine. All this data is then used to create the digital twin of production, or, in other words, the virtual production. From the co-simulation of mechatronics and automation, machine builders can create an overall simulation model that serves as the basis for virtual commissioning of individual machines and simulation of entire production lines. Now we move from the virtual world into the real world. The PLC code is transferred to the real machine. Totally integrated automation enables an efficient, reliable implementation of the machine. This makes it possible to analyze and evaluate the performance of the real machine in actual operation. The insights gained from this are used to improve the digital twins for the product and production on an ongoing basis. This in turn leads to continuous improvements in production and in the machine in the real world.
This very minute, we're standing at the precipice of possibility. Once again, industrial innovation is transforming our lives. Cities stretched towards the sky. Electricity ushered us out of darkness. Computers enabled automation. Science reshaped our universe. Supercomputers got super small. Then connectivity leveled the playing field, creating new competition and accelerating demand for innovation. Now, digitalization has opened the floodgates, blurring the boundaries between the physical and digital. The opportunity is unprecedented. It means turning complexity into competitive advantage. The race is on, and the rules have changed. Products, processes, and people are united across digital threads, enabling hyper-connected systems to predict future outcomes. Engineers from all over the world collaborate, using a digital twin to design, optimize, and validate a product in real time. Data is fed to manufacturing, where adaptable production lines in every sector are digitally simulated before being built. The virtual and real join as parts are printed and tested on the spot, and variants are manufactured by the millions down to a lot size of one. The merging of hardware and software, design and automation, insight and optimization forms a continuous feedback loop to improve every part of the process and deliver value in unexpected ways. Siemens is enabling digitalization, harnessing the power of possibility to create at the speed of innovation, where today meets tomorrow.
Individualized mass production requires a high level of flexibility in machines and plants. This calls for new concepts for machines and plants, which in turn imposes new demands on machine building and plant engineering. In order to meet these market requirements, it is necessary to think digitally. That means integrating and digitalizing the entire value-added chain and generating a powerful digital twin that includes the product, or in other words, the machine, its production, performance of the actual production of the machine, and the actual machine in operation. The digital twin makes it possible to merge the real world with the virtual world. The product digital twin, in this case the virtual machine, enables machine builders to handle the design, the simulation, and the validation of the machines without generating physical prototypes. This concludes the specification of the virtual machine. All this data is then used to create the digital twin of production, or, in other words, the virtual production. From the co-simulation of mechatronics and automation, machine builders can create an overall simulation model that serves as the basis for virtual commissioning of individual machines and simulation of entire production lines. Now we move from the virtual world into the real world. The PLC code is transferred to the real machine. Totally integrated automation enables an efficient, reliable implementation of the machine. This makes it possible to analyze and evaluate the performance of the real machine in actual operation. The insights gained from this are used to improve the digital twins for the product and production on an ongoing basis. This in turn leads to continuous improvements in production and in the machine in the real world.
This very minute, we're standing at the precipice of possibility. Once again, industrial innovation is transforming our lives. Cities stretched towards the sky. Electricity ushered us out of darkness. Computers enabled automation. Science reshaped our universe. Supercomputers got super small. Then connectivity leveled the playing field, creating new competition and accelerating demand for innovation. Now, digitalization has opened the floodgates, blurring the boundaries between the physical and digital. The opportunity is unprecedented. It means turning complexity into competitive advantage. The race is on, and the rules have changed. Products, processes, and people are united across digital threads, enabling hyper-connected systems to predict future outcomes. Engineers from all over the world collaborate, using a digital twin to design, optimize, and validate a product in real time. Data is fed to manufacturing, where adaptable production lines in every sector are digitally simulated before being built. The virtual and real join as parts are printed and tested on the spot, and variants are manufactured by the millions down to a lot size of one. The merging of hardware and software, design and automation, insight and optimization forms a continuous feedback loop to improve every part of the process and deliver value in unexpected ways. Siemens is enabling digitalization, harnessing the power of possibility to create at the speed of innovation, where today meets tomorrow.
Individualized mass production requires a high level of flexibility in machines and plants. This calls for new concepts for machines and plants, which in turn imposes new demands on machine building and plant engineering. In order to meet these market requirements, it is necessary to think digitally. That means integrating and digitalizing the entire value-added chain, and generating a powerful digital twin that includes the product, or in other words, the machine, its production, performance of the actual production of the machine, and the actual machine in operation. The digital twin makes it possible to merge the real world with the virtual world. The product digital twin, in this case the virtual machine, enables machine builders to handle the design, the simulation, and the validation of the machines without generating physical prototypes. This concludes the specification of the virtual machine. All this data is then used to create the digital twin of production, or, in other words, the virtual production. From the co-simulation of mechatronics and automation, machine builders can create an overall simulation model that serves as the basis for virtual commissioning of individual machines and simulation of entire production lines. Now we move from the virtual world into the real world. The PLC code is transferred to the real machine. Totally integrated automation enables an efficient, reliable implementation of the machine. This makes it possible to analyze and evaluate the performance of the real machine in actual operation. The insights gained from this are used to improve the digital twins for the product and production on an ongoing basis. This in turn leads to continuous improvements in production and in the machine in the real world.
This very minute, we're standing at the precipice of possibility. Once again, industrial innovation is transforming our lives. Cities stretched towards the sky. Electricity ushered us out of darkness. Computers enabled automation. Science reshaped our universe. Supercomputers got super small. Then connectivity leveled the playing field, creating new competition and accelerating demand for innovation. Now, digitalization has opened the floodgates, blurring the boundaries between the physical and digital. The opportunity is unprecedented. It means turning complexity into competitive advantage. The race is on, and the rules have changed. Products, processes, and people are united across digital threads, enabling hyper-connected systems to predict future outcomes. Engineers from all over the world collaborate, using a digital twin to design, optimize, and validate a product in real time. Data is fed to manufacturing, where adaptable production lines in every sector are digitally simulated before being built. The virtual and real join as parts are printed and tested on the spot, and variants are manufactured by the millions down to a lot size of one. The merging of hardware and software, design and automation, insight and optimization forms a continuous feedback loop to improve every part of the process and deliver value in unexpected ways. Siemens is enabling digitalization, harnessing the power of possibility to create at the speed of innovation, where today meets tomorrow.
Individualized mass production requires a high level of flexibility in machines and plants. This calls for new concepts for machines and plants, which in turn imposes new demands on machine building and plant engineering. In order to meet these market requirements, it is necessary to think digitally. That means integrating and digitalizing the entire value-added chain, and generating a powerful digital twin that includes the product, or in other words, the machine, its production, performance of the actual production of the machine, and the actual machine in operation. The digital twin makes it possible to merge the real world with the virtual world. The product digital twin, in this case the virtual machine, enables machine builders to handle the design, the simulation, and the validation of the machines without generating physical prototypes. This concludes the specification of the virtual machine. All this data is then used to create the digital twin of production, or, in other words, the virtual production. From the co-simulation of mechatronics and automation, machine builders can create an overall simulation model that serves as the basis for virtual commissioning of individual machines and simulation of entire production lines. Now we move from the virtual world into the real world. The PLC code is transferred to the real machine. Totally integrated automation enables an efficient, reliable implementation of the machine. This makes it possible to analyze and evaluate the performance of the real machine in actual operation. The insights gained from this are used to improve the digital twins for the product and production on an ongoing basis. This in turn leads to continuous improvements in production and in the machine in the real world.
This very minute, we're standing at the precipice of possibility. Once again, industrial innovation is transforming our lives. Cities stretched towards the sky. Electricity ushered us out of darkness. Computers enabled automation. Science reshaped our universe. Supercomputers got super small. Then connectivity leveled the playing field, creating new competition and accelerating demand for innovation. Now, digitalization has opened the floodgates, blurring the boundaries between the physical and digital. The opportunity is unprecedented. It means turning complexity into competitive advantage. The race is on, and the rules have changed. Products, processes, and people are united across digital threads, enabling hyper-connected systems to predict future outcomes. Engineers from all over the world collaborate, using a digital twin to design, optimize, and validate a product in real time. Data is fed to manufacturing, where adaptable production lines in every sector are digitally simulated before being built. The virtual and real join as parts are printed and tested on the spot, and variants are manufactured by the millions down to a lot size of one. The merging of hardware and software, design and automation, insight and optimization forms a continuous feedback loop to improve every part of the process and deliver value in unexpected ways. Siemens is enabling digitalization, harnessing the power of possibility to create at the speed of innovation, where today meets tomorrow.
Individualized mass production requires a high level of flexibility in machines and plants. This calls for new concepts for machines and plants, which in turn imposes new demands on machine building and plant engineering. In order to meet these market requirements, it is necessary to think digitally. That means integrating and digitalizing the entire value-added chain, and generating a powerful digital twin that includes the product, or in other words, the machine, its production, performance of the actual production of the machine, and the actual machine in operation. The digital twin makes it possible to merge the real world with the virtual world. The product digital twin, in this case the virtual machine, enables machine builders to handle the design, the simulation, and the validation of the machines without generating physical prototypes. This concludes the specification of the virtual machine. All this data is then used to create the digital twin of production, or, in other words, the virtual production. From the co-simulation of mechatronics and automation, machine builders can create an overall simulation model that serves as the basis for virtual commissioning of individual machines and simulation of entire production lines. Now we move from the virtual world into the real world. The PLC code is transferred to the real machine. Totally integrated automation enables an efficient, reliable implementation of the machine. This makes it possible to analyze and evaluate the performance of the real machine in actual operation. The insights gained from this are used to improve the digital twins for the product and production on an ongoing basis. This in turn leads to continuous improvements in production and in the machine in the real world.
This very minute, we're standing at the precipice of possibility. Once again, industrial innovation is transforming our lives. Cities stretched towards the sky. Electricity ushered us out of darkness. Computers enabled automation. Science reshaped our universe. Supercomputers got super small. Then connectivity leveled the playing field, creating new competition and accelerating demand for innovation. Now, digitalization has opened the floodgates, blurring the boundaries between the physical and digital. The opportunity is unprecedented. It means turning complexity into competitive advantage. The race is on, and the rules have changed. Products, processes, and people are united across digital threads, enabling hyper-connected systems to predict future outcomes. Engineers from all over the world collaborate, using a digital twin to design, optimize, and validate a product in real time. Data is fed to manufacturing, where adaptable production lines in every sector are digitally simulated before being built. The virtual and real join as parts are printed and tested on the spot, and variants are manufactured by the millions down to a lot size of one. The merging of hardware and software, design and automation, insight and optimization forms a continuous feedback loop to improve every part of the process and deliver value in unexpected ways. Siemens is enabling digitalization, harnessing the power of possibility to create at the speed of innovation, where today meets tomorrow.
Individualized mass production requires a high level of flexibility in machines and plants. This calls for new concepts for machines and plants, which in turn imposes new demands on machine building and plant engineering. In order to meet these market requirements, it is necessary to think digitally. That means integrating and digitalizing the entire value-added chain and generating a powerful digital twin that includes the product, or in other words, the machine, its production, performance of the actual production of the machine, and the actual machine in operation. The digital twin makes it possible to merge the real world with the virtual world. The product digital twin, in this case the virtual machine, enables machine builders to handle the design, the simulation, and the validation of the machines without generating physical prototypes. This concludes the specification of the virtual machine. All this data is then used to create the digital twin of production, or, in other words, the virtual production. From the co-simulation of mechatronics and automation, machine builders can create an overall simulation model that serves as the basis for virtual commissioning of individual machines and simulation of entire production lines. Now we move from the virtual world into the real world. The PLC code is transferred to the real machine. Totally integrated automation enables an efficient, reliable implementation of the machine. This makes it possible to analyze and evaluate the performance of the real machine in actual operation. The insights gained from this are used to improve the digital twins for the product and production on an ongoing basis. This in turn leads to continuous improvements in production and in the machine in the real world.
This very minute, we're standing at the precipice of possibility. Once again, industrial innovation is transforming our lives. Cities stretched towards the sky. Electricity ushered us out of darkness. Computers enabled automation. Science reshaped our universe. Supercomputers got super small. Then connectivity leveled the playing field, creating new competition and accelerating demand for innovation. Now, digitalization has opened the floodgates, blurring the boundaries between the physical and digital. The opportunity is unprecedented. It means turning complexity into competitive advantage. The race is on, and the rules have changed. Products, processes, and people are united across digital threads, enabling hyper-connected systems to predict future outcomes. Engineers from all over the world collaborate, using a digital twin to design, optimize, and validate a product in real time. Data is fed to manufacturing, where adaptable production lines in every sector are digitally simulated before being built. The virtual and real join as parts are printed and tested on the spot, and variants are manufactured by the millions down to a lot size of one. The merging of hardware and software, design and automation, insight and optimization forms a continuous feedback loop to improve every part of the process and deliver value in unexpected ways. Siemens is enabling digitalization, harnessing the power of possibility to create at the speed of innovation, where today meets tomorrow.
Individualized mass production requires a high level of flexibility in machines and plants. This calls for new concepts for machines and plants, which in turn imposes new demands on machine building and plant engineering. In order to meet these market requirements, it is necessary to think digitally. That means integrating and digitalizing the entire value-added chain, and generating a powerful digital twin that includes the product, or in other words, the machine, its production, performance of the actual production of the machine, and the actual machine in operation. The digital twin makes it possible to merge the real world with the virtual world. The product digital twin, in this case the virtual machine, enables machine builders to handle the design, the simulation, and the validation of the machines without generating physical prototypes. This concludes the specification of the virtual machine. All this data is then used to create the digital twin of production, or, in other words, the virtual production. From the co-simulation of mechatronics and automation, machine builders can create an overall simulation model that serves as the basis for virtual commissioning of individual machines and simulation of entire production lines.
This here at the studio at the Factory Automation Virtual Tour 2022. And we start the second part of our day. I'm welcoming you to our next session when we talk about Industrial Edge.
Welcome everyone to today's session of the Factory Automation Virtual Tour titled Industrial Edge, Make the Most of Your Data. In this session, we will talk about the vast amounts of data that keep on growing in our industry, how to make sense of it, how to make sound business decisions based on it, and where to get started, both with software and hardware when it comes to industrial edge. Today's topic will be presented by Chris Liu, Industrial Edge Product Marketing Manager from Siemens. Chris, take it away.
All right, thank you very much, Natalia. Hello, everyone. I'm Chris Liu. I'm the Industrial Edge Product Marketing Manager for Siemens. I'm based out of Orlando, Florida, but currently I'm in our beautiful Siemens FA office in Georgia, Alpharetta. So today, first of all, I would like to thank you for joining my webinar. And in the next 40 minutes, I will talk about Industrial Edge. Make the most of your data. All right. So before we get started, I would like to just spend a little bit of time talking about all the contents that will be covered today. So first of all, we will talk about the definition of edge computing and industrial edge. After that, I will spend just a little bit of time giving you an overview about industrial edge portfolio, including what Siemens offers in both software and hardware. And then I will also give you an industrial edge architecture to help you better understand how exactly industrial edge works. And then we will also spend just a little bit of time talking about the two well-defined starting application scenarios. And then I will, in case you're interested in how to get started with industrial edge, I will also show you a simple process and to help you get industrial edge on board. And then before we move on to the Q&A session at the end of the webinar, I will also share you with some helpful links and resources to help you study industrial edge offline. So let's start with the evolution of computing. Initially, we have our local or traditional computing that solely relies on physical equipment, computers, or data centers where to store data. And once these devices were installed, they never get updated, and users need to manually transfer data using a USB drive, which is risky and very unsecure. And then you can also maybe save data to a local server, but it is not accessible for users outside of the plant. In other words, it does not offer a global access. So data is limited to the device or the network they're connected with. Then, with the fast development of internet, as well as internet-based applications, tools, and smart devices, cloud computing was introduced and took off. It became mainstream in the mid-2000s, along with the emergence of public hyperscaler cloud platforms such as Azure or AWS. And since then, most companies started to store, manage, and analyze data on a centralized cloud platforms where they can utilize AI or machine learning to further study and analyze data. However, nowadays, with the exponential growth of IoT devices and the data generated, traditional infrastructures and cloud computing are no longer be able to meet the requirements for many real-life applications due to the limitation of latency, liability, and bandwidth. Also, the cost associated with data transmission and storage. And that is why edge computing is introduced to eliminate these limitations and close the gap between the conventional cloud data processing and cloud-based computing. So what exactly is edge computing? What's the definition? We know edge computing brings computation and data storage closer to the device where the data is actually generated. Since edge does not require internet or a cloud connection, then data can be managed and stored on the edge of network closer to the device without suffering from latency issues that can affect an application's performance. And companies that initially embrace the cloud computing for many of their applications may also discover that the cost in bandwidth were higher than they expected. And they're actually looking for an alternative for less expensive solution, and edge computing would be a very good fit. And this is why we would like to introduce you Siemens Industrial Edge, which is a new digitalization solution offered by Siemens that perfectly integrates OT and IT. Industrial Edge brings IT to the shop floor, realizes the localization of data management, including data capture, data storage, and data analysis. But what's the positioning of Industrial Edge against the existing industrial solutions, for example, SCADA and cloud computing? And what exactly is the position of Industrial Edge in the industrial automation industry? First of all, Industrial Edge is an independent system from SCADA and cloud. It is an open software platform that executes software in a very efficient way with the central management and versioning system. And I would like to point out that the core value of Industrial Edge is data localization. It reduces the response time to even milliseconds, which makes it faster to process and store data, enabling for more efficient real-time applications. And as I mentioned earlier, Edge does not require a constant connection to the cloud, which allows users to deploy applications completely on premises. And here, I would like to show you a short video about integration of Siemens Industrial Edge and the cloud computing MindSphere. Natalia, can you please play the video?
It is undisputed that machine data offer valuable insights and potential for optimization. The question, therefore, is which location is best suited for storing and processing this data? Depending on individual circumstances, either a local solution using edge computing or a remote solution using cloud could be best, or even both.
Cloud solution allows data to be collected and to understand from different sources, like different locations or different enterprises. And additionally, you can use the computing power on demand from different data sciences, for example, for complex analytics.
The Edge solution reduces decision latency through near real-time processing of streamed data. High-frequency data processing also ensures that only relevant data is passed on across platforms. This saves transmission and storage costs. Edge computing enables data analysis without delay in the field.
Combining cloud and edge computing enables the implementation of new digital business models, as well as consistent updates. Depending on individual customer requirements and specific use cases, each solution can be useful in its own right and will ensure maximum flexibility for the future of your production.
Siemens, ingenuity for life.
All right, thank you, Natalia. So that is to say, Industrial Edge is not competing against SCADA or cloud computing. In contrast, we aim to build an open ecosystem based on Industrial Edge, because Industrial Edge enables possibilities, collaboration, and interactions. And I also want you to be aware of that. If you are a customer or a machine builder seeking to increase productivity or production efficiency, Industrial Edge is an easy-to-use platform that can help you to reduce production downtime and secures real-time data handling without stopping the production line at the factory level. So that means the data into Industrial Edge device could be from any source with integrated connectivity. For example, if you have different types of POCs running at your production level, you do not have to change your POC program, and you can just simply plug in your Edge device using existing connector apps and talk to the POCs. So Industrial Edge makes the rollout faster and more reliable by highly automating IT-related workflows with the ready-to-use infrastructure, including a centralized management system, Industrial Edge IEM. It's easy to use for both OT and IT. And if you are, let's say, a device builder and you're looking to bring in Edge-enabled device, the soon-released Edge virtual device can also help you benefit from high-level connectivity and flexibility. And even more, Industrial Edge reduces complexity and IT costs. Industrial Edge can be used to manage container-based workloads or apps and devices centrally, which reduces the operating costs. Last but not least, Industrial Edge is an open platform that we embrace Docker-based app concepts. So let's say if you are application providers and you want to develop your own apps, we welcome you to develop your apps, and which can then be Dockerized and used on Industrial Edge. So I think I talked enough about what is Industrial Edge and what's the evolution of the computing from conventional computing to cloud, and then to the introduction of edge computing. So what exactly does Siemens offer? From here, I'd like to give you an overview about the Siemens Industrial Edge portfolio. So Industrial Edge consists of three major components, and they are Industrial Edge Hub, Industrial Edge Management, and Industrial Edge Runtime on Industrial Edge devices. So Industrial Edge Hub is placed in the cloud level as a global app repository. And on the factory level, we have this Industrial Edge Management System, which is operated by the customers. And then the Industrial Edge Runtime is also in the factory level, which allows local app execution. And let's take a deeper look. So Industrial Edge Hub is a central entry point in the cloud level, which contains all the packages, including tools and documentation about Industrial Edge, where you can also download the Industrial Edge Management System from the hub and monitor and manage many Industrial Edge deployments across the globe. And then when it comes to Industrial Edge Management, it is a on-premises control plan to manage all the connected edge devices and applications, which you can install individually on each Industrial Edge device. It can be used to deploy the right apps to the right edge devices at scale. And Industrial Edge Management is running as an on-premises solution on a computer or a virtual machine in your factory. So it helps to supervise your operations as well as to manage users with a centralized admin view across many plants. And then the third component of Siemens Industrial Edge is the edge runtime on the edge devices. So the edge runtime is actually a soft layer to execute containerized applications with integrated device connectivity to automation and cloud systems. And when it comes to the hardware Industrial Edge devices, we know data is generated from automation system in the field level, and that is also where edge devices is placed next to the machine to acquire data. And right now we have two types of edge devices, and they are edge dedicated or edge enabled devices. So for the dedicated edge device, they are solely designed for edge computing. They can be like powerful and scalable industrial PCs with Industrial Edge runtime pre-installed. And the sole purpose of dedicated edge device is to execute edge apps. And then when it comes to the edge enabled devices, they can be, let's say, HMI panels, human machine interface, whose primary function is actually not edge computing. For example, HMI, it is mainly designed for controlling or monitoring the automation process. However, with the edge license, the edge capability can also be installed on this type of edge enabled devices. So you can actually activate the edge functionality on these devices whenever you need it. And they are also configurable via Industrial Edge Management Systems. And then edge devices can be activated by a configuration file created on the Industrial Edge Management. It can then store data locally and retrieve the data as needed. More than that, Industrial Edge devices can upload this data to cloud infrastructure, such as MindSphere, AWS, or Azure for further analysis. So as you can see, Siemens, we do offer a wide selection of different edge devices. And here I listed the performance and specifications of the three powerful edge IPCs. They are IPC 227E and IPC 427E, which have been already released. and the soon available IPC 127E that will be actually released by the end of this month. So let's take a closer look at IPC 227E. It is actually equipped with a 4-core Atom E3940 4-core CPU. So that means compared to the CPU of 227E, it is more powerful. That means the individual apps performance on 127E could be even better. But with the less RAM, only 4 gigabytes, less number of apps can be supported on 127E compared to 227E and IPC 427E. Another big news is that the Industrial Edge virtual device will also soon become available, an official product for Industrial Edge. It will be officially supported by VMware ESXi after the first release in April 2022, which is next month. And then it will also be available for customers who like to use the virtual device in a productive environment. Other hypervisors such as VMware Workstation Pro or VirtualBox will also be supported later this year during the second release. All right, I think we talked enough about the portfolio. So from here, I would like to give you, I would like to show you the architecture of Siemens Industrial Edge to help you understand how exactly it works. So on the factory level, on the production line level, you have your automation systems running, and it's connected with the POC. So you can simply just plug in your edge device and connect to the automation systems with the already available Siemens connector apps. For example, Siemens S7 connectors or Ethernet IP connectors or Modbus TCP connectors, depending on what type of POCs the edge device is connected with. And then this data can be acquired and stored in your edge device. You can simply just run machine monitoring apps, for example, Performance Insight, that is with extensive access to machine data to visualize machine conditions that helps you to improve your productivity. It also comes with like apps, dashboarding functionality for you to visualize the machine states or if there's anything wrong with your machines. So it is very easy to use. On the factory level, let's say you have a server on site, a local server. So edge device also enables the connectivity to your local server if you want to forward your data to the server. And with the connectivity apps such as MQTT and OPC UA server, this can also be enabled. And let's say you are a cloud computing or cloud platform users, and you want to further push your data to the cloud level. Industrial Edge can also enable the connectivity to the cloud system by using the built-in MQTT cloud connector or the MindSphere connector apps. So then you will have the ability to further analysis and study your data or just store your data in the cloud. So this is actually the case for one individual industrial PC's edge device. But let's say if you have multiple edge devices and you want to run them like on a larger scale, don't worry. Industrial Edge Management System can be the tool to centrally manage all the industrial edge devices and to allow you to deploy multiple industrial devices at scale. And then if you have multiple plants, you have many manufacturing plants across the globe, you can also use Industrial Edge Hub to manage different Industrial Edge management deployments or instances. And the Industrial Edge Hub also allow you to constantly execute security updates. And this cannot be purchased through the Siemens Industrial Edge marketplace, where you can also get your hub access and purchase the applications to your Industrial Edge Hub. And then these apps can be downloaded from your hub to your IEM, and then your IEM can further distribute these applications or updates to each individual devices. Besides that, let's say if you are an app provider and you want to create your own custom applications, with the help of Industrial Edge App Publisher, any applications based on any program language, for example, Python or SQL, can all be deployed as long as it is being Dockerized with the Siemens Industrial Edge App Publisher. So I hope the architecture helps you to better understand the workflow of Industrial Edge. And from here, I would like to talk a little bit about the application scenarios. As we know, Industrial Edge is now still in incubation phase. However, we have done tons of case studies and market analysis. We have evaluated many real-world applications. So with the release of multiple edge devices, like I just showed you earlier, we have come up with the concrete go-to-market strategy, along with 3 well-defined customer use cases or starting application scenarios with clear technical boundaries. We understand how important data is in the manufacturing and automation industry. So first and foremost, the first step is to help our customers to make their production data accessible, structured, and visible before they can implement advanced edge applications such as AI or machine learning. This is also a better way to expedite the edge onboarding process for every customer like you, as well as to ensure a faster and smoother rollout plan for Industrial Edge. So what are the starting scenarios? First of all, performance analytics. Performance analytics is a classic data collection and visualization use case that allows customers to visualize machine states and performance, and also to configure flexible dashboards to monitor the plant, where data handling stays local and in the secure factory level. Besides that, customers can also access machine and plant performance data and further calculate machine and plant performance. Second, we have the option to collect data from different sources on your factory level and send pre-processed data to a central cloud for further analysis. For this use case, shop floor to cloud connectivity, data that relates to OT still stays local, and only desired data or topics will be forwarded securely with one entry point to the cloud systems. And the third use case, bring your own applications to the shop floor. So there is the possibility to manage and deploy self-developed apps to the shop floor with Siemens Industrial Edge. And as of right now, the third use case will be soon available and supported by Siemens. So, and currently we're actually focusing on the 2 scenarios, performance analytics and shop floor to cloud connectivity. So let's take a closer look at performance analytics. On the production line level, let's say you have a Siemens or a Rockwell or a Schneider PLCs running. You can just easily plug in the edge device and connect the edge device to the PLCs with connector apps such as S7 connectors or Ethernet IP connectors or Modbus TCP connectors, and then collect this machine data. Then you can run apps, performance insight that comes with dashboarding functions to further analyze the data and simply plugging a monitor to the IPC to visualize the machine states and monitor the plant operation. And on the factory level, this also allows users to obtain valuable information. For example, advanced cycle times analysis for machine or line KPIs and IEE based on locally stored data to ensure accurate decision-making in order to help the users to optimize machine availability. Here, I listed a recommended technical setup for this specific application scenario. So first of all, let's say you have a medium data load and you only have one type of POCs, which means there's only one connector required. So in this case, you can just simply plug in a IPC 227E with the maximum 600 tags per second data reading to the POCs. And then if there are more than one type of POCs, let's say you have Siemens POCs, you have Rockwell POC or Schneider POCs, there are more than one type. You can also just plug in a 227E, and which is equipped with 3 different connector apps, such as Ethernet IP or Modbus TCP or or other available connector apps. So this can also be enabled by a single piece of 227Es. And when it goes to like a higher scale, let's say you have a higher data load with 3 connectors required, and then there are more than 3 data connections. So let's say you have 100 tags per second data per machine, which means you have more than 2,000 tags per second. Then you can actually use a industrial PC 427E with a higher performance, or simply use a industrial edge virtual device to connect to the POCs and read the data. So this is on the hardware side. On the software side, we know we have Performance Insight app, which is designed specifically for this starting scenarios. Besides that, as I mentioned earlier, you can also plug in your SIMATIC S7 connectors, Modbus TCP or Ethernet IP connectors, which is still in like testing right now, but will be available, released very soon. And after that, you will also need IE Data Bus and IE Data Service, which is actually a prerequisite of Performance Insight. And then the second application scenarios, we're looking at shop floor to cloud connectivity. So cloud connectivity is actually used in conjunction with edge applications in an integrated hardware and software ecosystem for automation components. Edge device can be used as a data gateway, which collects data from machines with connector apps, and you can forward the data to cloud systems securely with cloud connector apps such as MQTT or Industrial Edge MindSphere connector, and soon released Industrial Edge Google Cloud Platform connectors. Industrial Edge devices gather this data and harmonize the data from different machines or vendors. So let's take a closer look at the recommended technical setup. So there's a little bit different from the first application scenario, performance analytics. In this case, since you will just need a IPC as your data gateway, so we will recommend a lightweight version, which is IPC 127E. And you can just simply plug in your IPC 127E with the cloud connector apps installed. Besides that, you will also need SIMATIC S7 connectors or Modbus TCP connectors or Ethernet IP connectors talking to your POCs. And then depending on different situations, here also we listed 3 different sample configurations. Let's say you have a medium data load and you only have 1 data connector app. You only have 1 type of POCs, so only 1 data connector app is required. And then let's say you have more than 3 types of data POCs, then you will actually need 3 connectors. So in this case, a 1 IPC 227E will be required. And if you have like a higher data load, and let's say you will also have more than 1 production line, then in this case, a higher performance 1 IPC 427E can also be used to enable the cloud connectivity. So let's get into more detail. Let's say you have 130 tags per second per machine, and we're talking about 2,000 tags per second. The 1 piece of 427E can give you this functionality to collect larger amount of data, and all this data can be first stored in your edge device and then further forwarded to the cloud system. So that sums up the application scenario. And here I listed all the edge apps already available for purchase. And if you're seeking an pre-engineered edge solution, it can also be supported by Industrial Edge. Now we have more than 10 connectivity apps available, and we're also working diligently on other third-party connectors to support many other protocols, which will then make the implementation of Industrial Edge easier and more compatible. So let's take a look at the connectivity apps. Right now we have MQTT connector apps, which support the cloud connectivity to the hyperscaler cloud platforms. And then we also have Ethernet IP connectors or Modbus TCP connectors designed specifically for different type of POCs. And for the performance apps, we also have Flow Creator, Performance Insight, or inventory apps that gives the users more functionality to further analyze and study the data generated from your production line. And we know there are so many different use cases. We are also looking to onboard like AI use cases, for example, live twin, predictive maintenance with anomaly detection, and notification functions that are also available on Industrial Edge. For example, the notifier applications, and this will also soon be fully supported by Siemens. And then let's talk about how you can get on board with Industrial Edge. Let's say you are the end user and you're new to Industrial Edge, this topic, but you want to get started. So first of all, you have to decide if Industrial Edge is the ideal solution to your scenarios. So please reach out to Siemens and we will help you to decide whether get Industrial Edge to your production line, and if there will be any other solutions that can be combined at the hybrid solutions to help you get Industrial Edge on board. And then the purchaser from your company can start purchasing process. For example, you can purchase Industrial Edge access, and then we will require an email associated with this Industrial Edge access, and this could be from your purchaser, or this can be your engineers. And then Industrial Edge Hub, we will send you an email with login information, and you can just simply click on the email to get your account set up. And then you will be granted with access to Industrial Edge Hub, where you can start download Industrial Edge Management System as an ISO for IPC. And after that, you can create new IAM instances via a configuration file, and you can download configuration file and upload local IAMs to onboard to Industrial Edge Hub. So from here, you will have access to the Industrial Edge Management System as well as to Industrial Edge Hub. And the next step, we can either help you to onboard your Edge devices and to connect your Edge device to your Industrial Edge management. So to simplify the ordering process, here we have, first of all, you will need to order the Industrial Edge Hub access through the Siemens Digital Exchange or the Edge Marketplace. And then the Industrial Edge devices, the hardware, are all available on Siemens Industry Mall. So you will have to order your hardware through your normal distribution channel. And when it comes to the Industrial Edge management license, as of right now, the first device is actually connect with the management system is actually for free, and it will then be like $130 per device per year. And soon, later this year, this price will be adjusted to about like $200. And then after that, you can start install your Industrial Edge apps and download these apps from Hub and onboard these apps to your Edge devices. So I hope that helps you to understand the ordering process of Industrial Edge. And from here, I would like to share some information with you about where you can access to Industrial Edge related documents and learning materials, so you can learn more about Industrial Edge offline. First of all, I'd like to announce that we now have an Industrial Edge recommendation website, industrialedge.io. It is an open and public platform, which is structured in 3 categories, for app developer, for admin and operator, and also for device builder. So from this website, you can actually find many useful documentations to know how to get started with Industrial Edge. And here I include a link for you to access. And then the next help link, here I listed Industry Edge Forum. It is a technical forum. It is also part of Siemens Industry Edge online support, where you can share the technical issues you encounter with other users in the community, and you can get answered by our technical support team. And then there is Industry Edge GitHub, where you can get guidance on how to onboard Industry Edge or get started with specific Edge applications. And then there's also another public platform available, which is called Path Factory. So Path Factory is a content platform where you can take a deep dive on a topic by looking at videos or white papers or recorded webinars or articles and more, which are already available in the Path Factory. We also provide like support and training to the new or existing Edge customers. For example, now we offer Citron sessions. So Citron sessions is actually a 3-day virtual learning session with a cost. However, it is very helpful for end users to get started with onboarding Edge. And the Citron session was already started back in October 2021. And just for information, the next available session is actually in April. So if you want to get yourself trained up and to get ready to onboard Industry Edge, you can feel free to sign up for the next available Citron session. And then let's say if you are already familiar with Industry Edge, with edge computing, and but you run into some technical issues and you want to know more technical details about Industry Edge. So we also have this Industry Edge online support website available, where you can actually contact our support team through the JOSI support line to find out the answers to questions that you cannot find in, let's say, in the technical forum or any other resources. So this is actually a very good resource where you can get more detailed technical feedback from our Siemens team internally. And here I included the link for you to easily access. All right, so that brings us to the end of my webinar, and I would like to thank you for your time and attention today. If you would like to know more about Industry Edge, or if you would like to connect with me, here I include a link for you, or you can just scan the QR code to find me. And thank you again, and now I'm ready for your questions.
Hello. Thank you everyone for joining. Thank you for being back after our break. Thank you for listening to our Edge presentation and asking the questions in the chat. Also welcome Chris being here. Great to have you here.
Hi Barry.
Hi Chris. So just to remember or remind everyone, please participate in our polls. Continue to engage with us in the Q&A, and also at the booths, talk with the product managers there. Please use the opportunity, and we are really looking forward to answering your questions. And also don't forget about all the prizes and drawings that come up. So it really makes sense, and it's worthwhile participating in the polls and watching the webinars. So let's start with the questions, and maybe start with one from Bob first. Chris, how difficult is it to connect Edge to a PLC, to connect an Edge device to a PLC?
That's a good question. Yes, it's actually very simple, very easy. You know, as I mentioned, we have this starting application scenario, and one of them is plug and analyze, plug and play. So far, as I introduced, we have a couple of different connectors. So what PLCs you have, no matter it's from our or if it's our Siemens S7 family PLCs, we have all the different connectors already available for you to use.
And thanks, Chris. Maybe to add from my side also, it's really a graphical interface, so you don't need any programming. It's really a configuration interface where you set up the connectors, you select the variables, and get them read in or into the data bus. So it's very easy to do, and you don't need any programming knowledge for it. It's an easy thing, like Chris mentioned.
Exactly.
Maybe in the next question, Chris, how many IEDs, how many edge devices can be connected to one industrial edge management system?
Okay. Yeah. So one of the essential components of industrial edge is the industrial edge management (IEM) system. The goal is to eventually run as many as you can, but right now we are in testing to run like 100+ edge devices into one IEM. So this is our what we're currently working on.
Okay. All right. And then maybe how many PLCs can be connected to one IEM or to one IED, to one edge device? How many PLCs can you connect to one edge device?
Okay. The question about the connectivity. Yeah, that's a great one. So it really depends on what IED the customer is using. So it is a highly scalable platform, and we offer so far we offer like 3 different edge devices. 127, which can be used to run like one specific connector type of connector, data connectors. And then we have 227Es where you can actually install and run multiple to 3 different data connectors. And eventually 427E can be used, and it is capable of running even more data connectors. So it really depends on what kind of edge you're using.
All right. And when we have another question here from Bob was about MindSphere. They have third-party connections also with to MindSphere. I don't know, do you want to answer the question, or do you want me to answer that one?
Yeah, maybe Bernd, because you are actually in cloud computing as well. Maybe you can take that one.
So we do have MindConnect devices where you can also connect and send data directly to MindSphere. So that's one option, and that's also available for third-party devices and third-party protocols. But also, like Chris mentioned, we have within Industrial Edge, we have a lot of third-party connectors. We can connect to Rockwell, to Schneider, all the other systems, and really read in all the data, and it's really an easy way to do it. So in case of doubt, it's always possible to use an edge device. And like Chris showed before, we also scale with the edge devices. So we start with very small edge devices up to larger ones. In this case, just reading in data could be also one of the smallest edge devices just to get the data. Then let's see, maybe Chris, what kind of applications do you see or anticipate coming up after the data collection? Any thoughts on that? So what's going to come up basically after data collection? What kind of other applications you see right now when you talk with customers?
Sure. Yeah. So first of all, I think most common use cases for industrial edge after the data has been collected is first of all like simple dashboarding, where you can actually utilize our already available edge applications, performance insight. So that gives you this capability of the data flow, and then we also have like several use cases, several projects also involved with digital twin, which can be actually enabled by our live twin edge applications. And the live twin is actually a big topic. We know, the digital twin can be used like during the entire manufacturing process to like reduce the risks, especially for the investment, because you can actually use live twin to predict, the functionality and the status of your machine, and that will make you to make the smart decision, no matter on what stage of the manufacturing process. Apart from that, one of the most discussed topic is predictive maintenance. Right now, Industrial Edge, we are also developing some AI functionality app, And one of them is actually available. It's called anomaly detection. So you can basically run anomaly detection on Industrial Edge that can gives you this this capability to machine downtime. So when it comes to the reality, like you can reduce the downtime for your actual machine, which will like enhance your productivity and production efficiency.
All right. Thanks, Chris. I think also what, from my personal view, just to add something to that, quite often we get the answer, okay, what is the difference to a SCADA system, to Edge? And yes, in both cases, we start with data collection, and one might think, why don't you just use a SCADA system? But with Industrial Edge, the plan is to go way beyond just collecting data and also showing data and displaying and doing OEE calculation. It's like Chris mentioned, it's really going into predictive maintenance, machine learning, real-time simulation, all kinds of new applications, and maybe also having a platform for applications we don't know about it yet, and that we typically cannot run on a SCADA system. So we want to be open and flexible also for new applications that come up in the future. And Industrial Edge is also providing a platform where you can scale very quickly and deploy applications to a lot of devices in an easy way and update them and then manage them. So it's much easier to deal with it when just having everything inside a SCADA system. And second is also a SCADA system is meant for control of a plant itself. And if we have applications with customers where we collect so much video data and image data that it's not even possible to get it all the data through the company network just in time. So you need to store the data separately. And I'm not sure if it's a good idea to store the data within a SCADA system, because it's just so much data, and it's not necessarily related to control of a plant and the factory. It's really for quality assurance, for predictive maintenance, for increasing the uptime and optimizing the efficiency. So maybe the result of analysis is going to a SCADA system, but the data itself, I think it's a good idea to have it separate and not interfering with the actual control of a running operation. And the third one I wanted to add, I think besides analysis and running live twins, we also have WinCC Unify as an HMI system right now on it. And we are thinking also about ways how to combine it also with PLC, maybe have PLC running besides an Edge system. Maybe in the future also have other approaches that PLC is part of, also PLC app is part of the Edge system, and really create an integrated system overall. So there's more to come. It's an exciting journey which just started. And yes, it started with data collection, but we will go much further than just data collection. All right, let's see. I don't know, Chris, which application scenarios? You talked about 2 application scenarios for analyze for my existing machines and also cloud connectivity.
Cloud connectivity.
Which other application scenarios do you see coming? Or what do you think is also going to come in the future, in the next step?
Yeah, so right now, the third app scenario, bring your own developed apps to industry. This is what we are targeting on. So let's say if you have if you're like an IT focused company and willing to migrate your own app to be used on Industrial Edge. It's fully supported by Siemens, so we can help you to transfer your existing apps to get it Dockerized, and then you can publish our Edge platform. One point beside that is you can actually make money out of it. So you can actually publish your applications eventually, and then if some other users they think, yeah, this is something that he's interested in and he would like to pay for it, then you can actually make some money on your own developed app on Industrial Edge.
So this might be also a good opportunity then for a solution partner, also a machine builder, so that they create their own apps, and they could publish these apps and then put it on our marketplace, and they can earn money with apps, and they don't have to take care of the sales itself. And they, even for maybe solution partners here in the US and not doing projects in Europe, still we could earn money by offering this app to other people who are doing projects in Europe, and they could use it.
Yes. Yeah, and remember, Industry is also like a platform, so you can actually download the app from the cloud marketplace, and your app could be available in all over the world.
Right. So it's also a good promotion possibility for your company, not just for the app, but also to promote your services and your company, to have apps up there.
Correct.
And yeah, I think also that really with Edge, it all started with managing apps. And 3 years ago, Siemens bought a company to get started with it, the company Pixium. And they were 3 years ago probably already 5 years ahead of everyone else in that field. And they worked in a completely different field. At that time, they worked a lot also with fast food stores, stores overall with chains who had tons of stores and had to update the software in these different stores we have. And there are stores or companies with around 20 to 30,000 stores worldwide. And if they wanted to provide one update to all of these stores, it cost them millions to go around. And Edge really was the idea, and the concept of Edge was the idea to help them. And that's where this company, Pixium, started to basically create the Edge stack, refine it, and also make sure all the user management and all the other mechanisms work. And they already brought out around 1 million of the Edge devices. We brought already 1 million Edge devices in the field before Siemens came and bought that company. And what we did, we added all the OT knowledge to it, the drivers, the other things you need, disaster recovery, really to make sure it's not just an Edge stack, it's a production Edge stack. It's really ready to be used. It's up to the standards we have in manufacturing and industry, and that it's really running 24/7 and then fulfills the needs, that no data gets lost and everything else. So there are two more questions coming up, Chris. That's good. One is, does Industrial Edge support MQTT?
Yes, absolutely. Yeah, MQTT is actually one of the protocol we are also like aiming to to further develop. And right now, one of the MQTT connector MQTT cloud connector available in Industrial Edge that used to enable the communication, the connectivity between the edge computing and cloud computing. So MQTT Cloud Connect can be used for Industrial Edge to talk to all the other hyperscaler cloud platforms. And like I said, Edge is an open ecosystem. We're not just talking to one specific cloud platform, but we're supporting more than one, or the hyperscaler cloud platform so far.
All right, great, thanks. And another question: what is the difference between edge computing and cloud computing?
That's a great. So right now it's used in many areas. In many, one of the of edge computing is bring data to local, satisfy data. So you can run edge applications on premise, and that will reduce latencies. Some of the analysis for the data connectivity acquisition rate right now enabled on Industrial Edge is much faster than cloud computing. So if you're seeking like one industrial solution with very high frequency acquisition, then edge computing is actually your ideal solution. And more than that, we're talking about reduced latency, but also is actually the great solution, great product that integrates IT and OT. Now, computing is mainly for the IT people, but even if you do not have too much knowledge about IT, edge solution is also it's very easy to implement. So that can be used on the production level, factory level, but can be central managed on the level.
All right, thanks. So to summarize, it's really about latency, about reduction time is a big topic. yes, we have more storage on the cloud level, but we are much faster to react to signals and what's happening on the edge level. And I think also for a lot of customers, it saves cost when you don't send all the data to the cloud, but really process and pre-process data already on the edge level. Yeah? So, thanks, Chris. So I don't know, what Chris, maybe one other question. If you talk with customers, what's your recommendation on how to get started with Industrial Edge? How should somebody start, and what are the first steps they should take if they are interested, and what should they do?
Yeah, I would say first of all, don't hesitate to reach out to me, and I can get you started with like the onboarding process. So for now, even though education and we are targeting for the 3 application scenarios, but if you have any kind of applications or use cases, we can really help you to get started, to get on board with Industrial Edge. So the first step will be sign up your Industrial Edge Hub access. Definitely something we can help you to get your account set up, and then when the hardware purchased through Industry Mall, Siemens Industry Mall, and then right now, if you have like specific use cases, we can also consider to offer you the first actually to help you get started. And then there's also like trainings available, like I put in the presentation, the session. Now we have actually 3 more sessions available until October. So if you are interested to get trained to be a edge expert, talk to me. And after you get advice, we can support you to onboard your edge device to the IEM, activate your edge device, and then you download from hub to your IEM and then to your device to start deployment.
All right, thank you. And I think just to add two topics, 2 comments to that is it's always good when you want to start something really to see what is the need you have within your company. So what kind of problem do you actually try to solve? Are you trying to solve? And then what we see, it always starts with a data collection first, with creating transparency, and then having more sophisticated algorithms afterwards, and the third step, really to analyze and to optimize your processes. But even before you start your journey, you should have a goal where you want to go to and where you want to get at. And we can help with defining the steps and really making the first steps and then get you started on the journey. So with that, I'd like to close with Q&A. Thanks for posting the questions. Thanks a lot. Thanks for joining. And now I also would like to announce the next session. It's digitalization and motion control with Kevin Wu and Greg Nelson. Looking forward to it. Thank you.
Welcome, everybody. Thank you for joining this session of the Factory Automation Virtual Tour for the panel discussion on digitalization and motion control. We will discuss how the pandemic shaped the motion trend moving forward in 2022, main trends in adaptability to mobile equipment, and how robotics is impacting the motion trend now. So allow me to introduce you to your panelists. Today's panel will be moderated by Kevin Wu, Motion Controllers Product Marketing Manager from Siemens, and Craig Nelson, Senior Product Marketing Manager for High Performance Drive Systems in the Motion Control business of Siemens Industry, Inc. Joining them will be a couple of panelists. First of them is Chase Boiga, Drives and Motion Control Specialist here at Siemens, who covers the Carolinas and Virginia. Additionally, Alejandra Cota, the Project Manager from Process Control Engineering, and Antonia Garcia, Project Manager from Process Control Engineering, are joining us as well. So now I'm handing it over to them.
Thanks, Natalia. Been with Siemens for about a little over 30 years, and I have to say this is probably the most dynamic time. But I'd like to thank everyone today for joining in on this panelist view. It's a very exciting time for motion control right now. We have so many new technologies going on and just advances taking place. So welcome, everyone.
Thank you. Thank you. So to get started, Kevin, Craig, what have we learned about motion control in the last 2 years?
I'll start off. We already had a very fast-growing automation market before COVID. Automating plants and smart manufacturing, that was all really at the forefront of most industries, really to stay competitive. That was the main thing everybody was the forefront thinking. Then COVID hit, and then everything from quarantining, the labor shortage, everyone remote working, just workflow disruptions in general, and you saw e-commerce, all these different changes that really just caused exponential growth in areas such as warehouse automation. And this really supercharged this whole trend to automate manufacturing. And now we're looking at some geopolitical issues at hand, moving a lot of emphasis to onshore manufacturing. So all this is about to take hold. So it really, I would have to say, it's the wild ride continues for motion control.
And just kind of adding to what Craig was saying, I think with all these changes, one of the biggest things that people are seeing is to be adaptable and flexible. So you never know when the next change is going to happen. So I think a lot of owners of especially OEMs, they're trying to think ahead and make the things more flexible and more resistant to basically having downturn. And that's one thing that's going to impact motion. You always want to have the latest and the greatest and know that you can compete in the global market. And whatever that global market changes, that you are ready to have an impact and absorb that change right away. So yeah, so it's been a lot the last 2 years. It's really hard to navigate. Everybody was navigating new in the last 2 years, but I think we came out on top, and we want to stay on top for everyone. So yep.
Speaking of navigating new, because I think you've mentioned every disruption that we've had in the last 2.5 years, did COVID have impact on motion products development, either positive or negative? Did it have impact?
In one way, it really accelerated the shift to development of software solutions for motion control, such as mechatronics. But yes, overall, I would say, adapting to the new work situations, dealing with supply chain disruptions, along with other just unplanned priorities that come up, has delayed a certain amount of development, especially on the hardware side. And I think what a lot of people don't realize is it wasn't just getting all the component parts. We also had to get all of our R&D teams back to work and in the lab. And the thing that a lot of people aren't so aware of is that there are a lot of other delays that have come up as well. And that could be it has been in the certification process. If we take a look at once we had a product development and we'd go through the certifications, that used to only take a certain amount of time. So all these service type aspects of developing new products also has experienced some delays. So just the amount of time it takes to go through and get your new products certified, or if you made a change to them to get that recertified, that's all taken a lot more time. But just services in general, people have to think about how the impact of delays have happened. I had to get my passport renewed, and usually it's 6 to 8 weeks, and I sent it in, and it was over 4 months later before I got it back. So there's a lot of different aspects that have been disrupted over the last 2 years. It has had a little bit of delays in some products, I think.
That makes sense. So with that, what markets see the largest rate of expansion, and how's motion control playing a role in that?
Yeah, I think the biggest expansion or changes that you're really going to have seen is just people now are bringing just fleets of AGVs or automatic guided robots to the plant floors. So this has got to be the most notable visual change that you see in a lot of manufacturing now. And anywhere products are handled, or logistics centers, I think this is a huge difference.
Yeah. So, I mean, besides what Craig was talking about, the AGVs, you know, that's a very complicated solution as well. And one of the key thing about, you know, bringing this automation solution is to simplify it, make it a little bit easier. And we, you know, we wanted to create tools and just make it very user friendly, how to integrate the solution and utilize that. So actually, this kind of leads into, you know, our motion specialist, Chase Bohiki. He actually went to visit a customer, talking about a solution, how to basically increase throughput with the robotic. And, you know, I'll let him tell the story, basically how he's easily able to demonstrate with the tools that we have and show it and just kind of like, you know, wow the customer. So let's take a look at that.
As a motion control specialist at Siemens, I cover the Carolinas and Virginia. And so anything that moves back and forth or around, that usually comes to me in some point. So today I wanted to talk a little bit about a customer that we had. They had a robotic cell, and what they were trying to do was actually get it to move faster and do more cycles. They were having a lot of trouble with their manufacturer, and so they tried keeping the PLC, swapping the manufacturer of the motion control, and were running a little bit better, but still not where they wanted to. At this point, the Siemens salesperson contacted me, and we went to the customer. So the first thing that we looked at was to try to figure out, you know, what are they trying to do? And in this particular case, it was 7 identical robots, as I said, and they're all doing the same thing. It's a pick and place operation. And they wanted something that was more simplistic. One of the problems that they had with their other manufacturer was the fact that it had a lot of axes of control on top of the physical axes. It had logical axes, and that takes up a lot of system resources. And just to give you guys an idea, this is what the robot looks like. And you'll have to excuse me because these motors are not the typical motors that we would use. These I found in a storage area, and we just happen to have the ability to put them onto that robot. So they gave me the robot. I took it home. And this is the great part about it is when I took the robot home, I was able to take our demo S120 and actually physically hook it up to this robot. I am a pre-sales guy. I am definitely not post-sales. So I'm not a tuner, right? I'm not great with PID loops or anything like that. And we'll highlight the reason I said that in just a minute. So let me show you guys what I did really quick. So if we take a look at TIA Portal on my screen, okay, most of you guys are very familiar with the portal. So at this point, let me just show you what I did. So we had a PLC. In this case, it's a 1511 TF because that's the PLC that I had. And it is a T so that we have that angular synchronism, right? So the first thing that I did was we just wanted to add our drive. And you can see that down here. I added an S120. But keep in mind, guys, that you can do this with an S210. You could do this with even a G120 if the resolution and the capabilities are there, right? With an induction motor. So we don't limit that. So anyway, I added the drives. We tuned the drives for their speed loops, got them all nice and tight. And then once I did that, I went and downloaded a sample program that we have on our CEOS site. So we actually have a demo program for kinematics that you can download and just get a start. And what's great is it's actually got a comfort panel built into it. So you can download all this stuff and you've already got a demo ready to go. You can even test it out in PLC Sim, which is really cool, especially for somebody that doesn't do this every day, like me being a pre-sales guy, right? So once we do that, then we just needed to add the motion. So I added my left axis and my right axis. And as you guys can see, it's pretty simple to do. We just say which physical axis we're going to be talking to. And then we hook up, then all the rest of this gets pulled in. I didn't have to mess with any of this. This is default stuff. We put our limits in, position, speed, maxes, all that good stuff, position tolerances. And it's all right here. This is the point of how easy it is. Once we assign it to the axis, this is now our positioning axis for the left. This is our position axis for the right. So now I can do all my control with simple clicks, and there's no flipping bits and making sure that everything's okay. A lot of this is just pre-done for you. So how do we get these robots to talk to each other so that the customer can do pick and place? We actually have what's called a kinematics technology object. So in the kinematics tech object, what we do is we pick the type of kinematics that we're going to do. And I really want you guys to take a look at this because this is awesome. So in this particular case, we had a Delta picker that was a 2D, right? So as you can see, the picture looks just like the robot, right? But if I had something else, I can do a 3D. And then the picture changes. And everybody's thinking right now, well, that's a picture that doesn't actually do anything. It actually does. So the reason is, and once we set our units, see just pull downs again. The reason is because once we make this robot, I select which axis goes to which arm of the robot. And look, it highlights it too. I mean, there's no confusion here in how it sets it up, which is really nice. Okay. So once I set that up, then I go back through and it tells me, hey, let's measure all the different parts of the robot. So it's guiding you through, right? This is what makes the difference in TIA Portal, right? They've tried to make it user-friendly. And you can see that throughout the setup of this system in the dynamics. So I can limit how fast I want it to be able to move so that even if somebody were to put something extreme in there that might possibly wreck the robot, it won't let you do it. Okay, we pick our coordinate systems, all that good stuff. There's also zones that you can do. I didn't have to set up zones for this particular one, but if you didn't want the robot to go in a specific spot, you can just turn on a zone and it won't let you go there, okay? So anyway, now that we've done that, all I had to do is commission it, and this becomes live once we're online with the robot. I can also do a trace, and this is one of my favorite parts. Once you go online with your controller, this thing literally traces where the robot's going. And this is a live demo, guys. It draws little red circles or whatever it is around where your robot just moved. So you can see if it actually went to the right place or if it went somewhere else. So once I did all this, we had to tune up the position, right? Because when we added the drive, we tuned up the speed, but now we had to tune the position. So we go to our axis, right? And we go to our commissioning tab, and all we have to do is go to tuning. And then once this is loaded up, you can test your tuning however you want to. You just move the bar, add a little bit of tune, see what happens to it. And like I said earlier, I'm a pre-sales guy. I'm not a great tuner at all. But once the speed loops were set, and by the way, we have that one button tuning, so don't forget about how easy that is, then all I have to do is go here and just adjust the bar on the positioner until it gets to where I want it to be. So I did all this, right? It took me, I don't know, a day or two because I don't normally do all this. I downloaded the demo and I spent a little bit of time and I got it running. So I actually, as somebody that's never done kinematics before, I think I talked to one of our APC guys for about 30 minutes just to get some ideas on what I should do and how I should do things. In that amount of time, I was able to go from zero kinematics experience at all to making this robot that I showed you guys run back and forth at a considerable rate of speed. So I took this back to the customer with the salesman, and I thought, well, we'll have to see if we can professionally get this tuned up for the customer, right? And this was the funny part. We put the robot down in front of them, right? And they're like, okay, show us what you can do. And I set the robot to go, and they looked at me with a puzzled look on their face. And I said, well, you know, we can get it to go faster. And they go, how much faster? And I was like, I don't know, let's try. So we kept speeding up the robot and speeding it up. And I said, I'm probably going to break your robot. I don't want to break it. And said, we don't care. This is really cool. So we kept speeding it up to the point where they just went, okay, this is the fastest the robot's ever run. And I think that's a testament to how easy TIA Portal is. Everything from the setup all the way to like the tuning procedure of how to make this robot snap into place and point stop and not go overshooting. All I did was adjust a couple of numbers. I did not have to go back and tune and do torque loops. And I'm not saying that every application is like that, but most applications for most people, this is all you need to do. And the program's been pre-written for you. You just need to adjust it for your application. So if there's anything that I could push people today to say, it's like, give that Siemens TIA portal a good look. If you're ever going to do kinematics, if you're ever going to do robotics, if you're ever going to do motion control, it really is a new way of motion. And I think this is just a great direction that we're going in as Siemens.
Well, thanks, Chase, for the testimonial. And, I think one of the big takeaways here is the ease of use of an integrated motion control solution is that it's now capable of delivering for even complex kinematic applications. I mean, we all know the big game changers that are out there in technologies today that are at hand: artificial intelligence, digital twins, IIoT, advanced simulation. You got machine learning, cloud, and edge analytics, etc. But in the end, the motion programming needs to be intuitive and efficient for the engineer making this to happen. So, with tools such as graphical programming, standard application libraries, drag and drop designs, the automatic device detection, self-tuning, as Chase mentioned, it's, you have the built-in diagnostics as well. Then, being able for the engineer to put this together very efficiently, this is really what makes the world go around, as we say in the motion control world. A lot of those other technologies are really great, but in the beginning, you've got to get the stuff running. So, that's a key thing I think now, is just that there is a lot more ease of use in the motion control programming.
That's so true. And Craig, this week, Siemens was making headlines for all sorts of great reasons. And our CEO, Barbara Hampton, said this week that the future of manufacturing needs to merge this global innovation, all of these technologies that you mentioned, with local production. That way we avoid all of these supply chain challenges that the pandemic had brought forward. And she called this process with a very interesting word. She called it glocalization. So, could you talk a little bit about glocalization and what would that mean for motion control?
Yeah, maybe I'll take this one, Craig.
Okay, good, Kevin.
So, I mean, it's new to me too. I had to say it twice, globalization. I mean, what does it really mean? I mean, when that first came to my mind, multiple locations supplying versus a single location. So it definitely makes sense that we want to spread out, multiple locations for a supplier. But the trend is actually more than that. It's the capability to rapidly, produce things where they need it and scale accordingly. I mean, that's kind of part of our TI portal story, is to be able to scale up, scale down based on what you need. So, that kind of faces a lot of industrial challenges right now that we face in the US, is our age, automation systems, and our slow adoption to, the digitalization. This will actually hinder a lot of US manufacturers to compete and also, better prepare for the next crisis. But some of these challenges are already addressed with our whole Siemens total integrated automation and also TI portal software as well. So yeah, so I think Siemens is in a great place to bring innovations to address some of these challenges that we face. And that word globalization, I do have to say a couple of times to get it right, because I keep saying globalization, but it's globalization. So yeah, that's but I think that term's going to catch on. It's going to be like a hashtag globalization everywhere.
Yeah, once we learn how to say it. I don't mean to cut in, but we do have a number of questions that are coming in, and I think it would make it better if we start addressing them maybe as we go. And one of them I think is very, very timely, so I want to single it out. It's a question that came in, and they're asking about, well, okay, what about solution providers? Where do we fit in? How do we get into this motion control train? So maybe I think that's actually perfect from whom we have here on the panel.
Yeah. So we actually have process control engineering, our solution partners out in Arizona. They've been working with robotics. They're experts in robotics. And they actually have a project. They actually been working on a couple projects. So we want them to kind of talk about the project they're working on with motion control and robotics. So, please, we welcome you, and then please take it away.
Okay. Well, hello everyone. My name is Alejandra Cota. I am the engineering manager at Process Control Engineering. I have been working here for 3 years now. And in those 3 years, we have experienced a big growth on the number of projects related to the robotics field. The use of industrial robots is continuously growing. They're increasingly being used in machines and plants. I think their standardized mechanics are very well developed and highly flexible in terms of movement. So robots are increasingly replacing expensive specialist mechanics. I don't know if you understand what I am saying. I'm talking about robots replacing some very high costly machines. And that's a huge opportunity for robots integrators in this area. And well, we have a couple of applications to show you. My coworker here, Antonio, have a show. Is going to show a brief presentation of a couple of applications we have done recently, integrating collaborative robots and a Siemens PLC. Antonio.
Hello, my name is Antonio Garcia. I'm project engineer here at Process Control Engineering. As my coworker Alejandra told you, we have been working in some robotic solutions lately. So I would like to show that to you. I don't know if you can help me just presenting my screen.
We can see it.
Okay. So let me show you this machine. In this project, we use a 7-axis UR cobot. The cobot has a 7 linear axis, and the cobot is looking down. The 7-axis is for moving the cobot from the CNC1 to the CNC2. The part that is machined on the CNC1, the cobot takes the part and put it on the drawer on the first vision system. The vision system inspects it, and if the part is correct, it takes it to the second CNC. If not, the cobot takes it to scrap. After that, the second CNC has finished. The robot takes the part and put it again on the drawer, but this time under the second vision system. If the part is correct, the cobot puts the part under inside the drawer for storage, and if not, the cobot takes it to scrap. We have the cobot connected to a 1200 Siemens safety PLC. It controls the PLC. It controls the safety light curtains and safety mats. So when it senses that someone is near to the cobot, it slows down its velocity to avoid any accident. And it also controls the CNC doors and the 7-axis of the cobot with a servo drive. We also have another project we're working on. This is a simulation that we did in the KUKA sim. This is a KUKA robot of 6 axes. The robot is used to take some parts from a dispenser, and it puts them in a base under a sonotrode. The robot takes 8 little pins from the dispenser on the other side and places them on the part. The sonotrode goes down and insert the pins. It flips the part and places another 8 pins. After all of this process, it takes the part to the second sonotrode. It places 2 pins in there, flips the part again, and places another 2 pins. And finally, it places the part on the table. In this project, the IOs for the sonotrode and the safety is controlled by the controller of the robot. This is not a cobot. This is an industrial robot. We don't have here all the safety that it should have. It has to be in a cage. We don't have it here because we couldn't be able to visualize it in the simulation. But it has to be with a cage. And right now it's putting the last 2 pins on the second sonotrode. So it takes the pins from the dispenser on your left, place it there. Then it waits for the sonotrode to place them where it goes, and then the part is ready.
Yes, these were just a couple of applications we prepared for you. I don't know if you guys have any questions on this.
Some great examples. Yeah, what value a solution provider can play in automating plants, especially in the first example. It's not only implementing a collaborative robot to automate the movement from one machine to the next machine, but you guys talk about vision, so you're integrating the vision. These like CNCs, so you probably have automated door control that you need to control, as well as the robot arm loading, stacking into the one machine to the next machine. So a lot of complexities here. And then you have the whole safety concept that you guys come in with a risk assessment and do the safety as well. So, I mean, it's big value from the big amount of value that the solution provider can really play in automating a plant floor like this. So it's good to see.
Yeah, thank you for sharing that story. Yeah. Natalia, I think you're muted as well.
Sorry, I did mute myself.
Okay.
What I meant to say is, Kevin, is that where you would see technology controllers come in?
Yes, I mean, technology controls should be able to simplify it, but I don't want to go into the great detail of what we can do with the robotics. But I think moving forward, a lot of our technology control CPU is to make it more user friendly and be able to take any project with robotics and be able to get it started up very simply. That's why, especially for solution provider partners and providers, they can take any robotics project and get it done in less than 1 or 2 weeks, and not spend days and days trying to write meticulous programming and open communication, stuff like that. So yeah, the moving forward is about more easy integration and more user friendliness. I think that's where the trend with our motion solution and motion products are going forward with it. As you will see here more from us, you're going to hear a lot from us that later on the innovations are going to be make it very user friendly stuff. But before I keep going blah 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 on more things, we actually do have a great question that came in. If it's okay if I read a question. So the question is basically, can we address some of the market challenges in today, such as bringing the legacy equipment up to date, or even adding some flexible platform-based mechatronic solution to meet diverse application needs in motion control? I can take a first stab at it, or Craig, maybe one, or maybe even Alexandra, Antonio. If you guys have any input, feel free. Yeah. So what I call, that's a great question, by the way, and that's a question that hits a home for a lot of folks in the U.S. here with kind of legacy equipment. We just want to get it running. Siemens actually does a great job of basically help to migrate legacy equipments. I mean, we have the S5, and I've been seeing so many references with S5 to the S7-1500, even the S7-300 to S7-1500. I think the biggest challenge there is, if you look at today's PLC controller, it can do so much more. Even the input-output card, even the motion control part, it can do so much more compared to the legacy equipment that we have. So it's not, it's the issue there is not that our PLC is slower than the past. It's more like we can do the same, but how much feature do you want to add, and where do you stop? and a lot of times people want them to do the same thing. So and of course the reason why we want to address that, a lot of people want to look at that is the components, right? Legacy products, the components are gone, they need to move over. So we have a lot of migration tool that helps with that, and oftentimes there's more we can do a me too, do exactly the same, but then I think owner gets excited, engineer gets excited, want to add more feature and do more. So it's where do you cut off to do more, right? So I don't know if you guys have any more feedback to provide for that question.
Yes, actually, in our company, we have made a lot of projects where we have to update old machines and integrate some new technologies like vision system and robot, different robots for example, this application that Antonio just showed you, it is a good example because these two CNC machines, these were not new specifically. So we integrate a robot, but we needed a 7-axis with meets motion, the servo motors. So yeah, I think this is what you are talking about in your question. How do we integrate new technologies to all machines to make it like better, no? Working with mechatronic systems.
Yeah, part of that upgrade as well with the change to a lot more of software type solutions where we can upgrade the firmware versus having to change out hardware. This really helps in that aspect as well. But overall, we were talking about some of, this automation and what it entails with the, technology controller, bringing vision into the solution, bringing in the safety integrated. If you look at today's controllers, something that's really helping out is that in a previous solution like this, it would have took multiple controllers for these different type of technologies. Having the capability in one controller now to handle all these functions with the vision, with the drives, with the safety, and solving that in a single controller where you don't have to do so much integration from controller to controller. I think this is also a big ease of use step for us.
Absolutely. I want to switch gears a little bit and bring up another question because one of the things that we advertise is talking about, looking forward, what we might expect. So I don't know which one of you want to take it, but the question says, do you see any new technologies disrupting the market of motion control? Which one?
I'll talk a little bit more on I'm more on the drive side. I'll talk a little bit more on the drives. Some of the new technologies that are out there are around the power devices, the new type of power devices made out of gallium nitrate. So they're offering a lot of promise out there due to their, they're very highly efficient and they have real small power density. So much power density in them, they could really make, drives a lot smaller. But I would say it's just, they're not economical yet until we get the scale up, which will probably still be, I think, quite a few years away before we see any type of disruption on the hardware side. Where I did see a sea change, I thought coming in, at least pre-COVID, was really in industrial communications, with the OPC UA, and then with the TSN capability as well for network communications. We heard a lot of these, 2019, a lot of different shows, everyone was really touting this. And I think this might be where, we see some of the priorities being put to, dealing with today's problems versus, innovating for, the next realm of plant communications.
Yeah. I mean, just kind of adding to what Craig's saying. I mean, the other big, disruptions that you guys already know, it's already disrupted our lives. Cloud computing, right? OPC UA. It's like, and also computing, just be able to do everything in the cloud, where everything you do, even my day-to-day, work, we have everything saved onto the cloud. Then another big thing is the, cybersecurity. How does it come in? So all these are some of these technologies that, in the consumer side will slowly trickle over to the industrial side that will impact motion control in your OEM machines and everything. But I think with the way that I believe Siemens is moving is, like I keep repeating the same thing again, we're trying to make it easier for people to adapt those. Make it easier. We're trying to, not making it more complicated, but make it easier for people to embrace the new technology and be able to, fire up and get going. Nowadays, we tend to move faster. We react faster. I always tell my kids to slow down. I have 3 kids, to read things, digest, and then and think about it. But the way that our technology is embracing, surrounding us, we can pick it up, program them, in the digital world, in the simulator world, and get everything going without the actual hardware. You don't need that actual hardware there. You can actually program everything with the computer in the cloud and be able to get going. So I think that's some of the new technology that will disrupt. But I think Siemens is ready for that. I think Siemens already kind of making that change already. So just be on the lookout for that. So
yeah, you brought up two things. Not so much disruption is reaction to disruption. I think you're starting to see a lot new technologies coming in and security, preventing the cybersecurity. And, also I think what we're seeing a lot more of as well is, capabilities of other things that are going to cause, a lot more change to be able to handle these as well. So, again, from the network capability, from the security aspect of it, the ease of use, any type of change you see, I think we're becoming a lot quicker reacting to these.
yeah, and I'm going to do a shameless plug right now with the cybersecurity. I think Natalia also mentioned the next panelist, right? The topic is on cybersecurity. So stay tuned for that. I think my coworker Louis will go in great depth, get you protected, secured, maybe even
How to get started if you don't know where to start. As well.
Maybe give you warm hugs as well.
Yeah. Again, a lot of the technology is being to be other reactionary measures I see too. And Kevin, you kind of alluded to this. Everyone is experiencing delivery issues now, and with our simulation capability, the way we can go in and programming, do all of our PLC programming, the drive integration, all those other technologies, we can move so far ahead without even needing the hardware now. So yeah, it's not so much disruption, but capability of managing any type of disruption with a lot of the new motion control technologies. I think is more what the topics are around.
Yes. So we're coming up on time, but I thought we can take one more before we have to wrap it up. But we talked about, expansion. We're talking about how things are changing. So one of the things that's coming up in the area that's coming up on the horizon is the whole expansion of mobile equipment, such as AGVs, AMRs. So is motion control shaping it? And if so, in which way? So if you can address that, we'll take that as our last question, and then I'll wrap it up.
All right. Yeah, the applications or the use of automatic guided vehicles or automated mobile robots, because it seems like everyone is trying to build them or implementing them now. So, I mean, it's a good topic to discuss today. On the motion control side, being able to run these devices off, which are since they're mobile, they're going to be running off a battery. So more specifically a 24 or 48 volt typical application which you would have for these. So what you're seeing is more and more devices such as servos being able to operate off of these. But previously, if you looked at a lot of the products that were out there running off servos, let's say running off 24 or 48 volt DC, they didn't have a lot of the technology to be, to integrate them in on industrial Ethernet or have these safety features so we could do a safe limited speed when somebody gets near them, and then tie everything on back up through the controller 5G and, make sure we have collision avoidance and path guidance as well. So a lot of things happening around AGVs and AMRs presently, and just we're going to see them more and more with all the other conditions going on today.
I'm actually blown away by just the amount of AGVs and these applications, especially with grocery applications where a bunch of robots are packing, bringing things, and be able to be collaborative. And I think how motion control play in that is, there's a lot of development already on the consumer side, I guess, not necessarily on the industrial side, but some on the industrial side as well. But a lot of open source. These are development open source. So, the IPC having faster computing, and Siemens, does provide a lot of, the latest IPC where we can support that open source. So I feel like the motion control is part of that. It's not going to be the main part, but it needs to be able to integrate and be able to be part of that, take the open source development, the code is already existing, and be able to utilize that and support that. That's kind of how I see us motion control be part of that. You want to be part of that innovation, part of that development, part of that, adaptability already in the market. So, yeah.
And I think this is where you're going to see a big crossover between the industrial and the commercial side with these type of technologies for autonomous operation like this.
Right.
Absolutely. Thank you so much, Craig, and also Kevin, Alejandra, Antonio, and Chase. Let's switch gears a little bit and continue in the Q&A session now.
Thank you for and welcome back on stage, Craig and Kevin. Wonderful to have you here. That was a really good session, and a lot of questions were already covered. But guess what? We do have a very active audience today, and more questions came in. So thank you for continuing to submit those. And remember, participate in the polls as well. If you exit the full screen mode, they appear on your right-hand side. So let's get straight into it. We had a few questions that came in right as we were finishing up the session. And the first one came from Bob, and he's asking, Siemens is partners in some AGVs. Do you have your own version in the market? Going to be one for you, probably, Craig.
Yeah, sure. So Siemens does have a fleet management system for AGVs called C-Move. So we do the management of the fleet and if you want to call it, deciding the AGV path so they can operate in the most efficient way, as well as providing the motion control and the drives and motors for AGVs. But Siemens doesn't produce their own complete AGV.
It's important to separate the two, but thanks so much for the question, Bob. Another question that actually got asked a few minutes ago came from Jared. And Jared, I really appreciate how active you are here today. This one's probably going to be for you, Kevin, because it goes similar to the kinematics object that the testimony referenced to. Are there any other motion objects available to assist with motion integrators?
Okay, so from what Chase was talking about, that was our kinematic technology object, which you can refer to as motion object as well. So that's really user-friendly. As you can see, it goes in step by step. And it's focusing that it's user-friendly with a lot of graphic help. But we also have other technology objects for camming, for speed, for position. But I think another thing that really helps, especially for programmers and POC users with TI Portal, it's our application examples. On the Siemens support website, which will provide you guys a link. There's a lot of information there, but if you type in, the most important links with motion control, there will be all the application examples, firmware, even the drives. They're all there. You can find so much information there. So application examples are there. Application example also comes with the HMI template that you can utilize, which is great for if you're starting a new machine and you just kind of want to see how the HMI template works. You can take bits and pieces of that and use it for your own code, for your own machine. It really cuts down your commission time. Okay, and in there usually there's some drive they recommend in there with some starting projects, and then you can just break into pieces for how you want to use it. So that would really help as another tool to help with that.
Just one thing to add on to that, when we really talk about usability, those technology objects which we use. When they're implemented in the PLC, they work with the drive to be able to give it a, if you want to call it a sort of a pre-engineered setup for all the communications to the drive, all the diagnostics to the drive. There's a lot being accomplished by having that technology object control the drive, not just in the control, but in the complete commissioning and setup as well. So it cuts down on most of the aspects of the integration. And that's really what reduces so much of the engineering time in our motion control solutions when you use these libraries and these technology objects to basically just reduce all the different aspects that you would typically have to put into integrating in drives into your motion.
That's a very good point. Thanks for that question, Garrett. Okay, another question came in from Rob. And Rob is asking, what should operators do to minimize the security risks in hardware PLCs?
Okay.
Maybe you can just mention it, but save the rest for the best because we know what's coming.
Yeah. So, I mean, the quick answer to that, as you know, with TI Portal V17, the security by default is built into our PLC. But there's a lot more to it. And we do have an upcoming session. I believe that's what you're heading to, Natalia.
That's right.
So do stay tuned for that, as there will be a lot more information provided to you to kind of cover the whole security aspect with PLCs and even the network devices. So, yeah, I don't know if you got anything to add for
Yeah,
drives.
I mean, even when you look at the field level devices, you're starting to see, a whole design aspect around security with the field level. So again, additional protection. And again, we look at that when we look at our security as we want to do, the different walls, the different modes. And that goes, of course, the PLC is a big aspect of that and the whole automation level. But this also goes down to your device level as well, including drives. So more and more, you're going to see that security is a big aspect of what's offered from the device level as well.
Very true. You had addressed a different question about AGVs at the beginning of our Q&A, and we actually had a different question on the same topic come in. So perhaps you can take that one as well. And this one came from John, who's asking, how is motion control shaping the expansion of mobile equipment, such as AGVs, but also AMRs?
Okay. AGV, automated guided vehicles, and AMR, which is autonomous mobile robots, those are just, again, growing so fast in popularity as we try to deal with different supply chain aspects and labor aspects. So when we take a look at that, and one of the key things that's really making this a viable solution is the battery technology that allows us to have mobile applications that run motion control. So when we take a look at that, having the smaller servos that'll run off a battery, 24 and 48 volts, this is a big aspect of it. And also networking all of those AGVs together. So that really brings in a networking aspect, but the safety and having this different landscape of safety of having autonomous vehicles running around with and without people. There's different aspects that you need to be able to address and recover from as well. So the safety integrated technology really is a big part that and battery technology, networking capabilities, these are sort of all coming together at once to really allow the expansion in technology for all this autonomous.
And just kind of to add to that, to make it easy, right? Many people think of, I want to do an AGV or MR solution. It might be complicated. I'm gonna have to use different software. But we actually have the products and solution all built into TI Portal. So that's the key. So, for someone who's looking to starting an AGV or MR design, they can actually just start looking at TI Portal, looking at our products, and they can actually have a whole comprehensive solution.
And also tying back to that earlier question, we have some product partners we work with as well.
Very true.
They do if you look at the wheels, we have the motorized wheels for all these autonomous devices as well. And they have the motorized wheels that integrate in with our products as well.
Very true. When you started answering that question at the beginning at AGVs and AMRs, you mentioned safety. A very, very important consideration in the industrial environment. And we actually had a few questions that came in that touch on that. So I'm going to try to sum them up here.
Okay.
Let me go back.
Tough job to sum them up.
I'm trying to scroll up and down.
Okay.
Okay, so this one, either of you can probably do it, but here is a question. Is safety over network versus hardwire key to motion control in the future? What would you say on that?
Yeah, having the networking capability is really going to allow a lot of different landscape ideas of how we're going to address safety. And this is from the safety aspect and the efficiency aspect of it. And being able to network it together, being able to have the flexibility as well that a network will provide versus a hardwire would provide. When we started getting into some of the more advanced safety concepts, the safe limited speed, the safe positioning, safe limited torque as well, and you're going to run into a lot of those type of applications as well to make sure that if the AGV or robot arm was to move near a person, you could limit the torque on it as well on the safety. That's all a big aspect of it. But networking also provides other layers too. If we take a look at a lot of the storage applications, they have to run through different storage facilities and different doors and different cold storage.
Yes.
And if we even tie another one of our products into this, which is C-Door, which is the automated door control. So now the door control can be networked as well. So now if you have your automated guided vehicle running up to the cold storage door, it knows when it's going to approach and can efficiently open and close the door behind it, not let out so much temperature, not make the AGV wait for the door to open. So there's big advances in efficiency by having everything networked together as well. And then you also take a look at that from the aspect of being able to do the maintenance diagnostics as well. Again, how long the AGV has been running on the same wheel, because those wear out. If that automated door, you can basically have the counter built into these devices on the door. So okay, when it hits that limit of operations, then you can start scheduling your maintenance and not wait for something to break down.
Yeah, I do want to add something as well. So to talk about safety via hardwire or network. If you think about the hardwire, like what Craig was saying, the efficiency, but you're also limited when it's hardwire. As things get more mobile, moving around, I know you have these cables that can do certain bend radius whatsoever, but eventually it's going to wear it down. But when you move to network safety, that's where you could possibly even do wireless safety. Wireless safety a couple years ago, people are very hesitant with that, but now it's becoming more and more common. And having wireless safety, especially in the AGV and MR application, that just make them very mobile. And that's why if you even look at our Siemens has a Profinet eStop that usually is hardwired into our device, but now it's on Profinet.
Profinet.
Yeah, so you can have that Profinet device right within the AGV and it can be wireless controlled. So it just gives you so much flexibility and efficiency.
Yeah, new concepts, just so many new concepts that are just going to increase the whole industrial.
Speaking of that,
I don't think it's new. I think it's proven concept, right?
It is
proven concept. It's not new, but it's being proven and being utilized a lot. So
new concept, proven concept, new ideas. This ties into the question that, as I said, we had a few about safety, and we had a question come in that said, "What are some of those new ideas in safety of machinery?" And I wonder if we do have listeners from Canada and also I think even a few from Europe who are tuning in, or at least in the morning they were. That
late night grub.
The question was, what are the new ideas regarding safety in machinery, and also how is this different from the US? So new ideas, new concepts, safety of machinery. What are some of those new ideas?
Well, I can start off with that. Some of the ideas are just adoptions and go into more of a a global consensus as how safety should be done. So you have different safety standards that are now all coming together and becoming a centralized safety standard that everyone goes by. And really, it's taking a lot of best idea approach. Who's got the best idea? One of these things that we're seeing really come more to the U.S. from Europe is in, if you look at it in safety, it's in the documentation of how the safety is set up, how it works. So you have the safety acceptance tests of a lot of these safety features on the machine. And what we've done is we've really integrated that into our commissioning software to be able to say, okay, this is the safety function on the drive. We can test out the complete safety function. Basically give you data on this is the functional reaction of the safety system. This is what happens to the machine when the safety system occurs, and giving proof that it it reacts in a safe way, in the expected way. And if there's any changes, that changes can be compared to the original system. So I think that's what we're seeing a lot is just additional is just in the congruent standards and accepting the best in class ideas.
I mean, to add to that, you got to look at in Europe, the safety standard is a little bit more tougher because of more regulations and there's more accountability, I guess. That's why some of the safety regulations, especially in machinery, I feel like this is a safety topic, and I'm going to motion that. We should have a safety topic here, but
we do have a safety booth, so do feel free to check it out, and we have experts happy to chat with you live right now.
But the whole key thing is that the safety regulation is more. I think they're more advanced and more accountability. So structured. So some of those eventually will make it into US as they adopt those regulations. So I feel like in a way Siemens is trying to adopting the Europe standard, and when Europe standard goes international standard, then when US goes into international standard, it really helps for production. I guess customers who are shipping globally, they're covered.
They're
not
a connected word.
Yes. So either way, they're covered. Where if you just work in US region and then you ship it to Europe or somewhere, then you kind of have to catch up in a huge modification to your safety. And safety should never be a huge interference to your machine. So the way that we design our safety in our machinery is make it easier to apply it. So.
Very true.
Okay.
When we were talking about hardware versus network, you gave an example of the automatic door that opens right as AMR is approaching in, and that kind of probably I wonder if this inspired this question because the question is how important is energy efficiency in motion control systems? Because we were talking how the temperature can drop and things like that. So let's talk a little bit about that energy efficiency in motion control. Thank you so much for submitting that question.
And that's a big subject, and there's a lot of different aspects of it too. But the short question, it's very important in motion control from the whole holistic view that everybody's looking at. Especially when we're talking AMRs that are battery operated, you want to make sure you can get the most life expectancy or the operation out of that battery. So, looking at efficient synchronous motors that they're typically running, the drive technology, being able to go into different modes that, a sleep mode that doesn't consume much. But then when we get more on production machines as well, there's a lot of ideas there, having a drive system with common DC bus or regenerative capability, looking at the gearboxes too, having the most efficient gearboxes. But that's a big subject. But more and more that's becoming a lot more important, not just installing a motion control system,
not
but
so much an afterthought anymore.
An efficient motion control system.
Very good. Kevin, I do have one for you. Because it's about robotics. And the question is the following: is robotics a key driving factor of motion control? Because we talked about a number of things. We talked about new ideas about efficiency, robotics.
Yes. And also PCE, which is our solution partner, they also show the KUKA robot and show how basically robotics is now part of the kind of automation design. And the flexibility and then the movement, the free degree of movement is there. So I think a lot of people are adopting robotics. And I think a lot of question is basically how does robotic actually play into the Siemens kind of technology motion POC? And just kind of a little kind of shout out, I do have an on-demand video that does talk about it. So do kind of click right there. I think it's right-hand corner.
Right now.
On-demand video, there's a whole robotics section.
Yeah, right now you are in Agenda, where you see our live stream, and then all of the program is beneath it. The next tab over to your right is on-demand video, and we have a video from Kevin right there, so feel free to watch.
So please do tune that. That will explain basically how our semantic POC can actually interact and basically make the robotics very easy. And also Chase actually talked about the kinematic technology object, how he can actually run the simulation in there and in 3D, and you can basically program your path and be able to test that all basically in your TI portal environment without having actually to build the hardware and do that. So that's the biggest advantage there. So
awesome. Thank you so much. I appreciate all of your answers, Craig. Kevin, we actually finishing up on time, so this is also very good. And thank you for staying with us. Our next session will talk about industrial cybersecurity. So something that we got a question about and Kevin had alluded to. So stay tuned for that. And right after it, we'll have the presenters live here in the studio on stage. We can talk more.
Thanks.
Welcome, everyone. Thank you for joining this session for a panel discussion on industrial cybersecurity, from concepts to solutions. Allow me to introduce you to your panelists. The speakers on the panel today represent different aspects that should be considered when talking cybersecurity. We have Luis Narvaez, who is the Product Marketing Manager for Semantic Industrial Security here at Siemens. Luis has been in the industry for over a decade and has developed a strong automation background since graduating with a degree in electrical engineering from the University of Central Florida. We also have Kyle McMillan with us on the panel. Kyle is an electrical engineer that found a calling in industrial cybersecurity. He works with nearly every aspect of the topic, from corporate policies and network management through secure development life cycles for products, all the way to the support for end users and secure application design. Also joining us today are Wayne Cantrell, who's a Senior Principal Systems Engineer at Siemens Government Technologies, where his main focus is factory automation and operational technology cyber protection in the government marketplace. We also have Chuck Tommy, a digital connectivity executive from Siemens. Chuck has over 25 years of experience with process and factory automation and holds a master's degree in cybersecurity operations and forensics. He is a global industrial cybersecurity professional and a certified ethical hacker. As you see, you're in very good hands today, so let me kick it off to our panel for a welcome.
Hi, everyone. I'm Luis Narvaez. Thank you for joining on today's session.
Hi, good afternoon. Wayne Cantrell. Glad to be here and welcome.
Hello, everyone. Chuck Tommy, and again, glad to be here. Hope we have a lively discussion.
And I'm Kyle McMillan. Look forward to hearing all of your questions, comments, and concerns as we go through this today.
All right. Well, with that, let's jump right in. And I'm going to start with one big question that any of you guys are welcome to take, but the one that probably a lot of our listeners might think about, and that is, when do cyber attacks do the most damage? Is there such time?
So Natalia, I'll start with this one a bit. I've had some conversations with several customers. There seems to be a point in every application when something is occurring in that application that is most critical. For instance, a certain time in steel mills, there are certain activities like maybe the movement of molten material. If we go to the extremes, if you are protecting against a nuclear missile attack at the point that nuclear missiles are coming at you, then that's the most damage. Those types of things. And as we've looked at that, we've determined that maybe you want to add some additional cyber protections during the critical part of your process. And we worked out some solutions with Siemens products that really fit the need. One recently was the launching of satellites into space, and we worked out a nice solution for that to add some extra cyber protections during that launch process. So those are the most critical. Look at your application, see what's most critical, and maybe you want to dynamically add some cyber protections during that point in time. So that's good for me.
I'll go ahead and add to that is, it's there's no one size fits all answer to that. There's no anytime a cyber attack happens, it's not good, right? And sometimes you don't even know when there's been any kind of intrusion on your network, on your industrial control system. And so there's some times where there are situations where hackers or malicious actors or whatever the case, whatever their intention is, they may sit on the network for months, if not years, or weeks, and you may not know about it. So And when they strike, it could be at a most critical time during the process or during production or whatever it is that you're doing. And if you could think about like the implications of, I don't know, like what Wayne brought up, you brought up a steel mill as an example. There's a lot of safety precautions in steel mills that, you can't afford to bypass or to go down or to fail. And so, God forbid, let me knock on wood, that never happens to anybody, but the implications are bad. And obviously, there's no opportune time to go through a cyber attack, right? There's no good time to do it. So, yeah.
There is never a good time for a cyber attack. Any time is a bad time. So with that, I think that would really lead me to ask the next question. And
to interrupt, we just have a question. Do we want to answer those right now? We have one in the chat.
Sure. We can take that question if you'd like. So we do have a question, and that is, and let me pop it up because that's a good one, and I'm sure a lot of people on the call would wonder about it, because as I look at our registration list, some people come from really big companies, some people come from maybe lesser so, smaller, medium enterprises. So the question that we have coming in from MB is, should smaller utilities take the same precautions for cybersecurity as larger utilities? What would be a good standard that a smaller organization should adhere to?
So
I think
that the utility question, it brings up regulations, right? So, the NERC CIP regulations sometimes are applied in a rolling fashion, and starting with the larger utilities because they have more resources to get them rolled out. But eventually what I've seen is typically they flow downhill and everybody is required to meet the same requirements, right? From a requirements compliance perspective, it's going to be the same. Now, how you implement those requirements and controls may be very different between a larger utility and a smaller utility because of the difference in resources and teams. But again, that's something that gets very specific. Some folks think that, well, the larger utilities may be able to afford more automation and more software and that kind of thing to help them. But in a lot of times, you need to be looking for that force multiplier effect, right, of automation software. And I'm talking about automation as far as being able to automate inventory, automate initial responses, those kind of things. Those become more important for the smaller teams, right, that don't have as many resources. So it's a little bit different way of thinking about it, but they can be very different how you implement your controls based on the size of the team that you have to do that with.
And just to add to that, Chuck, I would say that you're exactly right. Regulations are not written to be prescriptive in how you meet them. So there's a lot of room for interpretation whenever it comes to how you meet those requirements. But the one thing that everybody has in common, whether you're a large utility or a small operator, is that the mission is the same. Right? You're always defending your home turf, and that gives you a home field advantage. That starts by just understanding what you've got to defend. What's the impact to your operations, what's most critical to you, and starting to put choke points in place around it. So you're going to do that in different ways, depending on the tools that you have available. And just like Chuck said, the amount of headcount that you can throw at the problem. But everyone's going through that same process.
Kyle, to piggyback on that, I think later today we can also talk about, what do you take on yourself and what do you perhaps outsource? But let's save that for a slightly later in the discussion. But I want to piggyback on another thing that you have mentioned, regarding, this is your turf, you protect your house. So with that, perhaps there are some simple steps that people can take to start hardening that cybersecurity? And if so, what are those steps?
The first thing is really just understanding what it is that you're trying to protect. And that's a technical question on the one hand, right? So what sits on your networks? Where is it? Where is it located? What's around it? And that's actually the fairly easy question. The next question that you have to ask is, how much are we willing to invest to protect it? What's the risk to the organization? What's the impact if those assets are compromised? And that's usually a much harder question, because you have to start talking about that relative risk with a lot of different stakeholders. It's not just your operations. It's not just maintenance. It's not just management. Everyone sits in the same room and has to come to a common agreement.
Yeah, I think I think in addition to definitely you need to have a plan, right? I think that's what it kind of boils down to is kind of having a plan in place first as to what's critical, what are you willing to invest, what's the implications of a given cyber attack. But I think even before I guess assuming that somebody has already made the decision, the conscious decision that, hey, we want to secure our industrial control system, and maybe they're in that phase where they're trying to navigate the next step or anything like that. I think one of the most simple things that anybody can do is an inventory, right? Take an inventory of what's installed on your factory floor and your processes, the devices that are on there. Can just knowing what's out there, first of all, knowing if you have backups, knowing are those products obsolete, are there any known vulnerabilities? That's kind of the next step that you take once you have that list of install base, and you can kind of start to build up a plan just from knowing that information alone, knowing where those gaps are and knowing those products are.
Yeah, the NIST organization has some good guidelines. So if you break down the NIST standard, there's things that the facility has to do. There's the configuration or the engineering of the system that goes in, and then there's the capability of the products. And so we've taken that from a Siemens standpoint and broken it down and developed a white paper document that breaks down the NIST standard by section and identifies who is the responsible party. And then once we get down to the product side, we've identified the capabilities of the Siemens products that meets that NIST standard. So that might be a good place to start or a good checklist for you.
And Wayne, that's a very good point. And we have a number of actually questions. They came both through the chat and through the question panel. And some of them are really, a couple of them all boil down to the whole idea of what does Siemens do for this? How are we helping secure that manufacturing process in the face of these rising cyber attacks? They're just bubbling up right and left. Somebody is mentioning it's up 250% recently. So there's also increased focus from U.S. government, something that you know a little bit more about. So between the question that we have from the chat and the question box, perhaps you can, Kyle and Wayne, both of you can address how is Siemens helping secure manufacturing and in infrastructure in the face of these rising cyber attacks?
Kyle, you want to start?
Well, sure. That's a super broad question. But let's start within the context of Executive Order 14028, the initiative to address our nation's cybersecurity. That executive order has spawned an awful lot of activity, not just within critical manufacturing and infrastructure, but also with a number of system vendors that sell into that, and really the whole ecosystem. That's caused a lot of people to get together and try to figure out, those hard questions that I talked about earlier. What are we trying to protect? How much do we want to work to protect it? So Siemens has taken a long-standing approach of using standards to drive our product development process and make sure that we develop systems securely. So that's 62443-4-1. And also that they have features that are necessary to be incorporated in secure systems. That goes to 62443-4-2, -3-3, and -2-4 for those of you playing the home game. It can be an alphabet soup, absolutely. But through use of those standards, we're able to have a common conversation, right, down to our product suppliers, up to our customers, system integrators, and everybody else who's involved in the whole ecosystem of cybersecurity.
Yeah, and I guess get a little bit deeper from the technical side, we have things like threat detection that you would use. We have partnered with several of the, I would say, the best in class threat detection providers in the industry. Some of their software mechanisms actually run inside Siemens hardware. We've married the threat response with that threat detection, so we can take automatic actions in your facility when a cyber attack occurs. We can offer planning. We have services that will go through and do an analysis of your plant and help you define your vulnerabilities, where it be Siemens products in there or not, also tying in with Microsoft. And so we provide those services as well. And getting down to the first question, I saw a question pop up about, you know, how would we protect at certain critical areas. We have products like our Scale and Assess products that you can provide a digital input into that and automatically change your protection rules on the fly. So a dynamic protection. So we have several technical capabilities that will help you protect your plant, and also can help with the standards as well. So just a wide range of capabilities that we have, and we're always happy to sit down with you as the customer and look at your needs and support you with any of those cyber activities.
That's excellent. Thank you, Wayne. And you mentioned Scale and we actually slightly different, but in that line, we had another question come through the chat, and perhaps Louis and Wayne, if you guys want to take this one. And the question came from MT, and this person is asking, how is cybersecurity implemented for control systems like PLC?
Yeah, I'll start off with that one. You know, I think in general, I think there's not a one size fits all, right? Kyle mentioned the IEC standard is 62443 as kind of a guideline to reference for protecting systems, like protecting your industrial control systems as a whole, right? So first of all, I guess I want to start off and say cybersecurity doesn't start at the PLC, right? There's a lot more around it. There's a lot more fundamental pieces that go into an industrial control system that also require additional protection measures. The second thing I want to add is I can only speak on the sense of like Siemens features, right? Like what have we done in our PLC products recently? Oh, looks like we lost Wayne for a moment there. But some innovations we've done in our PLC, right? So obviously Siemens, we've taken a really strong effort over the last several years to protect our industrial products, protect our industrial control systems from securing our manufacturing processes. We heard Kyle mention that earlier. To also adding features into our products, right? So securing the communications to PLCs, adding multi-factor authentication, which is, you know, something we typically don't see that in industrial control systems, but it, you know, we've had that capability in our PLCs, you know, to enable that in our PLCs. Excuse me. Things like checking checksums and signatures, and providing user-specific access and defining access control rights to those users. All those things kind of add up and create that multi-layer defense in depth strategy that we talk about just within the control cabinet itself, right? Just within the PLC itself. And then when you add things on top of that, like network security, network segmentation, and securing that network, and demilitarized zones, you've got this great big, I call it the onion, you know, these different layers of protection that at the core is, you know, the most critical piece of your process or your PLC code or whatever, you know, you're trying to protect. That's at the core of everything. And you're just kind of building up these layers by adding and using all these different features and functions.
Yeah, and just to delve in a little bit more technically, in the PLCs themselves, we can implement a firewall, so a stateful inspection firewall directly in the PLCs. We have VPN capabilities in the PLCs, and as Louis mentioned, we have multiple users for different functions in the controller. We have encryption, we have TLS communications, we have the ability to dynamically, as the program runs, to check verify the checksum of the program that it hasn't been modified. We can disable unused ports. We can do syslog, generate syslog messages directly from the controller in our diagnostic buffer. There's security classification, so you can actually generate a security log directly out of one of our PLCs. So just a wealth of functionality that's there. For collateral purposes, we have a white paper for that. And for even the older products like the S7-300 and 400, we have a spreadsheet that we can provide that shows you how to implement several security features inside those older products. So, and all that collateral is available for anyone that wants it.
Hey, one thing I forgot to mention also, just as a general practice for securing PLCs, ISA just released about a year ago, maybe more than that. I lost track of time this past couple years. The top 20 secure coding practices. So if you haven't heard of it, I highly encourage anybody to take a look at it. And it talks about certain ways to securely program different functions or different common functions within control systems, within the PLC logic. Just things like that. Also implementing those types of strategies into your PLC also can go a long way into verifying or protecting your system.
All right, thank you, Louis. And that sort of leads me to the next question, because we talked about vulnerabilities, right? We talk about the people are more aware, it's coming up. There's also such thing as published vulnerabilities. There's a lot of manufacturers publish them, including Siemens. There's a list of published vulnerabilities in ICS equipment that also includes our own products, Siemens products. So there's that information. What does an owner-operator do with it? How do they consider that information when they're designing a new system, new industrial control system? Perhaps, Kyle, if you want to start us off with this one. I know it's kind of in your court.
It's a really broad topic, so Chuck, back me up here. All right, so the topic of vulnerabilities is really near and dear to my heart because of where I sit in the organization. I've helped write some of those vulnerabilities that get published through our Siemens security advisories and also get sent out through groups like ICS CERT here in the US. And it's a really tricky subject because anytime you talk about a vulnerability, you're talking about what's essentially a bug in a program. And everybody has bugs. I'm sure that Siemens has its fair share of bugs. We release hot fixes and updates. We work to make sure that our products are continuously improving. Every vendor does the same thing. The only difference is some vendors have a more mature process for disclosing those. So we try to be very forthright and very open with our customers about what's going on with our systems. And that's why we publish all these vulnerabilities. Now, what an owner-operator does with that information can vary because it depends on the maturity of the cybersecurity process that you have in place. Some people take the position of just ignoring them and saying there's nothing that we can do about it. The machine is running. It's been running for 5 years. We don't have the resources to fix it. And they'll say the vulnerabilities come out, but we've got defense in depth around it, like Louis was talking about, that big onion. Other customers have a much more aggressive approach to it, and they want to patch everything as soon as possible whenever these vulnerabilities are disclosed. And we try to provide avenues for people to act on, either one of those options. Whenever we write a Siemens security advisory, we try to give direct mitigations. Maybe that's a firmware update. We also try to give workarounds. So if you're not able to update firmware or software, there are things that you can do to modify the environment that the asset sits in to help secure it. That's only the broadest approach to answering that question. Folks on the panel, have I missed something?
I don't know that you missed anything. Whoops, I've been muted, so I need to unmute.
Nope, you're with us.
Okay, there we go. So yeah, I don't know if you missed anything. I would just, I would say, the important thing to realize is that those vulnerability reports are available, right? Publicly available, not just for Siemens, for everybody in the industrial control system space. ICS CERT at the CISA federal level makes those available in a database that you can search and actually subscribe to. Siemens has the product cert website where you can also subscribe to receive specific alerts for a range of types of equipment. So doing that is important. Of course, that goes back to having a full and complete inventory of your system to make sure you know what you have. And that includes not just the type of device, it's a switch, the manufacturer, okay, Siemens, model number, so that when you get those vulnerability reports, you can look and say, okay, I do have that model number. Oh, and you also have to know the firmware, right? Because almost all the vulnerability reports list a specific firmware version that the problem is in, or versions, and then also the firmware version that you may need to load to mitigate that problem, that vulnerability. So having that inventory, up to date and on hand is critical to be able to figure out, hey, does that affect me? And then the other thing is to spend a little bit of time understanding how these vulnerability reports are written. There's a score, a CVE score that's part of almost every vulnerability report you're going to see out there, definitely in Siemens and in the ICS CERT database. These scores are there, and it may, it goes 0 to 10, and if there's a 9.5 out there, that sounds bad. But if you understand and read the report and understand what's required to implement that that vulnerability, maybe the bad guy has to be on the network already and have a view into the network or capability to be there. Maybe he has to have a physical presence. Some of the vulnerabilities actually require a physical presence at the device. So based on your situation and how many other controls you have in place, how good is your physical security, those kind of things, you may be able to discount that vulnerability and say, that's not as important as this, 8.0 over here, where they can do it all over the web. And oh, by the way, we still have our web interface open so that our controls engineers can get in and use it. Not a great idea these days. There's other ways to do that, but that's the kind of process you need to go through, right? Yes, the vulnerability reports are important and we need to look at them, but we need to understand how they affect our specific case, right?
So one more tidbit of information on that one. The Siemens product cert is going to have more information than you have with ICS cert. We've had that discussion with customers before. They would see kind of the synopsis of the vulnerability on the ICS cert, but they didn't know exactly what to do for it. And as Chuck said, if you go to Siemens product cert, it's going to have a little bit more detail there. And then we also have the ability from the Siemens product cert that if you can generate a tool that will download those vulnerabilities so that they can be processed in an automated fashion. And we also have some tools like the Somatic Automation tool that you can write your own API. They will go out and interrogate the Siemens equipment in your facility using the Profinet DCP capability. And then you can write a tool that would process those downloaded vulnerabilities so that you could look at the vulnerabilities and remediations for your site in an automated manner. So that's some tool development for it, but that might save you a lot of time in the future if you spend a little bit of development time up front.
That's a good point, Wayne. And since you're mentioning, the Siemens tool, and Kyle, you had a good point about, it depends how mature your system is. And Chuck, you mentioned knowing your inventory. So all of that together, perhaps you guys can use this opportunity to also, in a way, reassure the audience or explain a little further what do Siemens do in order to ensure that our products are manufactured, developed, and maintained securely? And could be, Chuck and Kyle, if you guys want to take that one, and Wayne, perhaps you can jump in.
Sure. So our viewers and listeners may have heard of this thing called Stuxnet, right? 2009 timeframe, we became aware that our security was not very good typically in the industrial control system space, right? We had relied on air gapping and just the fact that our systems didn't talk that much to other systems, that they weren't on the same type of Ethernet networks. But over time, that changed, especially in the early 2000s and all the way up to now. And so, we became more vulnerable to standard kind of what we used to consider IT type attacks. Well, now we're using IT type technology, so we're vulnerable to those same attacks. But because Siemens was actually involved in that Stuxnet issue, it was our equipment that was being used and was attacked. That's really led us to be very cognizant and at the forefront of security for the last 12, 13 years. When you get attacked by two of the biggest, baddest security organizations in the world, it's I don't know that anybody would have survived that. But it also goes to show that even at that time, we had passwords and other things built into our systems that would have resisted more if they had been in use, but they just weren't in use. And so that goes back to, I think Kyle said this earlier, or maybe it was Wayne, but that just using things that are in the PLC already, available, passwords, VPNs, protecting the system around, putting those layers of protection also around the system. There's lots of things that we can do to make things safer. Now, Siemens, and I'll pass it on to Kyle for more details here, but we've been heavily involved in the standards organizations, right? And we are across the board. It's not just on the cyber side, it's all across automation and all kinds of different, things from NEMA to ICS cert, or to the IEC standards for cybersecurity. So, when the IEC 62443 Category 4 standards came out about 3 years ago, we jumped on that, right? We've been actually involved in helping write those to some extent, but we think that's important. So Category 4 applies to OEMs of electronic equipment, right? Network attached equipment such as PLCs, switches, drives, all those things. And so the first part of Category 4, 4-1, is a standard around how does an OEM like Siemens create a secure product development life cycle? So how do we make sure that as we're designing a product, security is built in from the beginning? How do we make sure that then as we're supporting that product over the years and we issue these firmware updates, how do you know that that firmware update is the correct one and secure? So we provide on our website things like a hash, a SHA-256, which is just a cryptographic way of guaranteeing that the file you download is the one that we uploaded there, right? And it hasn't been changed by somebody. So there's things like that built into our product development lifecycle to make sure that over time that product continues to be supported in a secure manner. And then 4-2 is all about how do we certify against a specific set of, kind of almost minimum requirements that IEC says we ought to have built into our products. So, but Kyle's group really looks at, okay, how do we work with our product managers to make sure that's happening from the beginning and over time, right? So Kyle, let you say more words.
Chuck, you set it up really beautifully. So my group within Siemens sits in an R&D center, and we work with product development. We also work with our factories. So my group came about in the aftermath of Stuxnet. As security researchers picked up our products, and we had to start responding to the community and make improvements. And what happened over time was that we got really good at it, and we codified all of that knowledge into a process to develop products, right? If you think about it in terms of fail-safe development, like functional safety, it would be systematic capability. What we're looking at doing is we're developing the systematic capability within the organization to improve cybersecurity. And that lends itself really, really well to compliance, right? So IEC 62443-4-1 that Chuck mentioned applies to our R&D centers and to our factories. And we are subject to audit from external partners. I believe we go with TUV SID. And that means that we have to stay honest to ourselves, to our customers, and that's the key part of assuring supply chain security, right? Whenever you buy a product from Siemens, you know that that secure development lifecycle is in place because of all of those compliance and regulatory requirements. We're very proud of that. And then 62443-4-2 takes it a step further. Now that you've got this secure development lifecycle in place, you're delivering secure updates, you're making sure that you're developing things securely, let's put those key features in there to make sure that they're used securely. And that's where we're having an ongoing conversation with a lot of our customers, because the fundamental disconnect, industrial cybersecurity, is that whenever we deliver an industrial control system, customers typically expect that that control system lasts for the life cycle of the product. You know, whenever that box goes in there, it's going to last until the metal wears out. In cybersecurity, you expect the latest and greatest features, right? You expect state-of-the-art cybersecurity because whatever happened 7 years ago may have been broken already. And that's a disconnect in our world where we have the latest and greatest features, but we have to support for the life cycle of an installed machine. And that's where we're working with customers right now, especially with 62443-4-2, to make sure that the right features are in place to keep a system secure over its whole life cycle, and that we are able to support that into the future. And now I get to say it. Natalia, you're muted.
Thank you. For the what I was going to say, for those that are tuning in late, because I could see that some people started logging in a little later, we are answering some of the questions in the chat. We're taking some on the air. It's a back and forth, so do check the chat. Some of the links that were asked for on the chat, such as top 20 security coding practices for PLCs, we've posted just in the chat, so we're not going to take it on air. And with that, I will actually like to bring another question from the question panel. And the question comes from VM, and he or she is asking us, so you have to choose sometimes, right? What do you prioritize? Intrusion prevention or logging solutions?
Yeah, so that's a great question, and I'm gonna maybe not answer it in a way that they'll find helpful right up front, but I think it is the right way to answer it, right? So we are big proponents at Siemens of making sure that you have an OT cybersecurity program, right? An operational technology, not, you know, it might be part of IT, but there needs to have people that are dedicated to the OT world and understand all the additional requirements and differences between IT and OT, right? There's all kinds of differences from the way we generate the data, the way we use the data, how long we store it, what type of data even it is, you know, whether it's real time or something that may be, you know, stored for a long time. And so because of all those differences, we really think that you ought to have an OT specific cybersecurity program. And then out of that program, you will be looking at where you are now compared to some kind of standard that you adopt and internal policies based on your own market and risk structure, right, as a company. And then once you figure out where you are and where you want to be, then driving the organization from where you are to that you know, next destination. It's probably not the end destination, but the next one on the roadmap, so to speak, is a part of that program's responsibility. So I like to explain it in the same way as safety, right? If a lot of us have been around for 20, 30 years, you can see the gray. And you know, back in the 90s, we started really thinking about safety more. And so we would install a guard on a machine or a safety PLC, or we'd do an audit of the line and try to find all the safety issues with the line. And each time we did something like that, we did make it safer, right? But if we didn't have a way to make sure we came back and checked on that in 6 months or 12 months and made sure we looked again, making sure we looked for the bigger risks and solved those first. You know, we have limited amount of money and people and time, but so look for the riskiest things and fix those. That was how we did safety, but we figured out, hey, we need a safety program in place, right? We need dedicated people and resources so that we can do this on a regular basis, and everybody knows what responsibility is whose. So that's the same thing for OT cybersecurity. We need that continuous improvement mindset and a program in place to maintain that over time. So that's where we would come and say, hey, based on our current setup in our system, is a SIM more important than intrusion detection? And I'll tell you my opinion in general. Most of the time, it's easier to implement a SIM than it is to implement an IDS, and that's because the IDS requires a lot of tuning to make sure you're not getting a lot of false positives. Somebody has to be looking at those alerts that system's throwing off all the time. So it takes extra personnel and resources to maintain an intrusion detection system than it does a typical SIM. So that might be the answer there. Typically you might get to a SIM first in your maturity journey than you would an intrusion detection system.
Wayne, anything to add, or?
I guess just to throw in some plugs for the intrusion detection systems. One of the things that I like about those is they do deep packet inspections, and there's a couple on the market that provide some nice features. They have some machine learning and artificial intelligence algorithms to detect attacks. They are what we call OT aware of protocols, so they recognize BACnet, Modbus, TCP, and can interrogate at those packet levels. So they'll do some. They have the artificial intelligence algorithms to detect anomalies. They also provide signature-based analysis at the same time. So they provide some malware detection. So I think they are good solutions, and we, as I mentioned earlier, we do have some of those that run directly in some of the Siemens networking hardware. And so they are a good solution. But to Kyle's point, if you're doing some automatic not actioning Chuck's point, you do have to tune those appropriately and set up your rule sets properly. But they are good for protection of the facility. And we have some customers that will marry those with the automation with our Cyber Protect solution, and we have some customers that just take it into a logging system as well. So we have solutions in both cases. So that's my viewpoint on it in my last experience over the past several months.
Yep, absolutely agree. Oh, you're muted again, Natalia.
I was gonna start saying that we're running out of time, so I was only gonna take one more question, if that's all right with you, gents. And while we have still Wayne talking here, I wanted to come back to something that we sort of started talking about at the beginning of this panel. As you may remember, we had a question coming from MB regarding, what about a smaller guys? What about if it's not a large manufacturer? So in that case, I want to bring a question is, are there some activities that owners, operators, especially those in smaller and medium enterprises, can consider paying for or subcontracting? And if so, is it worth it? What's the risks?
So I'll jump in here real quick. We're aware of this. We've seen facilities like small water treatment plants that seem to get hacked regularly. Small airports, for instance, they don't have the IT infrastructure or the security personnel for it. So we've created some solutions that we believe are applicable for smaller facilities like that. As our Cyber Protect, we call it Cyber Protect Lite. So designed for a facility that don't have a lot of personnel. It's got the security monitoring in it, the intrusion detection and threat monitoring, and it's got the automatic response. So we tie the threat detection with our controllers and they will take automatic action. They'll warn the site with lights and horns. They'll integrate with our Scalance products to automatically protect with dynamically changing the firewall, like we mentioned earlier. So those small facilities, we try to put that into a, I guess for lack of a better term, a Siemens box that will implement a lot of those security capabilities for you. So we've taken that approach from a product standpoint.
Yeah, and then the flip side of that is, you know, for small and medium-sized companies, it is really difficult to, you know, get the resources to put together a dedicated OT cyber team that's going to be on call 24/7, 365, right? And so there are other, you know, options out there, right? We talked about, Wayne just talked about some products and really solutions that Siemens has to help folks be able to monitor more and more deeply with a limited staff. But then there's also services, right, that we can bring to bear to help, right? So we can help with design, we can help with you know, OT cybersecurity program development and implementation, change management. We can, you know, through our customer service organization, we can help with that whole patching issue. You know, how do you have enough people to get all those patches installed over time? And then, you know, we can help with the whole design of a cybersecurity system, including the network, including the PLC systems. And then we have a whole set of solution partners out there too, that have various different skills, right? We have some that are very cyber focused and can help with those very cyber specific tasks. And then we have others that are, you know, the typical Siemens automation folks that are coming up to speed quickly. We're encouraging them, and most of them are listening to come up to speed on the whole cybersecurity subject, right? But if your local integrator or folks that you're using now aren't, you know, really where you want them to be, then let us know. We can bring somebody in to help, not necessarily to take over, but to help on that cyber aspect.
Indeed. Thank you, Chuck. At this point, unfortunately, we are running out of our time, so I'm going to finish the session here, but welcome everybody to the Q&A that we will continue right after this panel. Thank you.
And because we do not want to make you wait, here we are back in the studio with a Q&A.
Yeah, there you go.
We have Kyle and Chuck with us here remotely, just as they were for the session, and Louis in flesh and blood with me on the stage. So thank you for joining, and thank you for staying with us throughout the day today. It really has been a pleasure to engage all of your questions, all of your participation in polls. It makes it better. And without any further ado, let me jump straight to questions that we have started receiving as the session was coming to an end. And I'm going to start with the first question that came from Kim, and I'm going to say that Kim has been submitting questions in the morning, so I know it's a repeat customer, if I may. So thanks for staying with us throughout the day. And her question is, are there any documents that speak to implementing PLC cyber protection?
Yeah, I'll go ahead and take that. Yeah, so I mean, we talked a little bit about this during the panel discussion. There's a number of resources that people can go to. It really kind of depends on where you are, what controllers. I mean, if we're talking about Siemens specific, there is a white paper for protecting automation systems. I guess we can provide the link afterwards. And then there's also a similar document on our industry online support site that you can look up. Same context, and it actually goes a little bit further and talks about protecting like the HMI system as well. So not just the PLCs, but just the automation system as a whole. And then one other thing that I think that's available, and it's a little bit more open source and kind of PLC brand agnostic, is this is if you heard of it, is called the top 20 secure coding practices.
That's right.
Yeah. So so it's a way to implement secure PLC logic in your PLC that's a little bit more secure, to not always necessarily protect against cyber attacks, but help detect cyber attacks or help detect some of the effects from a potential cyber attack. And
And some of it is protection measures as well. So take a look at that. And if you're not familiar with it, I'd recommend the top 20 secure coding practices and as a starting point.
It's definitely a great resource. Thank you.
Yeah, no.
Anything to add or?
Kyle?
Just would like to say, the whole set of standards out there too, right? That are OT specific, right? The IEC 62443 and the NIST 800-82 were written specifically for control systems. So those are also a good resource.
That's a good point. The next question, I feel like gentlemen here on the screen might start us off on, and the question is the following. How should a factory behave when an unusual cyber activity is detected on the network? And Kyle has that smile on his face because he knew I was going to send that his way.
Oh, I thought you were going to give it to Chuck, but I'm happy to take a first crack at it. So the issue of incident response really comes down to the factory itself. Whenever we think about responding to a cyber incident, it kind of falls in the same category as incident response and a lot of other business continuity conditions, right? So whether you've got a natural disaster or you have a labor shortfall, the cyber incidents kind of fall within that same grouping. And so a small, discrete manufacturer will have a much different response than maybe a process industry's customer, who maybe have a different response than a defense industry contractor. So if you think about what you're going to do when there's unusual cyber activity, it's first continuity of business. The second thing is to make sure that you take care of your customers, and then make sure that you're putting yourself in a good position to recover. Now, of course, all of that goes with the assumption that you're actually monitoring your OT network to determine if there is suspicious cyber activity. Chuck?
Well, so I would add, I guess, that that's one of the things that I think we are very weak on in the industrial control system OT cyber community is the whole what do we do if it happens? Because we spend a ton of time on the what do we do to prevent it and make sure that it doesn't happen. But as we've seen lately, I think, and I don't know anybody in the community that would say that you can be 100% protected, right? So you have to really think about this in advance, right? You gotta have that OT cybersecurity program in place with plans of what are you going to do? Who you going to call, right? Those Ghostbusters thing. But the plant, every operator up to management should know that, right? Who are you going to call? Who are the people that are going to address it initially? And there should be a playbook, right? If we got ransomware, what do we do? How do we try to isolate it as quickly as possible? How do we make sure that we can recover? And you should be practicing those plans, right? Too. If you don't exercise them, then you're not going to find the big hole that nobody thought of, but is right there in the middle of your plan, and you fall in. When you're in the middle of an incident response.
Yeah. So I'll add to that. I think the short answer is really there's no one size fits all, right? It really depends on your process, on your plant, what's going on, what type of incident are we talking about? Is this like a full-on ransomware type of attack? Is this just an intrusion? Is this just, what's going on? And like Chuck said, I think part of that is figuring out, what's critical, how to figure out where all those pieces are, the order of operations, basically, figure out who to call, and then keeping that plan in place and practicing it or constantly updating it, reviewing it, making sure that it's still applicable. So I wish it was simpler than that, that we could give a one size fits all, but unfortunately it's a little bit more complicated than that, right?
It's not one size fits all, but
it's like asking somebody, what do you do if your plant burns down?
Simple.
So, go ahead, Kyle.
Maybe it is that simple. Maybe the guidance to give, how should a factory behave when unusual cyber activity is detected?
Yeah,
is to do that groundwork first. Make your plans, meet all of your friends, know who you're going to call, and then implement a solution where you can actually monitor for that activity. And then the response becomes clear for you.
Yep, absolutely.
So plan the dive the plan. That's where we leave it at.
I think so.
With that, I actually have a question that came in. Well, just a second ago. So we're going to go back to this topic because it makes sense if we continue the same conversation. And Bob here is asking, well, is there a division that needs to be called if or contacted if you know you're being hacked? Is it required?
Yeah, I mean, I have a little bit I can start off with, and then I'll let you guys jump in because I know you guys are really passionate about this subject too. We actually all just attended a conference on ICS cybersecurity recently, and there was a lot of great discussions and initiatives and programs around one, incident command around ICS, around industrial control systems, kind of standardize on that piece, but also standardizing on the practice of reporting cyber incidents, right? And so I think historically it's been a little bit like, you know, and I'm speaking out of like my area of not expertise, but experience, I guess. But my understanding is it's always been historically a little bit of factories or owners, operators a little bit hesitant to report a cyber attack or cyber incident, right? Because then there's media involved, there's a lot of press and a lot of exposure or a lot of panic. And I think part of that goes to the fact of, like Chuck mentioned, is maybe not having that plan in place. One organization that I think has kind of established themselves as like that single point of contact is CISA, CISA, if you're in the US. Not sure what that would be for maybe if you're out of the country, maybe your local government has a similar organization like that. But for the United States, CISA is an organization that's working together with other federal government agencies to help combat cyber attacks, as well as create plans around protecting our critical infrastructure and other areas of our country. So, Kyle, Chuck, I mean, chime in on this too as well.
Well, I'll take it. Looks like Kyle's not going to jump on this one, but so I would say, you know, going back again to what we said just a minute ago, the plan is so important here, right? Different companies going to respond in different ways. They have different requirements to respond, right? There are some industries that are required to report. You know, we have different legal ramifications, right? We have the ramifications around, you know, if you're a bulk power producer, you know, and distribution company, then you answer to FERC, part of the federal government, and you get fined if you don't follow those rules, right? Yep. So there's that. If you're a water treatment facility, you respond to or you're responsible to the EPA, and they have new rules around reporting. Now, they're not requiring cyber reporting right now. They're highly encouraging it, but it probably is going to become a requirement before long, just like it is in the power side. So there's various actual legal requirements out there too. So you need to know what those are and understand what your responsibilities are. And again, that needs to be part of your plan.
I think one thing I wanted to point out too is the importance of reporting this is I mean, it sounds kind of cliche a little bit, but it's kind of for the greater good, right? It's we all learn from these
jointly
unfortunate, you know, events, but you're protecting the next potential victim from going through something similar, and you know, therefore furthering the agenda of whoever the malicious attacker or whatever is in the first place. So,
indeed. So you mentioned requirements there, Chuck, and we had a slightly different question that came in here, and that is, well, in that case, do you recommend that owners or operators put cybersecurity requirements in a procurement contract? Would you recommend that?
Yeah, I would. I mean, it's just like specifying.
There you are. Back.
No, you're Ryan. You're back.
You're good.
Okay, must be a connection thing. Yeah, I mean, specifying in the contract exactly what your requirements are for any type of cybersecurity requirement is critical these days. because, you know, it's just like any other part of a control system. You need to have the requirement there. You need to have a test plan in place so that you know that it was actually, you know, implemented correctly. And then that also gives you a way to go back and test periodically over time to see if it's still working, right? We've been many places where there's a firewall installed between IT and OT, and I'm sure it was installed, you know, well, I hope it was installed correctly to start with. But over time, they may have put, you know, additional firewall rules in there that open it up widely, and now it's really not doing what it was intended to do. So that's another issue, is making sure you go back and have that periodic check, continuous improvement process in place to make sure that what you did, you know, 2 or 3 years ago is still applicable and still operating correctly.
All right, thank you so much.
I guess,
Kyle?
do I have enough time for 1 minute?
Yeah.
You can add
I would
to this, yes. we'll probably have to close it after that.
Okay, excellent. I would just add that whenever we talk about contractual language and cybersecurity specifically, we're trying to control lots of different types of risk in these contracts. So like Chuck was talking about, there's, you know, the down on the ground cybersecurity reality. And a lot of times that comes to us in the form of RFPs or specification documents that come from our customers about what actually gets installed on their site. But there's another kind of risk. How do companies work together? And those are typically trying to be controlled inside contracts. And we get these cybersecurity addendums. We talked about a duty to disclose or a duty to report. And sometimes we have a contractual obligation as a vendor to report cybersecurity incidents to our customers to inform them of their own risk. And that's not unique to Siemens. That's happening throughout the industry. If you're selling into automotive, if you're manufacturing parts, if you have a problem, you need to report that to your customer. And then finally,
I think
Kyle dropped out a little bit.
he dropped out a little bit, but I think we do understand the point there. And then there are contractual obligations. Sometimes you have to inform. And at the end of the day, like Louis said, remember, the greater good.
Yeah.
At this point, we are at 4 o'clock, so I will not be taking any more questions live for you guys. Thank you so much for being here and speaking to our audience and addressing these questions, because I would like to invite you to join our last session of the day where we're going to talk about how Siemens cooperates with education. You might remember from our keynote earlier today about the next generation workforce. Well, in this session, you'll learn how we partake in being a solution to that growing problem.
Hello, thank you for joining today. My name is Amanda Beaton, and I manage a program called Siemens Cooperates with Education in the U.S. I'm going to take about 20 minutes to talk about how we work with schools and talk about some best practices and some success stories, and then how you can get more involved and help. So we started talking years ago about baby boomers leaving the workforce and 10,000 people per day retiring and someone turning 65 every 8 minutes. But of course, over the last couple of years, this stress and this issue has become a lot worse. There's such a demand for technical talent and digital skills and digital maturity. And about 80% of CEOs, when surveyed by experts like Deloitte and the National Association of Manufacturing, said that they were having trouble finding and retaining this type of digital or skilled talent. And about 50% of CEOs and managers surveyed said that they were turning down work because of the talent shortage. So we know it's a huge issue. I thought this was a relevant quote given our current economic times from Warren Buffett. And it says, skills, unlike currency, are inflation-proof. So if you have a skill that's in demand, it remains in demand. And it can't be taken away from you, and it can't be inflated away. So I think it was just a really nice statement, a really nice quote to talk about investing in yourself, investing in training, investing in technical skills, because it isn't affected by certain economic times, particularly of today. So from a broad, holistic level in the US, looking at Siemens' work with schools, we start at the K-12 or kindergarten through 12th grade level, working with middle schoolers, high schoolers, particularly because research shows that the passion or the interest in technical and STEM careers starts at about middle school. So Siemens sponsors lots of robotics competitions, skills competitions, brings lots of students, for example, in Manufacturing in America, our event in Detroit, lots of students get the chance to take tours of the showcase and get hands-on experience with products, get to network with manufacturing professionals. So a lot of involvement, a lot of investment goes into that K-12 space from Siemens US level. If we move over to apprenticeships and workforce development, of course, Siemens is a German company. So our roots go into that style of hands-on learning and training. And similarly, we've invested quite a bit in the US in our own types of training programs, but also with key community college partners for apprenticeships and workforce development to bring those products directly into labs and classrooms and training environments for that type of hands-on training. Next, where a lot of our work in factory automation is done, at the 2- and 4-year college space. So we touch tens of thousands of students with our hardware and software technologies, and at least 500 schools in the US every year with factory automation products. And that's taking the very same products you would see in a global manufacturing environment in a classroom and lab in a college course. So remember, that is specifically where the SCE, the Siemens Cooperates with Education program, does a lot of its work and spends most of its time. And finally, and a little bit different, the Siemens Foundation is, of course, the nonprofit arm of Siemens. So the work is a little bit different and focused on what they call the STEM and middle skill initiative. So over $100 million has been invested to date in sort of raising the awareness of STEM and middle skilled careers, changing the perception of manufacturing jobs for middle schoolers, high schoolers, and particularly parents whose perception of manufacturing jobs aren't always correct and up to date. And then to find what works in schools and to scale those effective training models so that we can grow the great work that we're doing across the US and do more of it. So if you look at our digital industries portfolio, just at a glance, starting with software and lots of software tools and simulation tools, into factory automation hardware and software, motion control, machine tool, the automation, process automation space, and of course, services and training. It can be a pretty complex portfolio, particularly for an educator to grasp, right? So, excuse me, so the work of our academic teams is very focused on bringing these products, these specific technologies, into the hands of educators and into students' hands so that it's easier to understand these really complex technologies. So whether it's complex software and simulation tools or hardware and programming devices, our work as an academic team is to bring these in the form of curriculum, product packages, credentials and certifications, training for educators, and bring all that into the classroom. Specifically how it's done in the SCE program, very tactically, is the same as we've done it for several years. So we have curriculum, packages of hardware and software in the form of trainer packages that match that curriculum. And it's built based upon what industry is looking for. So what kind of student outcomes, what types of skills that industry wants students to graduate with. We also offer workshops for teachers, for educators, for really anyone in the education space. That's always free. So teachers can come to an online training or a hands-on in-person training and always better equip themselves with our technologies. And finally, support, whether it's in the form of a local Siemens person or a global technical support expert or just a network of educators teaching the products, teaching these sort of technologies already. That's the value that the SCE program brings to education. So you're taking these job-driven competencies that industry is looking for, bringing them into students' hands, and then offering educators a part of being this global network where they can best practice share and talk about what works and how to teach and bring more value to students. So here's a quick map just to give you a view of where the typical SCE schools are. It's a dynamic map. It's always changing and growing. But again, we spend most of our time with technical colleges in the 2-year space, universities, which is actually growing as well, as more engineering schools bring these products into their programs. There are lots of workforce development and high schools that also use the products, of course, and anything from union training shops to county career training centers, but really a whole lot of different education environments utilize our products. Again, it's instructor training, curriculum support, technical support, and the whole goal is to elevate the technical expertise, the digital talent, and the digital maturity of not only the future workforce, but the current workforce. So again, we talk to our industrial customers about this virtual world of simulation and design and software, and the physical world of production, how they converge and how they overlap. And think about looking at that as an educator who may not have a technical or industrial background, who may not have a programming background, and it can be pretty overwhelming, especially coming from a company as big as Siemens. So that's why we have an academic team and we have these levers of support that bring these technologies into educators' hands, offer training, offer curriculum, projects, downloads, and tools to help bring it directly into classrooms. So my favorite part is to talk about successes and best practices, but I only have a few minutes, so I'll only touch on a few highlights and a few different types of stories from around the country. Starting with Motlow State in Tennessee, this is a cool story, unique story, because they have done a lot of work to start recruiting through outreach programs, middle school camps, and summer activities at the middle school level to bring more diversity into their engineering, technology, and technical programs. So they specifically have a goal of doubling their female population in their engineering technology programs. So they started about 10%, their goal is 20% of females in engineering technology, which I think is a super cool effort, and they've done a great job of that so far. Moving to Western Nevada College in a different part of the country, they have an accelerated mechatronics certification program. It's a 4-month program, and it's cool because it's in kind of a rural part of Nevada, but they've equipped obviously a van or a trailer to travel around the rural parts of the country and teach folks who may not be able to come to a traditional campus. But they have some fantastic success stories from that accelerated program as well. Next, Clemson University, you may not know, exposes about 250 mechanical engineering students each year to factory automation basics, the basics of manufacturing and technology. The cool part is students in certain automotive engineering courses as well get to go to their CUI-CAR, their Clemson University International Center for Automotive Research, and spend the last 2 years of their engineering program alongside Greenville Tech students working in this hands-on environment with lots of different access to robotics and automation technologies. So very cool opportunity for those students at Clemson. And finally, Think Academy right here in Georgia is near a Kia plant and has really done a fantastic job, again, offering a mechatronics program, but at a high school level. So high school students are graduating with years of experience already in programming and both electrical and mechanical skills. And you can see in the picture they're already working at a Kia plant and doing lots of cool programming activities. I think. Next, University of Toledo in Ohio. I mentioned this because they've done a very neat job, some of the instructors there, of building modular curriculum and their own projects based on very low-cost products assembled in lab kits. So they wanted to teach some pretty complex PID and servo concepts to students, but a lot of high schools and community colleges around them couldn't afford the hardware. So they built projects that you can download and use for free, a YouTube series that you can follow at hybridplc.org, and then give hardware suggestions for very specific things you can buy, and also accessories you can buy that are very, very affordable for teaching these concepts. So it's very neat. Manchester Community College in New Hampshire is in a rural part of the state, and it's cool. It's kind of a funny story because here you can see they've built hardware workstations for learning and things like PLCs and our logo products. But then because of COVID, everything went to remote learning. So in the second picture here for Manchester, you can see they very quickly set up cameras and with no budget so that students could actually remote connect in and network in and download their programs so they could physically see what's going on with the hardware when they were working at home and not allowed on campus. So with absolutely no budget and very little time, they were able to quickly adapt and still do some programming exercises and kind of experience what was exactly happening with the hardware on campus. Arizona State, we've mentioned before because last year they started a senior designer capstone project. But the cool part is this year's capstone student teams built upon the knowledge learned and demonstrated by last year's team. So this year they were able to build some workstations, both designing in software and physically building and assembling them to train the manufacturing community around them. So they also saw the talent shortage issue and are working together with industry around them to do some manufacturing training for workforce development training from ASU. And finally, my last story is KTech. It's one of my favorite. KTech is in Madison, Alabama. It's from an organization called Kids to Love. KTech is short for that. But they take non-traditional students who are coming out of some, for example, aging out of foster care, certain veterans, but different programs, sort of a non-traditional path, and they offer scholarships and accelerated programs in programs like mechatronics. And a couple of stories to mention, the young woman on the left, her name is Kayla, and she got the opportunity, was interested in automotive, became interested in the mechatronics program, completed the 4-month program, and was offered an internship at Mazda in Alabama. And instead of a 12-month internship or probationary period, she was hired full-time in 3 months and is the only female maintenance engineer there to date. And the next story, the young man, he didn't really have a career path and had finished an addiction center rehabilitation program and entered the mechatronics program there and was offered a job at Mazda. And the cool quote from him was, he didn't just find a job, but he found a career and he found a path in life. So a really kind of heartwarming, touching story from that facility. So we talk a lot and we have tons of stories of hardware and software and things like PLCs being used in labs, right? But we're not just talking about pieces of hardware anymore. We're really talking about a digital enterprise story. We're talking about IoT. We have projects that mention language around edge, artificial intelligence, IoT, digital twin. All these projects are being introduced to students now. So think about students getting exposure to this type of technology while still in school. And also think about your local school, whether it's a high school, college, workforce development training center, having a realistic future factory or lab with this type of products or this type of technology for customers or visitors or parents or potential students to take a tour through. It's actually some really cool stuff that we're introducing to lots and lots of schools now around the country. So finally, how can you get more involved and how can you benefit or help schools around you? Well, one of the biggest obstacles we face is there are so many schools, so many teachers in the country, and very few of them know about these levers of support, these benefits, the discounts, the free training, the free credentials, all these free things and discounted things offered from our educational programs. So we always need help in communicating things like upcoming events, workshops, training opportunities, where to find curriculum and hardware packages. So always a benefit to be able to communicate that, or to find schools actively using Siemens, or maybe to find schools not using Siemens without technologies, without products, and to introduce this type of program into those schools. Next, you can visit a school. You can leave your house. Be crazy. The middle pictures are from Kennesaw State University, which is not too far away from us here in Atlanta. And you can see they obviously have a mechatronics line, they have a digital twin version of that mechatronics line, and some very cool tools there at Kennesaw State University. Similarly, I sit on the advisory board, another way to get involved at Kennesaw State. But lots of schools have industry advisory boards, technical advisory boards, senior design mentors, but lots of different opportunities where they need technical experts, industry experts, people with experience to mentor, to give advice, to talk about what they offer in their programs and general student outcomes. So it's a very cool opportunity. We've talked about it once before, but you can see the companies involved in these types of industry advisory board meetings and what a great networking opportunity it is not just for the academic networking, but for the other company networking as well. So a very cool opportunity to get involved, but also to make a difference. So I would love for you to get more involved, to ask questions, and to contact me about how to take some next steps. Thank you.
All right. Thank you, Amanda. That was really great. Great insights. Thanks a lot. And thanks to everyone for staying on, joining us also for this last session. We got a couple of questions, and let's start with the first one. How would I find students, recent grads to hire? Where can I look if I need somebody from my company?
Right, I do get that question a lot. So a few different ways. I think the easiest way is to, we have what we call a partner school finder or school locator on the SCE homepage. So we can guide you to that homepage, and you can use that to find specific school locations that are close to you. And within that school location, the information is there for the program name, the program type, and an actual person you can contact at that school. We've got a few different places, but certainly the SCE homepage and the partner school finder would be the easiest way to find a school and a program and a kind of an instructor coordinator name. There's another way. We have a LinkedIn group that we're starting to populate it with instructors and students who have completed some sort of Siemens training or credential. So you can also look through the LinkedIn page to find certain students and instructor contacts there as well.
All right, great. Thank you. Also, what do I do if there's no school in my area and I can't find the right one? Is there a link also with information that I could share with a school to start a program, get engaged, work with Siemens?
Yes, of course. I mean, there are lots of information, there are lots of case studies and PowerPoints, PDFs, one-pagers, and kind of quick start guides on the SE homepage as well. That's kind of the first recommendation for them to start with is go through and you can share information. But we also have lots of events posted on the website for upcoming workshops, training dates, things that teachers can be a part of for free training and earning free credentials too. So I would invite instructors to participate in that and for teachers to attend the upcoming events and workshops and educational sessions for them. But yeah, lots of resources posted there that would be easy to share. Or somebody like me, part of the academic team, could contact the teacher as well.
Okay, great. And another question is, what do I do if I'm interested in being on an advisory board? So basically, I want to get more involved with schools and maybe also want to do some more long-term strategic planning, workforce development, make sure that also in future years people come out of the school. How should I do that?
Yeah, this is a really good question because it's a really cool opportunity to get involved in schools. They call them industrial advisory boards usually, but any kind of advisory board at some high schools, a lot of colleges and universities allow, or they really seek industry professionals and technical professionals to come in and be a part of usually quarterly meetings, like a breakfast or a lunch where they talk about the program and student outcomes and really what you want to see students learning. So it's a really cool experience to be a part of developing the program and giving advice. Again, you kind of have to go through and see the schools around you, maybe a school locator tool opportunity, contact somebody like me who can get you in touch with a school that's near to you, or you may already know schools around you that you can contact directly, but yeah, we can certainly get you to a school, get you to the school directly, or get you in touch with a member of the academic team like me to contact the school directly.
Sounds great. Maybe to just, are there any other thoughts you might want to add?
Yeah, we've actually had some good questions in the chat going today as part of the digital chat. And a question from an instructor came in from Florida who said he's making all of his own curriculum. And he said, I'm creating this from scratch. I would love for more technical professionals, more industry advice into creating the curriculum, the projects, and what my students are learning. So we're going to talk to him a little bit more today and this week about how we can go online to the SCE website. There are lots of projects already loaded that are really cool that they're using specific industry examples and lots of industry relevant projects. So he can download curriculum for there in Word form, PowerPoint form, project form, all that kind of good stuff. But there are also lots of other links and tools from the Siemens website in general, from industry online support to our YouTube channel. So lots of ways to get into specific curriculum projects or just quick start things for students that would be helpful, like the YouTube channel. So yeah, we can certainly help you find either the SE homepage or other quick start guides for teachers to get started on curriculum.
Okay. Sounds great. Sounds really exciting. Lot of activities going on with schools. So hopefully we also get a lot of people joining the workforce, joining manufacturing.
Yeah, we hope so.
Yeah, but lots of things happening. Thank you so much.
Thank you.
With that, I'd like to close the Q&A for Siemens cooperates with schools, with education. And also, I'd like to thank everyone for joining our today's event and being part of it. Even though it's warm outside, everyone could also have done something else. Really being here, join us for our event, for our Siemens factory automation event. The platform itself will be live and will be online till end of June. So you still can come back and watch the content, watch the recordings. After today, it's possible to ask questions instead of in a chat. An email is sent to us, and we will answer all of these questions. And if somebody missed today's event and they still want to do it, they can go to usa.siemens.com/virtual tour, and they still can sign up for everything, and they can still look at it. So really use it. Thanks again for joining. Thanks for being part of it today. Thanks for asking the questions. Looking forward to engage with you. And yeah, looking forward also to the next event. And thanks to everyone here. Thanks to the whole team. Guys, great job. Thank you, everyone. Yeah. See you. Yeah. Thanks.
Thank you.
Okay, bye.
Thank you.